We have Dr. Sriram Venkatapati joining us virtually. Let me introduce Dr. Sriram quickly. Sriram Venkatapati, a senior scientist at Amazon's Alexa machine learning group, is an accomplished researcher with over 8 patents to his name. He completed his BTech and PhD at IIITH and pursued a joint PhD with University of Pennsylvania and CMU, specializing in natural language processing. Dr. Sriram's academic journey was shaped by his passion for research and teaching, having been involved in numerous research projects and mentorship activities at IIITH. He was also a part of the Xerox Research Center in France, where he worked with machine learning for document access and translation group. Sir, we welcome you.
Hi, Sriram. Can you hear us? See, I think you are on mute. Maybe we are not able to hear you.
I can hear you also. I can confirm that the voice is clear except Sriram's one.
Oh, okay. So, Sriram, if you are able to hear us, can you do a thumbs up? Okay. So we are not able to hear you. Kishore, are you able to hear Sriram?
No, I couldn't. I tried to say hello to him before we joined. I couldn't.
Oh, okay. So, Sriram, we see a mute button on your image. It's a pin button. Okay. No, he's able to hear us. Okay. In such a case, maybe before we can we ask Kishore to go first? Is that okay, Kishore?
Yeah, sure. I just wanted someone to give me the permissions to share my slides. That
Okay.
was only issue for me. Oh, I think someone gave me that. Okay, fantastic. Okay, give me 1 second. Should be able to do that. Hopefully, I'm not displaying anything I'm not supposed to be. Okay, can you guys see that?
Yes, we can see that.
Okay.
Yeah, please go ahead. And maybe in the meanwhile, maybe Sriram can fix his mic problem. Or okay,
sorry.
go ahead. And
Sorry.
maybe before that, please introduce.
That's okay. I don't need an introduction. Probably I can go ahead.
Yeah.
Shall I go ahead?
Dr. Kishore S. Prahlad is a key member of the Siri team at Apple, contributing to advancements in voice and speech technologies. Before joining Apple, he was an associate professor at the IIIT Hyderabad, where he played a pivotal role in pioneering speech research in LTRC. Over his 13-year tenure at IIIT, Dr. Kishore progressed through roles as a research scientist, senior research scientist, and assistant professor before becoming an associate professor. He led a dynamic team of researchers and students, significantly advancing the field of speech technology, specifically in Indian languages. Sir, we welcome you.
Thank you. Thanks a lot. I hope you can hear me and see my slides. Yes, no?
Yes, we can. Yes.
Okay, awesome. I don't know how much I can cover in 15 minutes, but I'll try my best. So let me thank everyone for being here. And also it's my pleasure and privilege to be here. And if if I have to be honest, I miss Triple IT being there. That's been probably, I miss my um, uh, days there. That's probably one of my best days. I still want to come back, but depends how it goes. Okay. So I just wanted to mention who am I. I am a proud husband to my wife Lavanya, and then my kids. Three amazing kids are there who are displayed here. So that's what I am at this point time. What else I am? I was a research scientist. Started in 2001. Rajiv Sangal recruited me. I worked closely with Dr. Deepthi and Dr. Vasu there. So it's been a fun 14 years for me, and I was probably a special recruit. I was did my PhD at the same time. At the same time, started my speech lab at LTRC in March 2001. So I graduated 3 PhD students, 12 master students, and then did tons of courses, programming and NLP courses. So whenever I'm in the Palo Alto area, so whenever I just stopped by one day to fill my gas, and then someone said, "Hello, how are you?" So I was so shy and hesitant. I couldn't remember because there have been so many undergrad students in the Bay Area. So sometimes I do often find someone saying hello to me. So that's because of mostly the programming courses I've taught in there. What do I do? I mean, I do tons of things. I like cooking, so a couple of my recipes, photos. So one of them is the banana stem curry. Other one is a pizza that I do bake sometimes. What else? What else I've done? As mentioned, like I have a PhD from Carnegie Mellon while I was still at faculty at IIIT Hyderabad. Did my master's in IT Madras, did engineering in computer science from Osman University, and so on. So why I'm here, I live in the Bay Area right now, but why I'm here? Mostly, I would say I'm following my passion to impact users' life and the quality to enhance the quality of life. That's been my passion. That's where I'm here, where I am at this point. What did I do? I mean, to get here, what was the activity that I did at IIIT Hyderabad, just to give a sense of it. So these are the couple of master students. You can see through a lot of speech and language technologies spread over there, ranging from artificial neural networks to voice conversion to speech synthesis and then screen readers and so on. So these are the couple of master students that I worked with and graduated them, and they're all here right now, pretty much in different places of the world. So it's been fun to see them grow in my life, and then that's been more satisfying to me. So that's something I did. What did I do again? So I have 3 PhD students graduated, Shivanand, Gautam, and Sapsibe. And then you can see both of them are at Apple. So you really would know what I'm doing at this point of time. So trying to get them into their successful path. That's one of the reasons why I'm here has been to garner most of the industry experience to bring back to the rest of the community as much as I can. What else I did? I mean, being a faculty there, just not easy to to go teach, do some research and everything. So it's been a lot of funding activity going on. So these are a couple of projects which kind of ranging from 2004 to 2015. So there are few more, but probably what they call as principal investigators. So that's what I did at IIIT Hyderabad when I was there. What did I really do? I mean, if you ask me, hey, this all seems good, but what did I really do? One of the things that I'm quite happy about or proud about is something like we built or co-founded Akshar Speech Technologies, which was based on some of the technologies that we built, what we call as Ravi. Vasu named it, and Rajiv Sangal was also quite instrumental. Raghavendra was the one who ran it as a co-founder as well. So this was one of our first screen reader for Indian languages, which really was proud and real impact. You could see, like, Buchibabu, who was one of our initial members, was visually challenged, used to come to office and listen to Keynote newspapers every day using our software. That's the most gratifying user impact that you could see even while he was there. At that time, he couldn't read Keynote newspaper. There was not possible at all technically, because there was no font converters. There's no such software at all. I'm talking about somewhere in around 2009 and 10 at the time. So we also built a lot of technologies, probably like, on device right now. People talk about a lot of on device. So we were probably one of the initial, very early on built on device speech technologies on computer. We built speech recognition systems for Indian languages, TTS for Indian languages, and spoken dialogue systems. So this is what did I really do? If you ask me, like, one of my satisfying thing has been, like, Venkatesh, I was the one who was taught programming course while he was in the class. So I have to read out every character that I write on the board, programming course. And then he worked with me and other cognitive professor in LTRC on the master's thesis, basically reading the mathematical equations using speech technology. So that was his thesis about. And then right now he's an assistant professor in the University of Michigan. Like, we do in touch often, but that's been. So if you ask me, like, what did I learn in the last 15 years? Focus on basic mission oriented, like, product oriented research, which is like pasture quadrant. That's something has been quite critical for me to align with the passion. And then, like, focus on user impact. That's one of the examples that what I highlighted here. That's been a huge learning for me. Like, the more and more we focus on quality of life and enhance the quality of life, that's something that's interesting. So I'll stop here. It's about 10 or 12 minutes. I wouldn't want to take much time, but that's what it is. That if you ask me the reflections in 10, 15 minutes for me.
Okay, thank you so much, Kishore. It was very nostalgic to hear your voice and then see you. I also remember all the great things that you have done and then continue to do. Thank you. And I now request Sriram, if he is available, if he is able to.
Can you hear me?
Yes, we can hear you. Okay, great.
Great. Yeah, apologies for the technical problem earlier. Let me share my slides now. Are you able to see my slide?
Yes, please.
Okay, great. Yeah, thanks for inviting me to present on my 10 years of reflections at IIIT. So I joined IIIT in 1999. I did my BTech honors with most of my projects in LTRC. After 2003, I continued with doing PhD. That continued till 2010, where I graduated. So I started at LTRC from the first summer, which is the end of first year BTech. So there was a list of summer projects that were advertised to us, and I was very excited to be able to join in one of the projects and make productive use of my summertime. So I picked up a project. Professor Sangal selected people who could take up projects because there were handful of projects. And so I was lucky to get this project on information extraction from resumes. So that was my first project at LTRC. So it was funded by Satyam. That was, I think, was funding the LTRC center at that particular time. So this was a project that had extreme value to Satyam at that particular time. So that's how I got involved in LTRC, and I didn't stop getting any less involved since then. Uh, so I think in this slide, I presented some of the key things that happened during my time at LTRC. And that kind of also aligns with the journey that the LTRC took over the years, where it started with predominantly rule-based systems. And eventually it graduated towards statistical and machine learning-based systems. Of course, I passed out of the institute before neural networks became predominantly being used. Between in 2001 and 2002, it was in BTech second year and third year. We got the opportunity to publish our first papers. It was Icon 2002, which I understand was the first edition of Icon. So it was wonderful to have that opportunity to publish our work that we were doing as BTech second year students to an NLP conference in India. And I believe that this is like one of the first computational linguistics and NLP conferences in India. So this was really exciting and privileged to be part of it. We also published another paper at ICUKL, which is International Conference of Universal Knowledge and Language. Dr. Pushpak Bhattacharya, he was very much involved as well. So we published a paper there. But a very major thing happened, which was there was a corpus-based NLP workshop that was organized by at AUKBC, and most of my peers in LTRC, we participated in that project, in that workshop. And this was a workshop that was organized by Professor Sangal, Dr. Arvind Joshi, Dr. Srinivas Bangalore, Dr. Anup Sarkar, Dr. Durgesh, also all the kind of stalwarts in NLP at that particular time. And as student, it was like really exciting and really formed a great impression on our minds. So that was a wonderful thing that had happened during 2001 and 2002, which also kind of introduced us to the state of art in NLP at that particular time. Then I also got experienced with example-based machine translation at that particular time. I graduated from BTech in honors in 2003, and my BTech honors project was on Shakti machine translation system, something that you might have heard. Yeah. Then I started PhD in a research exchange program with University of Pennsylvania in 2003. And we started looking at multi-word expressions. So multi-word expressions are like idioms, which are a very difficult case for machine translation, because you're not translating word to word. And so that was an important challenging problem that LTRC was working on, and Dr. Arvind Joshi, with whom who was going to be my mentor at UPenn, was also interested in multi-word expression. So that's what I took there. we published a couple of papers in 2004 on handling multi-word expressions in machine translation systems and recognizing multi-word expressions of verb-noun types during that particular period. Then we published another paper in 2005 on verb-noun collocations and so on. 2006, I also met Dr. Srinivas Bangalore in AT&T Labs and got introduced to global lexical selection. So we published a paper in 2007 on that. 2007, we also started under Professor Sangal's leadership, TCS NLP Winter School. And this was the first of the series of IAS NLP schools that you have. I believe even this year there was an IAS NLP school, summer school. So that was wonderful to kind of be participating in organization of that particular winter school. So that was really nice. We also did an NLP tools contest, sorry for the typo there, in 2008, where we provided data in like machine translation data, parallel corpus, and teams had to kind of build systems around that and present those at these tools contest. We also did lots of collaborations externally. One predominant collaboration was with SRI International on natural language generation. So that was an exciting project where computers had to the computer had to answer advanced placement type questions and so on. So these were, I mean, throughout these 10 years, I learned a lot at every step in LTRC. So it was a wonderful period. So I'll have some pictures to share about my journey at LTRC. So this was at 2001, 2002 about the corpus-based NLP workshop that was organized, where you see all the BTech students of who were doing projects in LTRC are seated behind Dr. Abdul Kalam and Dr. Arvind Joshi. And you can also see Professor Sangal, Dr. Srinivas Bangalore, Dr. Anup Sarkar. You can see Dr. Sushma Bendre from behind and Dr. Durgesh. And on the right, you can see the from the AU KBC campus where the LTRC team had visited. So this was an extremely wonderful conference. These are a couple of pictures from around the time where dependency tree bank was getting discussed. So Rashmi Prasad, who was a postdoc at UPenn, she was visiting and helping with that. I believe others like Dr. Srinivas Bangalore, Dr. Martha Palmer, others were also involved in this. So this was a time of extreme intensity. This was ICON 2005, where there was good participation from LTRC at the conference. You can see lots of familiar faces here. Yeah, and I remember Dr. Sangal had organized also a trip in Bitur. I think it was around Kanpur, and a boat ride in Ganga. That was like it's unforgettable and really nice. This is a slide where I'm showing the kinds of people who joined and presented in the TCS Winter School 2008, which is essentially IAS NLP 2000, the first series of IAS NLP. You can see Prof. Sangal, Samar, Deepti Ji, Dr. Shivaji Bandyopadhyay, Dr. Sudeshna Sarkar, Dr. Srinivas Bangalore, Gerard Huet, Dr. Ganesh Ramakrishnan, Philip Cohn, Sadao Kurohashi, Fesia, and so on, Dr. Arvind Joshi, Dr. Pushpak Bhattacharya. So this was like a very intense and very fruitful program that happened, and that has continued ever since till now. There's some pictures showing some of the fun times and the kind of rapport that all the LTRC folks shared over time, which made like working at LTRC so much fun over all these years. These are some other pictures from LTRC and folks who were there at that particular time. This was towards the end. So this is from left side is from a conference, and I think it was HLT NACL. Right side is after I had graduated, finished my PhD, and did a small celebration in the IIIT guest house. Yeah, so that's all I had to say about my life in LTRC over 10 years. Thank you.
Thank you so much, Sriram. So wonderful reflections of the whole journey. The pictures are great. Many of us actually now are able to recollect all those days. Thank you so much. Any questions? Maybe we have time for one or two questions to both of them.
Yep, sure. I'm happy to.
Yeah. Srinivas here.
Sriram, thank you so much. You took us down the memory lane, and it was very nice, like Vasu said, to see the pictures and relive those times. My question to both of you is that having spent time in the industry now, how do you think the preparation that you got here helped you in what you do today?
Kishore, do you want to go first?
Yeah, sure. As I said, like, it's about two things here. Right now, everyone is interested in machine learning. So more than the algorithms in which the academia is quite passionate about, I would say, like, focus on the problem and the data. And the LTRC has been propagating that philosophy, although to the deaf ears, to the most of the time, to most of the algorithmic people. So if you look at now, I think the data is the most important, and the data processing is most important. And the machine learning is becoming a kernel in the, like, in the way no one works on the OS kernel, right? So a couple of years down the line, that's going to be the issue. So what preparations you got is focus on the data, and the LTRC has been asking to focus, at least, like, I can give you a clear pointer. So I think around like 10 or something, 2010, I went to Rajiv's office and then said, what should we do, or something we discussed about. Then he said, why don't you ask the people to work on the Indian language data? So that's where we did some speech, Indian language text-to-speech data corpus collection, and then made the Blizzard challenge for the international people to come and then work on our data. That way, like, when someone works on your data, the feel of the algorithms automatically. So the data is the entry point, and that will be the key lesson that I think, if you ask me, what the students should still, and the faculty as well.
Thank you, Sriram.
So I remember one of the, during my BTech, we were working on example-based machine translation, and we were like meeting every day to discuss what kind of a modeling approach we should take, what should be the details, nitty-gritty details of the data, and so on. And every day, Professor Sangal, Dr. Sushma Bendre, and Vamshi, who was there in the project with me. We used to discuss with such intensity every day. I mean, so you kind of really got the feel of how research works. I mean, what kind of dedication and effort and passion it requires. I think that kind of sowed some of the seeds which are even helping now, especially in a scenario where things are changing so rapidly. So some of that passion and intensity really helps in adapting to change and succeeding. Yeah.
Yeah, one very quick question here. How do you relate the current trend of data and theory and the past earlier emphasis on theory? What do you think is should be done as we move forward, and particularly in education? Short answers.
Focus on the data quality.
Okay. Sriram, you would like to say?
Yeah, I think the data is the secret recipe in all these models, and the scale of the data also is something that we should focus on.
So later we have a session on linguistics, role of linguistics today, but it may be a little late for you people at night. But anyway, thank you. Recordings will be there, of course. Yeah. Yeah. So thank you. We'll have now the next session. And
Thanks,
it was very...
You can stay on for the next session.
Yeah, you can stay on. Yeah.
You could have flown us both of. I don't know where Sriram is, but you could have flown us. I would have come. Yeah. Thank you.
Okay. Our next session is addressed by Professor Vijay Raghavan. He's online. If you can show him. He's able to listen to us, I assume?
Yeah, I can listen to you.
Hello, Joey. Yeah.
Hi, how are you?
Professor Vijay Raghavan is a distinguished biologist and former principal scientific advisor to the Government of India, also the chairman of the Prime Minister's Council for Science, Technology and Innovation. He graduated in chemical engineering from IIT Kanpur and earned his PhD in molecular biology from Tata Institute of Fundamental Research, conducted research at the California Institute of Technology before joining TIFR. Professor Vijay Raghavan played a key role in establishing the National Center for Biological Sciences at Bengaluru, where he served as director and is now Professor Emeritus. His research focuses on the development of the nervous system and muscles and their role in locomotion. He also served as secretary of the Department of Biotechnology, Government of India, where he played a leadership role in shaping the policy and implementation of the policy in the country. His leadership has greatly advanced biological research and policy in India. Should also mention that we studied together in IIT Kanpur. So he's an engineer who became a biologist. And as his BTech project in chemical engineering, he built a heart-lung machine. Can you believe this? This is in 1975, 74, 75. So it's great to have you, Vijay. And
Thank you.
We have requested him to talk about the Bhashini, the initiation of Bhashini, what were the thought processes, and where does he think we stand today, and any words of advice. Yeah, thank you.
Thank you very much, Rajiv. It's a great honor to be here. I really wish that I could be there in person because this seems like such an exciting meeting. And, it's also a very important meeting. The reason, I mean, the last part of what Rajiv said about advice, I'll skip because I will probably have that permeating through what I have to say, but don't take that part very seriously. But there are other components which we must keep in mind. And we must keep that in mind in a situation where there are, literally exponential changes in technologies to understand, translate, and use languages in a variety of contexts. And this is just going to explode even more. There's no doubt about that. But that said, there are some fundamentals which remain and which need to be addressed constantly. What are those fundamentals? And what are those fundamentals for a country of the size of India? Those are the issues which we need to do. Now, let me step back a little bit to the time when, there's been a discussion about English being critically important for India to find a legitimate place at the time of globalization. Now, there are two arguments about English in India. One, that it is needed, it's a global language and it is needed. And the second is that it is a language which is a glue across the country, as opposed to, say, Hindi, which will have tensions and acceptance in some places. And English, because it belongs to no one, can be argued to belong to everyone. Now, both these arguments, might have their points, but they're overall specious. Let me take the first argument. English indeed is the dominant language in the world today, as was German some time back, or Farsi some time earlier, or other languages of the court in countries, in large regions, and so on and so forth. That will always be there, and one has to adapt to that and deal with that. There is no question about it. But the language of the court, the language of commerce, and the dominant language of exchange can never be your national language completely. It can be a language which everyone understands and knows and is useful, but it cannot replace your mother tongue. Because for a variety of obvious reasons, but I will not go into that in depth, the ability to converse in the language you learn as you grow up is something which allows you to have the power of abstraction, conceptualization, and cultural nuance in a manner where a language which you learn as an adult will not readily be able to have. So there are always exceptions to this, but in general, that would be a problem. In this context, we all know, and I'll just reiterate briefly, that there are countries in Europe, for example, if you take Sweden, the Swedes learn Swedish, but they also learn English. The Chinese learn Chinese. They may or may not learn English later on. It's a huge country. There'll be some who learn and others who don't, and so on and so forth. This can go. So, in other words, in terms of education, the primary cultural mooring needs to be in your native language. And that poses a challenge in India. While we can be bilingual and learn English also or Hindi also, that poses an enormous challenge on how to do this. Now, let me go to the next component, which is about why this is valuable, and come back to how to do this. The next issue is about excluding people from the workforce. Many have argued, many eminent people have argued, that if you know English, it opens a door to the workforce. And therefore, look at the way people, if they have a choice between going to an English medium school or a Kannada school, no matter how poor they are, they will go to the English medium school because they see economic opportunities there. Now, this is given as a reason why education should be in English. The problem in this is when you're talking about a country of 1.4 billion, language becomes the weapon of exclusion rather than the weapon of inclusion. We are never going to have a situation where we can adopt with fluency a language such as English across the country without completely eliminating our cultural moorings in our own languages. Now, that has a great danger if we manage to do that. And colonialism has managed to do that in two different large contexts. One, in Latin America, it did that by not only eliminating the languages, but eliminating people. And therefore, you have largely Spanish or Portuguese in Brazil, in Latin America. And you have people who are now, those have become their mother tongue. In Africa, in Anglophone Africa or in Francophone Africa, you have large countries where across the spectrum, you have people replacing their native tongues right from the beginning with English. Now that has resulted in, certainly a few extraordinary African writers in English, but as a population, the ownership of the language has not yet seeped in, and that poses an enormous challenge. So in Latin America, you do have, people who have written exquisitely in Spanish, are deeply imbibed in Spanish, but that has come by eliminating the people, by eliminating indigenous people effectively. But in Africa, the adoption of English or French has not resulted in the presence of large communities in the global place or in the national level in terms of self-confidence and assertion. So it will not work out in India either to have that replaced, and that should not be a goal which we set ourselves. Our goal should therefore be that opportunities are available for everyone to be bi or trilingual, and that is not such a big problem to solve, and it has been solved in many countries, many European countries. The Dutch, for example, speak at least 2 or 3 languages, including English. So do the Swiss, and they do it fluently, and they can manage. So that's what we need to do. But let me go on to the next point, which pointing to a particular kind of, I should say, hurdle, which I see in our conceptualization when we want to do this. This ability to use one's own language as well as English seamlessly, if that is there, it requires the availability of translations in both directions or in multiple directions into all these languages. The problem today is that the availability of technology allows this to happen with speed in broadly still, and this will change dramatically, what I would call transliteration. And it can be done even more effectively in technical areas, but in cultural areas, this still poses a challenge. And even in science, it poses a challenge. So when Charles Darwin writes The Origin of Species, and that, by the way, is an example of a deep revolutionary scientific discovery which is communicated to lay people as well as scientific expertise in the same text. That kind of a nuance in communication and an ability to put several hundred pages of work into this in a readable manner, if you want to appreciate every aspect of it, that requires sophisticated translation, which has been done in many languages. Similarly, if you want to translate Kalidasa, or you want to translate the Ramayana or the Mahabharata, or any ancient Indian text, or Shakespeare for that matter, into Indian languages, it requires scholarship. The problem is that still now models of computational approach to these problems do not yet have scholarship. Will they have scholarship is therefore the final question which we need to answer. Will they ever have scholarship? Now that's a debate, and you can argue that if you have artificial general intelligence, you will also have scholarship, creativity, abstraction capacity, and so on and so forth. And that may or may not happen, and that debate is a separate matter. But the fact is that we don't have scholarship now. And given the diversity of Indian languages, we need scholarship in a bi-trilingual manner in this situation. Hello? Yeah, can you hear me now?
Yeah, we can hear you loud and clear.
Yeah, it was just hung for a second. So therefore, the simple matter is, going forward, how do we have a situation where we can amplify this scholarship? This is the biggest danger we have, in a manner similar to the disappearance of indigenous people in South America. in a manner similar to the disappearance of indigenous languages in Africa, indigenous languages are disappearing in India in a substantial manner. Both the major languages as well as the smaller ones are in great threat for a variety of reasons. Again, we can discuss that separately, but I don't have time to go into that now. So what we need is a spurring of translation. Now, translation, unfortunately, has meant, in a positive way, it has meant only the limitation of literature. And that's very important. We must keep in mind that literature is the crucible of creativity, of thought, of knowledge, and the use of language in this context is what makes us human and distinct from other animals which have substantial communication, but they don't have language of the kind which we have. So if you want to distinguish between communication and language, then this pool of translation and scholarship needs to grow substantially. And it has to grow beyond literature alone. It has to go into architecture, science, communication, technology in a manner where, it makes sense to the reader without getting, technical or in a manner which doesn't appeal. This is very limited in India today. In principle, every single institution in the country, whether it is a university or research institution or a college, should have scholarship in these kinds of areas. The fact of the matter is that whatever scholarship there was in our university system some time back in both languages as well as in translation and linguistics, that is gravely diminished, and this is a serious problem. The kind of investment which is needed to push this is modest, but given the range of challenges and problems the governments of the day have, this is not going to become a top priority because this is a priority for the country going forward in a 10, 20, 50, 100-year period. Governments are more concerned with immediate problems of flood, health, infrastructure, and so on and so forth. So a long-term mechanism of investment is not likely to come top-down alone. Top-down is needed. It will also need to happen bottom-up. That bottom-up requires both talent, commitment, as well as support. Support is actually least of the problems. There'll be multiple sources where we can get support. But it's important that in a manner similar to what people such as Rajiv Sangal started first at IIT Kanpur, then at IIIT, and all of you have taken the lead on that. We need a next generation driving scholarship in addition to the technology component. That means we need resources for having both part-time and full-time quality people who know their languages and who can translate really well. And that is something which is absolutely critical for us to do if we are to imbibe the culture of our heritage and of global heritage and have that available to everyone so that each part of our country, its culture and its nuances can go not only for the development of its people, but also be available to the rest of the world. Thank you.
Thank you. Can we take a couple of questions?
Certainly.
Yeah.
By the way, I should say that not having attended the previous sessions and not being able to attend the next ones, I might have said something which is completely redundant and useless, but excuse me for that.
No. I think what you have said is talked about the larger canvas. We were more focused on technology, as you might expect, but larger focus is and larger view is extremely important in the country, what needs to be done. Yeah. Yes, Dr. Srinivas from Interactions and AT&T earlier.
Thank you, sir. It was even though a short talk, it was very engaging. You posed certain challenges. Just as a matter of context so that you know my background. I teach a course on translation at Princeton University. I was Dr. Sangal's student at IIT Kanpur. I had the fortunate opportunity to be in the initial stages of IIIT Hyderabad here. What engaged me in your short speech was that the challenge that you said about preserving culture through translation and having the ability to reach out to the masses, so to speak. And the challenge that I find is that technology, and which you alluded to, is that the technology is transliteration, not really translation, which I agree with you. The question for you is, even human beings who translate don't necessarily capture all the cultural nuances. And that's the reason why we have so many versions of any epics. Even the Bible is translated in many, many languages, many times over. So how do you see technology play a role in such a challenging task when humans can't do it themselves to capture all the nuances of the culture?
Yeah, I mean, your question is thank you very much, Srinivas. Your question is a very important one, and that, is a constant challenge of dealing with scale and quality. If you don't have to worry about scale, you can answer this question by focusing on a particular text and having, say, 10 different translations of the Mahabharata or 20 different translations of War and Peace, and seeing how, different people appreciate that. And indeed, 20 different versions of epics. So that's possible if there's depth without the worry of scale. The true essence of scholarship is really that, you have depth without worrying of scale. But the problem which you addressed is an important one. Knowledge today, and including cultural knowledge and understanding, means more than ever before. It always meant it. More than ever before, knowledge is power. And the absence of this kind of nuanced knowledge to larger communities means that they're increasingly going to be divorced from power. So how can one scale is your question. Sorry for that long point there. My feeling is that the question, therefore, can be moved to scaling of scholarship in translation across areas. That a combination of technology and individual abilities in terms of training can do that. So we must embrace technology for this, have first pass of various kinds, and have collective effort at doing that. These kinds of collective ways of nuanced translation are today more feasible, and that's something we can do. So far, scholarship has been substantially an individual exercise. That can remain, but that's not sufficient anymore.
I can have Dr. Professor Pushpak Bhattacharya, IIT Bombay.
Hello, good morning, and very insightful statements. So my question is, what trajectory should natural language processing language technology take in terms of its ideal? Should it be the path that physics has taken versus the path that biology has taken? These two paths are very different.
Well, I mean, let me sort of make a guess in the interest of time what you mean by the way paths physics have taken and biology have taken. I suppose you mean not the study of physics and biology, but by biology itself as distinct from physics. Physics, you can make generalizations which are applicable across scale, or at least at some scales, whereas biology, those generalizations are require, in addition, a detailing in every context. It's more a combination of exploration. It's more searching for algorithms in each case rather than laws, right? That's the point in biology. So I think, yeah, it's very beautifully put what you said. Now, in that situation, I think translation is substantially of this kind, which I'm talking about, needs to be more algorithmic, but also, at this stage at least, substantially interacting with humans. So my suggestion, which I think IIT Kanpur, by the way, had that at its early stages, where humanities, social science, linguistics, and engineering were all together. And many people not only did benefit from that locally, but went on with a cultural attitude of the importance of humanities and social sciences and engineering. That importance, if it can be brought back to our engineering institutions, including triple ITO on scale, by having people who have scholarships in these kinds of areas, would be very valuable. Because this algorithmic deciphering requires a substantial bottom-up citizens and scholarship effort, which is an ongoing process which will never end.
I had a quick question if there are. Yeah, no other. Oh, there is one more. Yeah. Arafat Hassan,
Thank
PhD
you.
student and worked in industry.
So thanks a lot. The talk that you gave really jives with me, because one of the things that I think is happening in the field is that we often miss the forest for the trees. When we are talking about the amount of data that we have translated, we count them in words and not really the books that we translate, right? So the output is measured in terms of 1 million corpus or a 2 billion corpus that has been translated. And it is, like you rightly pointed out, like probably a 2-decade task to build this ecosystem. What, in your opinion, are the incentives that currently exist or should be put for young researchers or the researchers in the field, so that there is some incentive for them to actually put forth their work in translations, technical works in science and engineering? Is there like a program or something that you have in mind, or that encourages them to contribute in other languages as well, apart from the language that they're working on, which is English primarily?
So I must stress that there's been thank you very much, Rafat. A very important question. So I must stress that there's been a dramatic change in employability of people who are expert in these sectors in the last few years. And therefore, if you look at it from the crude value of the marketplace, the ability to take high quality data from your socio-cultural points and become a top scholar and be able to translate that is hugely monetizable. In other words, in a class of, let's say, 30 people who do these kinds of things every year, who are trained rigorously in some region, in some language, and being able to look at multiple aspects of it, I would bet that 25 would go on to become, extremely well-to-do people in the finance sector and markets and tech companies and so on, who will value this. And the other 5 will be scholars who, generate more scholars. This is what has happened, for example, in areas such as astronomy and astrophysics, pure mathematics, and even, politics and economics in the West. So today's world requires, whether you're a hedge fund operator or a big tech company, these kinds of people in large numbers at the back end and even at the front end. So I see enormous opportunity, and I see enormous inability of our being able to convey this. And that's partly because of the nature of our markets. If you look at markets in the West, people take up these kinds of courses with rigor and end up doing all sorts of things later on. That flexibility is there. And I think with the new national education policy, in principle, that flexibility we also have. But as our markets develop, as our economy internally grows, we are going to find more value for these kinds of scholarship.
I had a quick question. I'm told now the time is getting up. The the issue of learning as utilitarian versus scholarship. I'm so happy that you brought the issue of scholarship, and the joy that you have in scholarship and pursuing it is today getting undermined, not being realized by our young people. It's become a utilitarian race towards what that also is not very clear to our people. As the salaries rise, they say, no, we want more. And it is, somebody getting into depression because he only got a 30 lakh rupee per year job when his other friends got more than him or her. Do you have any suggestion about what can be done at the national level, at the college level, at university level, to bring us back towards scholarship and the joy that one gets out of it?
One of the good things about India still is across the spectrum, politicians to tech billionaires, when they interact with scholarship, there is a respect. The problem is that a large section of our people are not exposed to the opportunities of scholarship sufficiently. And of course, part of it is economic, about need for getting jobs and therefore being utilitarian. But remember, I'll give you an example, and I know we're running out of time. And this is not necessarily entirely a happy example in terms of outcomes, but the entire Second World War and post Second World War physics in the US substantially was shaped by 5 Hungarians who, most of them were chemical engineers who went on to become physicists. They were from Jewish families in Hungary, Teller, von Neumann, von Karman, and so on, Leo Szilard. These people were sent to be chemical engineers by their Jewish fathers and mothers because that's where jobs were. They were subversive, they disobeyed their parents and took to scholarship. So in other words, what I'm trying to say is there's earnestness with which people want scholarships. And some of these were from rich families, others were from poor families. So the earnestness to take up scholarship will always be there in a significant small fraction of the population, despite everything else. What has changed in the world today is the lure of opportunities for all and wealth for all has minimized this fractional, small fraction attraction to scholarship. That must change. Last point I'd like to make, Bill Gates supposedly said, I don't know whether it's true, it's an apocryphal statement, that you can be as rich as you want, but ultimately hamburger is a hamburger. You can't make it better beyond a certain point. So access which you get as a consequence of wealth plateaus dramatically. That needs to be imbibed. And really, it's our institutions which should encourage and nurture this small fraction for scholarship because they will be appreciated by others who take on other kinds of jobs. Most people will not go into scholarship, but cultural appreciation of scholarship needs to come back. There is a disdain for that globally now, as if what point is there in studying history or languages or music or how the tabla works and the different kinds of tabla. These are critically important for our meaning in our societies.
Thank you. Thank you. Thank you very much. Really
Thank you very much.
Yeah.
Pleasure and all the best. And I wish I was there.
Yeah. Okay.
Thank you, Professor Sangal. Next, we have a talk on overcoming LLM's limitations with agenetic workflow by Mr. Harshit Surana. And I kindly request Professor Chiranjeevi to introduce our speaker.
Hello, everyone. Good morning. So today we have many pre-trained models in speech, text, and vision, right? So can these models directly deployable? Are any practical aspects do you consider? So the coming 2 talks is about dealing the practical aspects in industry scenario. The first talk is from Harshit Surana. He is a research scientist at Alien AI, and he is a co-founder of 2 companies like Deepflex and Kavos Genius. And he did his graduation studies from CMU in NLP area. And before that, he has a small connection with the LTRC. He did his undergraduate thesis here. So I'm requesting Harshit to give a talk. Thank you. Does the clicker work? Can you guys hear me fine? Okay. So hi, I'm Harshit. I'll be talking about overcoming LLM limitations with the agentic workflow. And yeah. Yeah, so I just first wanted to thank
some of my colleagues who have been part of this research. So Bodhi, who's also the co-author of the book, and Peter, we are sort of co-leading the project. And then Chris and Grace, who are at the right side, they are helping us with the biology. So all the biological labs in Seattle Hub for Synthetic Biology, and Allen Institute for Neuroscience. Also from CMU, Graham Newbeck, who we are collaborating on with code generation. So we'll talk about code generation, the use of agents in code generation and software engineering a little later. But before I do that, this is something I couldn't say yesterday was I started my NLP and I learned about NLP and research at IIIT. I learned about combining rule-based systems and statistical systems. Here, I learned it from Deepti ma'am, I learned it from Sangal sir, I learned it from Anil sir. So yeah, thanks a lot. So yeah. Yeah, so we all agree that LLMs have revolutionized NLP, but they often fall short in key areas. And I think all of us would agree with that. Where do you guys feel that, what are the areas where you feel that NLP has, or the LLMs have failed, right? Well, we discussed about hallucinations earlier, but what are the key areas would you feel when you use ChatGPT or use Gemini or Claude, that they can't do something that you want them to do? So I'll just wait for a minute, and if there are any answers from the audience. Hallucination is one. Is there anything else? Okay. Sorry, yes. Yes, exactly. Right. Right. Yes. And so essentially it cannot follow a complex task because, yeah. So yeah, so what he was mentioning is that, a lot of code or a lot of text is generated and you want to change a small part of it, and that cannot be easily changed, right? Because it changes everything and it doesn't change what you asked it to do, right? And that is essentially an example of a complex task. So we cover a bunch of these problems that LLM limitations have for advanced tasks. Hallucination is one, but we also have LLMs are opaque. You don't really know what's happening inside. They often have limited context. Even the larger models, which have 2 million window, they also have pretty limited context. If you look at monorepos, which have tens or 20 million lines of code, which is quite common in a large industrial setting, they often also have poor adaptability of out of distribution domain and tasks. They work well, when something is part of their pre-training. They don't work otherwise. And obviously, they lose memory over longer context, non-trivial to verify, and cannot integrate into specific user workflows. Anything else that you guys want to talk about that this list doesn't cover? Okay. Yes, reasoning, and I bring that up. Yes, that's a very important point. The one key thing whenever you talk to anyone in industry or anyone in academia and they want to use it is, hey, this is a cool demo. How do I use it? Right? This is a very common pattern that we see whenever companies are adopting LLMs, and at times research groups are adopting LLMs, right? So how can we tackle this, right? So I'll talk of a simple example. This is an example which is sort of inspired from one of Andrew Ng's slide. And this is the example where you either look at non-agentic workflow. Imagine you're generating NLP code, and there are two ways to generate that code. You generate this code by saying something like, write a Python script that uses the Hugging Face model for sentiment analysis given a bio data set. Please type out the code in one go without waiting or even using a backspace, right? So this is how a default ChatGPT works. But this is not how we as human beings program, right? But by default, whenever you're using ChatGPT, and I think the person who asked the question, this is, when we give a prompt, we are essentially asking the model to behave in this manner. What really works is agentic workflow. What really works is how you would solve that problem, which as an example is you will, in this NLP code problem, you'll first define the problem in a certain manner. You'll talk to domain experts, like this is the bio domain, so you'll talk to doctors or clinical data scientists, and then you will start with a baseline. You'll start with a baseline model and then you'll iterate, you'll have bugs and you'll fix and so on and so forth, right? So you revise your code, you research, go outside in the world, talk to people or search on the browser, and you debug your code, right? So that's something that is just missing in the single shot example that I gave earlier of of NLP code in bio domain. And how can we solve that? What are the solutions, right? And these are these agentic design patterns. We'll briefly talk about these agentic design patterns, and then talk and give 2 concrete examples from our work on how they helped in different use cases, right? So one of the design patterns is reflection. We want to reflect, just like we reflect as human beings, we want agents to reflect. The other design pattern is tool use. It's important to use tools. Agents by default don't have access to tools. Planning is something that PJ and sir, you mentioned. So planning and reasoning are linked. And also multi-agent collaborate. We work better when we work together. So the first one is reflection. I cannot read this very well. Maybe I'll have to turn back. No, I cannot. Maybe I haven't updated my eyesight, but yes. So reflection is the first one. So what we essentially want is you verify and reflect the LLM outputs either by some external feedback, or external feedback could be something like a unit test, or by some other LLMs or those LLMs itself, right? So use the reflection to iterate the results, right? So given even the example that the person asked that, hey, I have a lot of code, I asked it to change, and I don't know if it worked or not, right? LLM also doesn't know whether that specific change worked or not, unless it passes through a unit test and the unit test tells that it failed. Now, once you have that information and you convey that information back to the LLM and you have a loop, then LLM will often generate a much better answer. So there are different models for that. One is self-refine, which came out of our group and a bunch of collaborations with CMU, Google, NVIDIA. And then reflection is an even more popular one, which uses the structure of structured unit tests to iterate all kinds of code generation. Tool uses another LLMs by default. They don't have access to tools. It becomes much better when you give tool usage to LLMs. Even when you're asking ChatGPT to generate a particular code, or if you're writing a paper, you're asking ChatGPT to write certain parts, it's not aware of the literature, or it's not aware of the coding environment, as an example, right? So it's important for these models to be connected to browsers, APIs, code execution. Custom code is something that we have seen it being important, because often LLMs are also not very good at generating very domain-specific code in a very narrow domain of science, or a very specific or a narrow domain of systems engineering, right? And search engine and so on, right? So AppWorld is one example where we're building this benchmark. And this is how this general function calling happens. So now a good proportion of LLMs do support function calling. Not everyone does, but even for the LLMs that don't support function calling, there are ways to sort of have them emulate function calling without proper function calling. Right? So this is the tool use. Planning and reasoning is what was also mentioned. So planning, right now, when you ask an agent to do something, ask LLMs to do something, they don't have a plan of what they want to do, and they do things from start to finish. But the results get much better when there's like a task ledger. It has a list of things it wants to do, and it's keeping a track of them, and based on that information and more user prompt, it's able to reason over them and change their plan. So AutoGen is like a popular framework from Microsoft that is used for multi-agent collaboration, and AutoGen recently released Magento, in which they were having a lot more planning and having task ledgers and process ledgers and so on. Right. And then the best part is things work generally well when a lot of people work together and they collaborate. That's the point of research. That is what we discussed in this talk as well. And this is multi-agent collaboration, right? So here you have the example of ChatDev, which was by Tsinghua University. It was, I think, in ACL 2024. And the colors don't render well, but essentially in this example, imagine you are like running a software company and you give a high level task, but you have different departments like designing, coding, testing, documenting, and these different agents all work together. And in chat dev, it's also somewhat visual, and they help you get an answer to a particular problem, right? So these multi-agent collab by itself doesn't work perfectly, but these are these broad design patterns. And when you apply these design patterns for a particular problem, well, then you start getting much more better results. Right? This is another example from our group, and this was in ICML 2024, and this is around data-driven discovery. So we have these 4 different agents, which is like a planner, a data expert, a programmer, and a critic. When they all work together along with some agents, memory, and access to literature, external literature, then they're able to do much better with scientific discovery, both for NLP as well as biology. And so I'll probably pause there. I've covered these 4 design patterns, and if there are any questions that you have around these design patterns before we go to 2 concrete examples. Cool. So let's deep dive. Sorry.
I have a question.
Yeah.
So let's say that in a dialogue, let's say that this is a customer support dialogue chatbot. User has 2 goals to get the answer from the customer support, and
user has 2 goals.
Let's say that he has 2 questions. For example, for example, insurance chatbot. Okay. And first question is like, you want to know the status of the amount of the premium. And second thing is like, how many days, how many more years he wants to pay.
Right.
Okay. This happens in the series of dialogue turns.
Sure.
Okay. When the dialogue switch happens, I mean like from the first question to the second question, if the goal has changed, user goal has changed, the identification of the goal switch is a major challenge.
Yes, it is.
Yeah,
and that's why keeping a track of goals can be super helpful, right? Keeping a track and also updating them.
Okay.
Right.
That's what I mean. How I'm wondering how this can be solved.
So you sort of have a task. You sort of have a task ledger. In your case, it will be like a goal ledger. And every time a user asks a query, you'll figure out whether that's a concrete goal in the list of your defined goals or not. And if it is, you'll keep adding more to this goal ledger. This goal ledger will go along with the other things as a context to your LLM call, right? So the goal ledger always is there because LLM needs to know what has happened and what has not happened. And then you have another call where you identify what all goals have been met and if any new goals have been added. New goals could be added either by LLM output, because LLM may figure out, hey, your policy has these issues that may lead to some other new goals, right? Our LLM goals can happen by the user query as well.
Okay, but we are adding.
Sorry. Sure. Okay. Yeah. Okay. So I'll just pause, and I have anyhow kept a lot of slides which are deep dive, which I don't know if we'll have time to go into. So, but yeah, I'll probably complete these 2 concrete examples, right? So the first one is software engineering with LLMs, and software engineering is not just code generation, is not just coding, as we all know. So there's this work by OpenHands, like it's like one of the most popular LLM repos. It was by CMU, UIUC, and now there's a research. There's a startup as part of it. And what they do is, I don't think we can read their overall structure very well, but essentially, unlike coding on ChatGPT, where you don't have the environment, here you have the full coding environment. You also have access to different agents like browsers, but also agents which would work well on a particular part of, say, code editing or data science. They also have access to runtime and various tools, and you can plug different LLMs. As you may have seen, certain LLMs work better for certain use cases. So optimize for both performance and cost is something that could be done if you have pluggable LLMs. And generally, it's like a top repo, 37,000 stars on GitHub, right? But how do we know it works well? We need a benchmark. Without benchmark, we can't really qualify if these things work well. So there's a benchmark by Princeton called SWE-bench, and it has become like super popular. What they essentially did is scraped a lot of PRs from out on GitHub. They added some filters to it, make sure that there is a test, because otherwise, how would you verify that that a particular code generated works, right? So they made sure that there's some test, and those tests contribute to a code resolution. And this laid a foundation for a lot of software engineering related both agents as well as startups. But there's an issue with SWE-bench, and what the issue with SWE-bench is not everything is verified. So all the information that is provided in a GitHub ticket, that's not enough. That's not enough to solve, and I think it's showing different distributions. I'm not sure if we can see the colors, but essentially what I would say is that because SWE-bench had a bunch of issues, SWE-bench, OpenAI took SWE-bench and they made SWE-bench verified, which is that they had like 90 plus software engineers, and they looked over like some 1,500 samples and figured out the samples in SWE-bench that really work and that are completely constrained, right? So they can solve a particular task just with that information, and we have a fully verifiable way to know that the problem is not underspecified, or all the information is there to make sure that it will be passed. Right, so this is called SWE-bench verified. Now, this is the most popular benchmark for coding in real-world software engineering challenges, and people run it on open hands with their code act agent. And as you can see, these are slightly different models, but broadly, from a score of 7, the latest open hands agent with a slightly better Claude model had a performance of 53. So open hand is the first agent to cross 50 in SWE-bench verified. And what did they do for that, right? So first of all, one thing they included is task planning. As a software engineer, you do a lot of task planning, and they're telling me I have a minute. I'll probably take 2. But you need a lot of task planning. You need ability to traverse directories, and they also added function calling. So very quickly, we also are contributing to Open Hands. It's a great contribution. It's a great place to contribute to. We are contributing on the evals side and the data science agent side, and it's just a very heavily growing repo. I'll take a quick detour on say scientific discovery. It will take just a minute, and there are 3 broad methods of scientific inquiry. One is theoretical science, where you develop theories. There's experimental science, or there's observational science, right? And what we are focusing for the second concrete example is observational science, which is the data is already there. You don't need to develop new theorems, or you don't need to run more experiments. But there are data sets like the US Bureau's National Longitudinal Study or Nurses Health Study, which has led to like tremendous science. A lot of medical innovations we use every day came out of these large longitudinal studies. And essentially, we use that for data-driven discovery. I will have to rush through data-driven discovery, but essentially, we use the agentic system along with a bunch of other things like memory and planning over it. And it ended up having pretty good results. And in fact, this was a position paper. It sort of started with a renaissance on scientific discovery with a focus on data. Now, I think there are half a dozen benchmarks related to data-driven discovery. I'll skip through all of this for now. Just the last thing is that all of the stuff that I showed around data-driven discovery is part of the broader vision that we have, is like a research agent that can do data analysis, but can also do search, can synthesize literature, can find hypothesis or generate hypothesis, and then can plan an experiment and execute it, right? So this is called NORA. And all the agentic workflow, agentic patterns that you saw in the earlier presentation, they are all applied there. And I'll end with one leading question. All these patterns that you saw here work well if you have limited data, but on an industry scale, when you have petabytes of data, or you have millions of lines of code, then a lot of these patterns may not also directly translate, but they still somewhat hold. And we can probably discuss offline on how to make sure that work well at that scale. So that is pretty much it. So yeah, thank you.
Yeah, thank you, Arshit. So, interest of time, we can go to the next talk. Meantime, and during the break, you can interact with the Arshit.
Okay. Thank you.
So next talk is about so we have good AI systems. Let's assume that how can we deploy those AI systems for better ROIs, return on investments. So the talk is from Anuj Gupta. He is an alumnus from our institute. He is a he did his Master of Science research in theoretical computer science here. And he is a co-founder of Gradient Advisors. So I'm requesting Anuj to take the talk.
Sure. Thank you. Am I audible? Okay. I am aware of the fact that we are already running late, so I'll be quick. Okay. Just one call out. Most of you work in NLP trying to push the boundaries of the system. A large part of my work owing to early stage startups ended up being how do you build systems that lead to large business outcomes? Some of my work has led to acquisitions, funding rounds, even in IPO, right? So I'm going to give a perspective of how do you go about some of these challenges, right? If you look at today, AI in general, last 3 years, right, the whole scene has exploded. A lot of startups have come up. I don't think so there's any company out there that is not doing ROI, AI, but there is one central problem to all of this. Where is the return on investment, right? A lot of money is being pumped in on the top, talent, data, compute, and all of that stuff. But it's only a handful of these companies that have seen any outcome, a business outcome. While this might not be a question for an academic institute, but for an industry, it's a very central question because by the very nature, it is the profit and loss that matters. You can build the greatest system, but if it doesn't move the business outcomes, it's a liability. If you were to ask me what's the central issue and summarize this in one picture, I would put it as this, right? A lot of teams are trying to do AI purely on the basis of model, ignoring a lot of other fundamental stuff that is often needed, right? One of them is right use case. Are we solving the right problem itself, right? And a part of this talk is going to be about how do you identify use cases that are likely to lead to large business outcomes. So if you are somebody involved in building AI ventures, then this would interest you, right? A lot of these learnings are generic in nature, can be applied to vision, speech, data science. Towards the end, I'm going to tie all of this to the NLP because that's the group here, where I'm going to bring out a counterintuitive insight on one of the most popular use cases of NLP in industry, right? Okay, we're going to skip this. If you look at today, ask anybody where AI, Gen AI can be applied, people will give you a list of applications where it can be done. Probably given my background in theory and large part of my work in theory was around generalization, we have tried to create a framework by which you can take a use case and say, is this a good use case when applied this framework if you're trying to build an AI venture, right? So that is what it answers. Is this a good use case when you're trying to build an AI venture? Okay. Now, we all understand that in a traditional software, when you're trying to build ventures, people typically go for applications which have high impact, low competition, and low effort, right? But these three parameters are not good enough when you're trying to understand AI use cases. What we have done is we have added a couple of more parameters to this particular framework, right? One is that traditional engineering, which is fairly natural to the people out here, right? If a problem can be solved using traditional engineering approaches, you should absolutely do that, right? In a lot of cases that I have seen in my journey, people are trying to apply AI where it is not even needed, right? So that's the fourth obvious point, right? The fifth point I'm going to come is when you're trying to solve a problem, you have just the right algorithm to be able to solve the problem. Now, what do you mean by just the right? It basically means that the algorithm is good enough to take care of large number of scenarios and edge cases. But at the same time, it should not be so very new that you don't know the pros and cons of it. Because when you put systems in productions and things go wrong, right, that can have a lot of repercussions when you're part of product teams as opposed to research lab. So this is where what you're trying to look is a problem for which you have algorithms which are fairly advanced and sophisticated that can solve large number of use cases. But at the same time, they should not be not so very new or cutting edge that we don't know the pros and cons of it, right? So that's the fifth point. Sixth, an obvious one again, but often missed in industry, pick scenarios where the cost of a mistake is low, right? Now, if you're trying to build healthcare, and that's one, there are a lot of companies that are trying to apply AI to healthcare. Unfortunately, there's a dichotomy where in countries in APAC where this is heavily needed, people don't have money to pay for it. So it's not a viable business to build. A large part of this, if you do in US, there are consequences in case your system gets things wrong. Now, in the code of the law, it doesn't matter whether you're using a software or AI. A mistake is a mistake, and there are liabilities to pay. Which basically means try and pick use cases where cost of a mistake is fairly low. Okay, so summary so far, impact should be high, effort should be low, competition should be low, AI should be the last resort for the problem that you're solving, right? You just have the right AI algorithm to be able to solve that problem fairly well, right? And the cost of mistake is low, right? Despite all the APIification that has happened of AI, right? So one of the big things that has happened in last 2 years is that you have what I call as off-the-shelf intelligence. You don't have to go and build a model on day one. You have these APIs or open source models that you can use. You can just make an API call and it will start to give response. It may not be the greatest response or the accuracy might not be very high, but the off-the-shelf models are or off-the-shelf intelligence is available. It basically means if you are a smart business or a product leader, you may not necessarily need an AI team on day one to build or assemble a system, right? Now, AI, despite all of this, still remains a fairly expensive technology, right? Because you still need data, compute, talent, and to be able to do all this, right? The purpose of any AI venture is not to advance mankind's understanding or do social good. It's all about money aspects of it, right? So it is crucial to keep economic considerations in mind from day one, right? What I have seen in my 15 years of journey, having worked with a lot of early stage startup, venture capitalists, and Fortune 500, a lot of teams tend to completely miss this, right? And I will give a small example to illustrate this point. AI can be applied in any organization at multiple points, right? And multiple places. One of them could be bottom line, where you're trying to improve the operational cost of whatever the company does and try to improve it, right? And other end of the spectrum is where you try and apply it to improve the top line itself, which basically means you're trying to either create newer products or you're trying to create new markets where the product can be sold, which is likely to bring in more and more revenue for it. Now, what I have seen consistently across 15 years is that when you're trying to apply AI at the bottom line, if your initial hypothesis is that you'll be able to improve something by X, you typically end up improving only by X by 3 or X by 4. Right? And why is that the case? There are multiple reasons. One is that AI is far from 100% accurate, right? We are far from there, which means that there's a constant effort that one has to keep putting in order to improve these systems. As these systems improve, what starts to happen rather than seeing exponential gains, what you start to see is that the improvement curve starts to stagnate, which means rather than see exponential gains, you start to see exponential effort for a fractional gain. Third, if there is human aspects involved, which is often the case, Human labor is always available to the, thank you so much, thank you. Owing to globalization, human labor is often available in the APAC market for a much lower cost, which means from a business officer's perspective, you have an AI system and you have a human labor, and the human labor is fairly cheap available in these third world countries. So the arbitrage between the system and the human is not a lot, right? I don't know how many of you know, but one of the most impactful work that AI have done in industry is not in the customer support space and all of that, and I will discuss that point, but it is in the drug discovery. Drug discovery is often a multi-million, even multi-billion dollar game, which can take 20, 30 years, right? Professor Raj Reddy was yesterday talking about we are in all probability likely to see one or two more pandemics in next 20, 30 years. What COVID showed us is that the pharma companies may not have 20 and 30 years kind of timeline to be able to develop and test these drugs rigorously, right? AI have shown ways via which the entire drug discovery time cycle can be made much shorter, right? And if you look any of the large pharma companies, you'll see there are very large AI teams already present, as large as sometimes 500 people AI teams, right? So that's a very counterintuitive area where AI has gone on to show tremendous amount of result. But the point I'm trying to drive here is this was a very intelligent application at the top, which directly impacts the business rather than at the bottom line, right? Last but not the least, always build products where the market is willing to pay a very high price, right? They're willing to spend fair amount of money in order to get your products and services. So if I were to draw this as a spider graph, and unfortunately it has not been rendered correctly, but what you actually have are multiple octagons here. The one which is innermost is low, then the medium, and then the high. So what this shows is that the impact should be high, effort should be low, it should be the top line should be high, competition low, traditional engineering should not be able to solve it, cost of a mistake is low, and the price point is high, and the tech advancement of the algorithm that you're using is just mature enough. So the gray area that you show in that you see in middle, if what demonstrates that if your use case falls here, it is more likely to lead to a multi-million-dollar venture as opposed to other use cases, right? What I will now demonstrate is that one of the favorite applications of NLP is building chatbots for customer support, right? We all have known, we all have seen. It so turns out that according to this framework, it is not a great problem to solve or a great problem to pick if the aim is to build an AI venture out of that. Right? Now let's try and apply this framework to that problem, and with that I'll end my talk. The impact is high. The competition is low. Why? Because there are a lot of companies that are doing this chatbot business, but there are hardly any companies that are doing it very well. Hence, I have said low. So if you can solve this problem very well, right, you have an edge. The effort is low. The traditional engineering falls short. We all know that you cannot write a bunch of rules on a traditional software that will solve this problem, right? Availability of just the right algorithms today in the world of LLMs and whatever we have seen in last 2-3 years, right? These are fairly sophisticated algorithms that can solve this problem fairly well. Cost of a mistake, even if something goes wrong, that's okay. It's only a user experience. It's bad. It is not that it's going to cost anything much, right? Where this changes the game is that one, it's a top line because imagine your whole business is building chatbots and selling, right? So if you do any improvements, it will directly impact your top line. Where things start to go wrong is the price point of it. And why is that the case? Because in the markets, an alternative human agent is available anywhere between $300 to $500, which means for per seat, no matter how good your solution is, market will not pay you a price greater than this, right? And in my journey, I've been part of three organizations where either I was directly involved or as an advisor, right? And what I've seen is that often the margins that these companies have in terms of P&L, right? This is purely a profit loss viewpoint of the work, is very thin, right? It is not like other AI companies where you actually have a lot of revenue and a lot of margin. You can have a lot of revenue, but your margins are fairly thin, which actually does not make it a great use case for applying AI in industry. Right? I hope I made sense. Sorry, I had to be a little quick, so I rushed through. Right? Just one last point, right? What Harshit talked about LLMs, and then this is what we tried to actually put together in the book, right? A view of things from industry. And it's not always about building the greatest model out there, right? How do you build systems that lead to large outcomes? Anybody who is interested in this area more, recently another book has come out. I would strongly recommend this book. The two folks from Princeton have actually done amazing work. So if you want to look at the hype and want to bring a more realism, this is a great book to look at. Thank you so much for your time. Thank you. Any question I can take quickly, one question now, and I'll be available otherwise for any questions and discussions. Yeah, please. Sure. Yeah, please, sir.
So if you go to your chatbot building slide towards the end, yeah. So you say effort is low, but in chatbot we have to deal with many language phenomena like ellipses, co-reference.
Yes.
So are we assuming that all these are done by LLMs?
No. So when I say this, the idea is when you're building a system which is good enough to take it to market, right? Because then your revenues will start to come in and the wheel will start to move. In any AI system, getting to the system is always hard, right? Even if we look at Tesla, right, it is not that they are 100% autonomous, right? And that's primarily because AI always lives in this long tail of edge cases, which makes it extremely difficult. So when I said the effort is low, it is to build a minimum viable product which is good enough for you to start getting the traction in the market. That is what I meant.
Prototype to
Thank you so much. Thanks a lot.
Thank you, Anuj. I kindly request Professor Vasu to present token of appreciation to our speakers, Harshit and Anuj. We will have a very quick tea break and be back by 11:30 sharp for the next session. Thank you.
Very interested, they can come announce it now.
Both the tea breaks are available and both the tea breaks.
Okay. An announcement. So both the tea breaks now and the one in the noon, there are posters available, and anybody who's interested, please do visit exhibition hall. 10 that.
Opposite alumni lounge under the
Yeah. Okay. It is opposite to the alumni lounge. Volunteers, please guide the ones who are interested to go there.
Hello, can you hear me? Hello, can you hear me? Hello.
I don't think.
So, yes.
Yes, we
So we are
can.
having tea break till 11:30. Hello? Am I audible, sir?
I think you are, but not to Mitesh, I guess. He can't hear us.
Sorry?
You are audible to me, but you're not audible to Mitesh. I don't think Mitesh is trying to speak, right? He's the next speaker, correct?
Okay.
Yeah, I don't think he's able. Mitesh, can you hear us?
Yeah, now I can hear you. Yeah.
Okay, yeah.
Okay, sir.
Yeah,
Yeah.
they are in a break, so they'll come back after the break.
Yeah, I just joined from two devices, so I'll be mute on one of the devices.
Can we test your slides now?
Yeah.
You can start your sharing your screen.
Yeah, I'm doing that.
We can see your slides.
Okay. Good.
Can I read it, the heading? But what do you mean Gen AI for India?
Yeah.
Okay, thank you, sir.
So for our next session, we have a talk on generative AI landscape in India. And I request Professor Manish to kindly introduce the speaker, Professor Mitesh Khabra.
Thank you, Anaga. So this session is basically titled the Generative AI Landscape for the Indian context, for Indian languages, right? And we have two excellent speakers, Professor Mitesh Khabra from IIT Madras and Professor Ravi from IIIT Hyderabad. And the idea is to cover in broad strokes where the generative AI revolution is leading our Indian NLP landscape, right? And it is my absolute pleasure and delight to introduce our first speaker, Professor Mitesh Khabra, who is joining us online. Professor Mitesh Khabra is an associate professor at Department of Computer Science and Engineering at IIT Madras, where he has received a lot of prestigious awards, including Google Faculty Research Award and IIT Madras Young Faculty Recognition Award. He also, for most of us, he is known as the face of AI for Bharat. That's the short name that we know it for as. But he heads the AI for Bharat Research Lab at IIT Madras and has been contributing to revolutionize the Indian NLP landscape. There is another part of this story which would come an hour or so later, which we will cover then. But Professor Mitesh Khabra has his research published in almost all the top forums in NLP research across the world. He has worked at, before working at IIT Madras, he was working with IBM Research Lab. And before that, he was an esteemed member as a research scholar at IIT Madras at Center for Indian Language Technologies under Professor Bhashini. It's my, again, I should, did I say IIT Madras? I'm sorry, IIT Madras at Center for Indian Language Technologies under Professor Bhashini. Once again, it's my absolute pleasure to welcome Professor Mitesh Khabra. Over to you, Mitesh.
Thanks, Manish, for the generous introduction. And the second time also you mentioned IIT Madras, so I will correct you as IIT Bombay, Center for Indian Language.
Pushpak sir corrected me and I corrected that.
No, second time again you said IIT Madras actually.
So, okay. Just to be clear, PhD and MTech from IIT Bombay under Professor Pushpak Bhattacharya. Over to you, Mitesh. Thanks.
Thank you. Bye. Okay. So let me start. So I'll talk broadly about Gen AI for India, right? And share my thoughts on what I think about where we are, where should go, and so on. Right? But before we talk about Gen AI, right, let's talk about what has happened to language technology in India over the past few years. And I'll talk about this in the context of Bhashini, where multiple research groups have been associated with Bhashini as consortia, as different, working on different language technology verticals, and several contributions have been made. And all of these efforts have gone towards building the foundation to enable machines to understand the rich and diverse lives of India's, the rich and diverse languages of India, right? And there are several verticals, a few of them are listed here, speech recognition, optical character recognition, machine translation, speech synthesis, transliteration. Others work on natural language understanding, all of this happening under this project Bhashini, right? And what all of us have been trying to do is build this ramp, right, where we create foundational datasets at a certain scale, at a certain size, which is respectable for modern AI, right? To give you a sort of example of that, we all know that modern English, a lot of modern English ASR systems are trained on the Libri speech dataset. Of course, now they're trained on much larger datasets, but Libri speech is a standard dataset which has 1,000 hours of transcribed audio, right? So can we create at least 1,000 hours of transcribed audio for each of the major Indian languages? Was one of the goals that was set out for Bhashini, right? So build this foundational layer of datasets for all the language technologies or verticals that I have listed here. Right? And once you have this data, build multilingual models, which then enable these technologies across different languages. And finally, a missing piece is evaluations. So much of evaluation on the progress of ASR or machine translation has always been in the Western context. Hence, a lot of metrics that are currently used have been inherited from English and other languages, and they may or may not be really suitable for Indian context. Just not metrics, but also data sets. For example, one of the most popular benchmarks for machine translation today is the Flores benchmark released by Meta. But it contains sentences which are originating in the Western context, and then they are translated to multiple languages to make an n-way parallel data set, right? But now can we make a benchmark which is originating in India, which has sentences about Bharatnatyam, has sentences about the first war of independence of India, and then decide to evaluate how well do our machine translation systems work on these contexts from Indian context, right? And while this ramp is being built, there's also this loop where deployments are happening in parallel through partners like Bhashini, where in multiple government use cases, the models are getting deployed, be it Supreme Court, Hello UPI, PM Kisan, language learning, and so on. And the idea is to drive impact, right, through inclusion. So all of this, the reason I'm talking about all of this is that this ramp is already being built, right? And it's like made significant progress over the past few years. And of course, this has been building on the traditional work that has been happening for many years in India on NLP. But there is a sort of effort to accelerate the growth of Indian language technology even further, right? Now, while all this was happening on these non-LLM technologies, for the want of a better word, we also had work on LLMs, right? So there were the Gen 0 LLMs where foundational data sets were being built, monolingual corpora for Indian languages, the BARD, the Gen 0 type of models, right? Which are not very large scale, which are not trained on huge amounts of data. They're trained on sane amounts of data as opposed to the insane amounts of data used today, and some traditional benchmark, right? All of this was also being built for Indian languages when we were hit with this Gen AI quake, right? The ChatGPT moment or the Gen AI quake, where everyone got excited about, hey, this is something exponential jump from where NLP technology or language technology was there. And now we are seeing an exponential jump. And now what should we do, right? What can we do in response was a question, right? And this ChatGPT moment sort of triggered discussions in the Indian context that what should India's response be? Should we just wait and watch? Is this hype? Can we build it in India? If so, how should we build? Should we even try to build an Indic LLM? And what are the resources required for them and so on? But even before all of that, right, a basic question on what exactly do we mean by Indic LLM, right? So let's try to decode that Indic LLM. So when we say Indic LLM, do we mean LLMs for Indian use cases? Because that is a valid definition of Indic LLM. Or do we mean LLMs of Indian language, right? So it's a language model, it's a model of a language. So do we mean model of Indian languages? Or do we mean LLMs built by Indians, right? So is it for Indians, of Indians, by Indians is the question, right? And now, if you look at the first one, which is for Indian use cases, then that is actually possible even today, or that was even possible one and a half year back when ChatGPT had just, not one and a half, now almost 2 years back, but say 3 to 4 months after the ChatGPT moment, it was already possible where people were building solutions on top of ChatGPT by using traditional language technology like machine translation or speech recognition or speech synthesis or a combination of this. A classic example of this is RAG-style bots, whereas there is an Indian user who is coming and giving his or her query in their native language. The query gets translated to English because the LLM is good at reasoning in English. The LLM again creates an answer in English, translates it back to the native language, and then the answer either gets shown in the form of a text or gets synthesized as speech and is returned back to the user. Right? So this is already possible, or was already possible even 1.5 years back. Right? So if that is what we mean, then we are already there and we could focus on seeing how to improve this further. If you mean that we want LLMs of Indian languages, then we need to ensure that we have a large amount of Indian tokens. Right? Tokens is a common terminology now. It just means a corpus by tokens, I just mean corpus, that we should have a large collection of documents written in Indian languages and about Indian content, Indian context, right? An example of that would be documents containing all the legislative articles in India, or all the Supreme Court judgments in India, or all about all the government schemes, about Ayurveda, about anything which is Indian to begin with, right? So not just tokens, but also content should be Indian. It should not be, say, an article on Trump written in Indian language, which is also welcome, but also originating in India, right? So that's what would take to build a model of Indian languages, right? And if it's about the third, where we are talking about by Indians, then we want the models to be trained in India by Indians. We need to be involved at all the stages that go into a modern LLM, which is not just pre-training, but also instruction fine-tuning, making sure that the models are aligned with Indian preferences, Indian culture, Indian values, are devoid of biases which exist in the Indian context. And we do a robust evaluation such that we can show that the model is fair and inclusive across a diverse demographic of Indian population, which speaks different languages, may have different needs, may respond to different culture, have different cultural preferences, and so on. Right? So that is what would mean by LLMs built by Indians ground up, by rooting all of these decisions in the Indian context. Right? So now, if you look at these three, for Indians, of Indian languages, and by Indians, then the first goal is in the short term, right? As I said, this is already possible, right? This is already being done. Many people are trying to build solutions on top of existing LLMs by interfacing them with language technology. The middle one is the midterm, I would say, right? In the midterm, we should try to see if we can build a lot of content or a corpus which is rooted in Indian content and contains tokens from Indian languages. And in the long term, we should set up not only the large-scale data infrastructure, but the large-scale compute infrastructure, as well as the talent required for building these models in India ground up, right? So that's like a perspective on what we could mean by Indic LLMs and what each of these definitions would mean in terms of time, right? Another way of looking at this is that in short term, we need to empower Indians with AI solutions built on top of LLMs. We should make sure that they are not left behind in this use case drive of the use case wave of LLMs, right? Where a lot of LLMs solutions are being built, and just because they are not natively in Indian languages, we should ensure that our population is not left behind. And this kind of integration of language technology, such as machine translation or speech recognition with an LLM, should be able to power these solutions. Right? In the midterm, which is the part where I was talking about collecting Indian content, Indian tokens, this is to champion Indian languages in the next generation of LLMs. Now, what do I mean by that? If, as an ecosystem, we all come together and release a large amount of good Indian content corpus out there, then there is no reason why any of the open source or even proprietary efforts on building the next LLM, right, be it GPT-5 or be it Llama 4, should not use this readily available content to include it in their pre-training cycles or even in their instruction fine-tuning cycles, right? So that is what I mean by champion Indian languages in the next generation of LLMs, by simply putting out a lot of data, which is, it should be a no-brainer for anyone to just pick up and add it to their next training cycles, right? And the third, which is the long term, is to lead the way with sovereign models rooted in Indian needs, culture, and value, right? So that's a different way of framing that. And a more technical way of framing that would be that during pre-training, get the tokens in. During fine-tuning, focus on specific use cases so that it works for the Indian population. And during alignment, make sure that we make the right choices so that it understands Indian preferences. Right? Now, given this context, what will it take to get there, right? So there are three important pieces to the puzzle, and no surprises here, I guess, to this audience. One is talent. I genuinely believe, and I know there could be differing opinions on this, but I think that we have enough talent in India to build Indic LLMs. I am aware of at least 2 to 3 efforts where LLMs have already been built ground up in India or will be built in the next few months, right? So I'm not really worried about talent. And if we don't have talent, I think getting talent or creating talent is not an issue in my personal opinion. And I'm agreeing to the fact that this is open to debate, but my opinion would be we have the talent, right? Data. We do not have enough data to build Indic LLMs, right? So we have to make sure that we first create this data infrastructure. And I'll talk a bit more about what kind of data we should look at for building Indian LLMs. And the third is compute, right? We simply do not have enough compute to build Indian LLMs. We all hear news articles about how much compute is procured by the deep tech industry, be it Meta, Google, Microsoft, to train and run these LLMs. Right? And we are simply nowhere close to this as a country. Fortunately, we have certain initiatives going on, in particular the India AI mission, where both data and compute, and I think skill also, talent also happens to be an important pillar. And I'm sure we'll make more progress along that, right? But some of this has to be done organically, and I'll talk a bit more about data, right? So this data bottleneck, right, needs a moonshot effort. Now, why do I say that? If you look at the latest Llama model, which is a good sort of ballpark to have, because it is in the open, there are at least some statistics available about the amount of data that was used. It was 15 trillion tokens which was used, right? So let's assume that, say, 5 trillion tokens of that is code and other languages and so on, which is still a bit of an exaggeration. I think that would just be around 1 to 2 trillion tokens. But just to get a round number, at least 10 trillion tokens of English knowledge are there in that data which was used to train Llama, even the 7 billion or even the bigger size, right? Now, what would it take to get there? Because today, if you look at all the content out there, which is machine readable, available on the internet, we are not even touching 1 trillion tokens. We are not even touching half a trillion tokens, right? We are somewhere between 100 billion tokens to 500 billion tokens, which is significantly less than the 10 trillion token that we should set up. And this is again summed up across all the languages. I'm not talking about one language here, but summed up across all the languages. But let's assume that if you have collectively 10 trillion, that's good enough to think about training a model ground up in India. Right? Now, what should that data look like? Right? So if you look at it, what are LLMs being used? Right? A lot of the magic of LLMs in its knowledge about the world, right? And this knowledge, unfortunately, is largely available in English. Right? You wouldn't find an article on the first war of independence in each of the 22 languages on Wikipedia or any other online resource. Right? You wouldn't find an article on the Battle of Panipat in each of the 22 languages online or Wikipedia or anywhere else, right? But you have these articles available in English. So the world knowledge is sort of largely skewed towards being available in English. Can we do something about making it available in Indian language? And given the gap that where we are, I don't think creating it from scratch with the help of humans is going to get us there. It's just going to take us a lot of time to get there. And here, at least my recommendation is that we look at synthetic data, where we use open source models like Llama to synthesize some of this content in English because they have this world knowledge, and then use translation and appropriate filters or distillation to distill this knowledge into an Indian corpus. And I'm talking about data distillation here, using a large language model to create data which is of interest to us through translation as a pipeline, right? So that's one important pillar required in the data, which is capture the knowledge of the world. The second important pillar is to capture the essence of the language, right? So one criticism for using a lot of synthesized data, at least, especially through the translation route, is that you would get this translationese effect where your sentences then would not sound very natural, right? But I'm looking at that pillar only from a knowledge transfer perspective, or only from the perspective of capturing the knowledge of the world. There has to be another pillar which captures the essence of the language, the grammar of the language, the structure of the language, right? And this, in my opinion, would require a smaller amount of well-curated data, be it from well-written books available in Indian languages, well-written content on the web, or even well-spoken content in the form of speeches or podcasts. All of this can be curated to distill into this essence of the language that we are trying to build an LLM for, right? So that's the second pillar of data which is needed. And okay, I finished the third, and then I'll come back to one more statement that I wanted to make. And the third is the culture specific, right? Can I ask an LLM today about what does an average person do on the day of Diwali from 6 a.m. to 11 p.m. in the district of Dharwad, right? And I want to take such 10,000, 1 lakh questions, the number could be anything, and go to every district in the country and ask them, right? So what are the rituals performed from the day of the Roka ceremony or the pre-engagement to the wedding day in your district or in your village, right, or in your culture, right? What are the different rituals performed or after the death of an individual in your culture or in your village, right? And it could be after the funeral, there are 13 days, in some cases there are 30 days, what all is performed during that period. And you could think of a long list of such questions which actually captures the cultural essence of India, and not just like a centralized cultural essence, but really distributed across the different villages, districts of India, right? And this would require an effort where we go across the country, right? This would be a large-scale effort, similar to some of the Indic Voices effort that we're doing as a part of Bhashini, where we actually go across the country, interview people, and ask them these questions in the form of prompt response plays, right? And my sense is that there is an order of difference in the amount of data required for each of these. If we require 10 trillion tokens to capture all the world knowledge, then perhaps we require 100 billion tokens to capture the essence of the language, and maybe 10 billion tokens to capture the culture of the language, right? So that's my estimate. It could be up or down, but at least I'm very clear that these three pillars of data are required. And unless we have this, there's no sense of even attempting to build an LLM for Indian languages, because it will not really be Indic the way we want it to be. And all of this would sort of contribute to the 10 trillion token target that I would like to set for training an Indic LLM. Of course, these numbers can be a bit up or down. It could be 20 trillion, it could be 10 trillion. But the overall message that I'm trying to give is that it has to be a significant size, and it has to capture these different segments of knowledge that we care about. Okay. And once we have that, the other important thing which is missing is to do robust evaluations, right? So currently it's like an open, clearly acknowledged or clearly understood among the academic circles that LLM evaluations are completely flawed. There is data contamination. The leaderboards are often on very simpler tasks as opposed to the actual power of an LLM in generating or giving recommendations or synthesizing content and so on. So there's not enough robust evaluation of LLMs. And when we sort of plan our journey for Indic LLM as a country, we should focus on evaluations which are grounded in use cases, right? And here's where the India AI mission, as well as the Ministry of Electronics and Information Technology, which is trying to set up an initiative for building the AI pillars for the country. We should have evaluation as a very important pillar in that. And to give you a sense of it, right? So there is a lot of talk about building bots for different applications. Now, bot has become like a all-encompassing word for any AI application that is being built. Now, what do you need to evaluate these bots, right? So you need to make sure that the bot really understands different types of intents, be it asking for decisions or trying to solve a complex problem or trying to just do a brainstorming with the bot. Different styles of speaking. This includes languages, dialects, accents, emotions, all of it, right? And then different personas, right? With people from different backgrounds, they want to interact with the bot. All of this has to be evaluated, right? And if you think of it, current LLM evaluation, it's like a standalone data set on which you just keep trying to track the numbers and improve that, which captures none of this, right? None of the complexity of a downstream application is captured in that. So can we come up with automatic ways of evaluating that with an LLM plus human in the loop, or a human-centric evaluation where we get people to interact with these test bots and give their opinion on whether it works for their dialect, or have some automatic metrics of capturing this through the interactions that real people have with the bots, as opposed to evaluating them on a standalone data set, right? So a lot more work needs to be done on evaluations. How are we doing on time?
Mitesh, we have 2 minutes.
Okay, sure. I'll wrap up. Yeah.
Thanks.
And this is the last point I want to make, that if we are thinking about LLMs, we have to be mindful that voice is India's most natural interface. We are not really very good at typing in our languages, nor are we very good at consuming written content in the form of reading in our language, right? So even if we magically have these 10 billion tokens, we build an LLM of the right size. Now, when a user comes to interact with them, this is a text LLM, and the user may want to speak, or the user may want to type in Romanized form, because we're not very good at typing in our languages. So we would use one of these proxies. We need the peripheral technology of identifying toxicity, language ID, etc. And if the LLM still happens to be better in reasoning in English, we may have to translate the content to English in addition to feeding it in the regional language. then feed it to the LLM, do the reasoning, get the answer back, and then synthesize, right? So a lot of this peripheral technology is also integral. It's not just about building LLMs, but ensuring that we improve voice technology end to end. That means speech recognition, speech synthesis, all of it. This is what we need to do in short term for the peripheral technologies. In the long term, we should see if we can directly leapfrog to voice LLMs, where the input and output both is in speech. And here, this has to be done a bit smartly so that whatever investments we make in the short term in terms of creating data sets for improving ASR and TPS systems, can they be leveraged later on for building the voice LLM end to end? Right? So I'll end here. Thank you. I'll be happy to hear any comments or questions.
Thank you, Mitesh. Thank you, Mitesh. If there are any questions. Just we'll take one question.
Dr. Mitesh, thanks for the nice presentation. I want to supplement on the infrastructure that the national program on AI has already put out a tender for putting up a large infrastructure. So that may not remain the bottleneck in the near future.
Yeah.
Thank you, Sarnata ma'am. And for the next part of this session on, before that, thank you so much, Mitesh. That was a very enlightening talk. And we'll just, if you could hang around for a little while, we'll take some questions at the end of the session.
Sure, I'll do.
Thanks, Mitesh. Thank you. And for the other half of this session on generative AI landscape or India, we have our own Professor Ravi. Professor Ravi is an associate professor at CBIT IIIT Hyderabad. He leads the vision direction of BhashaChain, which is a government-funded multimodal, multilingual LLM initiative. And he's also the lead for mobility at the iHub data efforts we have here. Dr. Ravi did his PhD from IISc Bangalore, and unlike LLMs, I do not want to hallucinate again. So I pay more attention here. He did his PhD from IISc Bangalore, and where his thesis got the Indian Unit for Pattern Recognition and AI Best Thesis Award, and also Sir Vittal R. Chandravakar Memorial Gold Medal. Before joining IISc, he has worked for multiple US-based R&D companies, and before that, he obtained his MS from Computer Science from University of Washington. There are some other things that I wanted to say, but Ravi would take care of that himself. I welcome Dr. Ravi. Over to you.
Okay, so first of all, I'm very thankful for this opportunity. This is a great occasion in more ways than one for me. And I'm glad that Manish left something for me to say, because I stand here not just as a faculty of IIIT, but also as a former student. Does the clicker work? Oh, all right. So for me, it is truly a story of there and back again. So when I joined IIIT, I did not know that I would be joining a research institute. In fact, IIIT probably did not know itself that it would become an institution of that kind. So the first paper I wrote was in 2003, and this was on OCR for Hindi and Telugu documents, right? And well, this was my first foray into research. And what I particularly like looking back at this paper is the role of many people whose names you have seen throughout. So though fundamentally image-centric problem, there was LTRC all throughout this, right? And for me, life has truly turned full circle, because after coming back to IIIT, I took up OCR again, right? So hardly a solved problem and lots more to do. Okay, so the talk is to be about generative AI landscape in India, but I think I will probably cover some of the frontiers and directions in which generative AI in India can go towards, right? So this is a slide from a picture from NASSCOM's State of AI, Gen AI in 2023. And I think the detail is not really clear, but the pink band over there contains text, which says that basically there were no Indian foundation models. So there are a couple of applications, some generative AI startups, some names that you might be familiar with. You can see over there, there are some generative AI services. Now, come 2024, the very same report from NASSCOM shows that the landscape has changed dramatically, right? So there is a solid set of entrants in proprietary and open source LLMs and services. And it also, I think it's an interesting read. I recommend everybody read it to get a quick peek at some of the trends and drivers of Gen AI in India, right? So the NASSCOM. Which row of? Oh, okay. So I'll point that out. So there is a row over there which says proprietary LLMs. And you can see names like Sarvam.ai, Krutrim, and so on. You can see AI for Bharat and some of the other names. And perhaps the most recent entrant is what I am affiliated with, BharatGen. So I'll talk a little bit about that. So BharatGen is a government-funded Indic multimodal LLM initiative. So it is primarily an academic consortium-driven initiative. And we also partner with Bhashini, which Mitesh was talking about earlier. So this was formally inaugurated in end of September. So in that sense, it is fairly newborn baby. And some of the activities that we envisage taking up are more or less on lines of what an entity like this ought to be taking up. So there is, of course, the emphasis on foundational technology development and also India-centric dataset development, right? But in addition, being academics, there is also a role to educate and skill. So there is a role for HRD and skill development. I think there is definitely a need for that. And we want to do that not just in terms of releasing models and data sets, but also recipes, and also to create all these educational tools and content and trained personnel, which is a natural byproduct of being the entire consortium being rooted in academia. Right? And we want to be slightly expansive and also engage with the industry, and therefore there is also an emphasis on entrepreneurship, right? So entrepreneurship rooted in the consortium is also something that we envisage. So I'm not going to go over the entire set of activities that we tend to take up, but from a strategic point of view, I think an initiative like this makes a lot of sense, because I think the analogy is that regardless of whatever we are comfortable with, there always needs to be BSNL. Otherwise, unlimited data plans come at unlimited cost. And there always needs to be a state transport corporation. And otherwise, we will have breakneck speeds and reckless driving. So therefore, regardless of other players, it is always, I think, a wise strategic initiative that is government-driven and government-led, that always needs to be in the picture, something which possibly will never be a victim of mergers and acquisitions. So in that sense, there is a need for an entity like BharatGen, right? And it is not orthogonal to some of the things that have been mentioned, right? So it's in perfect alignment with some of the other things that have been mentioned about what Indian LLMs ought to be, Okay, so a lot of this event has been about language and script, but I think there is a need for inclusivity in all aspects in DIC, and that extends to beyond language and script, right? So there is images and videos. There is how do we capture culture? How do we capture history in all its varied forms? So here are some possible thoughts, and I'll try to give a brief reason why I think they might be something to reflect and think about. So memes and jokes, we all like them, right? Meme conveys a picture is equal to 1,000 words, and meme is equal to 10,000 pictures. So memes, jokes, and metaphors are a good test bed for AI. This is not just me saying it. So as early as 2012, the famous researcher Andre Karpathy, educator, posted this picture. This is 2012, right? Just when the whole deep learning was about to take off. And in that blog post, he says that the state of computer vision and AI, we are really, really far away. So this is a picture of the then President Barack Obama, and it shows a sort of a funny incident. Now, everybody looking at that picture gets the joke, right? So in case you're not familiar with what the person is doing in the corner, he's standing on a weighing scale. So in the blog post, he essentially asks, what would it take for computer vision to fully understand every aspect of this picture, right? So the day computer vision is able to take this picture and describe it, then we can truly say that AI has arrived. And he posted a follow-up to this, saying that it seems like the industry really took this seriously. And now if you give a picture like this to some of the recent vision language models, it does give a pretty accurate description of what is there in the picture, identifying the people, not getting fooled by reflections, and so on. Now, there is some debate in the community whether this is part of the training set, but maybe we will not take that here. Right? But the point remains, right? So we want to have challenges which truly force the community to go beyond traditional data collection and traditional ways of thinking, right? So what would these pictures be in, say, an Indic context, right? So earlier, Mitesh was talking about, what it takes for something to be Indic, right? So now this picture taken somewhere in Midwestern USA superficially has nothing Indic in it, right? Yet all of you in the audience get the joke, right? Or can, if asked, can give a fairly consistent explanation of or a description of what it conveys, right? Another example, right? So what would be the equivalent of this for the next generation of systems, right? So the first two pictures, okay, there is some similarity. The two pictures on top right and bottom right require a great deal of world knowledge, right? Not just knowledge of the world and its physics, but also an understanding of metaphors and an understanding of contemporary metaphors. Right? So how do we have systems which can understand these things in visual medium in totality, right? So now one knee-jerk answer to this could be that, let's go and create a data set of memes, right? So that is possibly one step towards it. But I think the knowledge representation that accompanies these pictures is what is key, right? And that is definitely not straightforward. So at BhashaChain, one of the things we wanted to see was, is there a way in which we can work on something relevant and not wait for all the so-called necessary advances to happen before we can say that we are moving the needle, right? And for this, we took up a scenario in e-commerce. Right? So e-commerce is very well known. There are primarily three kinds of players. So you have the sellers who sell items. You have the buyers, most of us. And then there is the e-marketplace or an aggregator like ONDC. Now, most of our experience in this entire scenario is that of a buyer, right? And we know that all the e-commerce players out there are trying to make this experience as short and quick as possible. Now, let us for a moment think about somebody who has to sell a product on the marketplace. What would they need to do? Of course, tools exist to make this process easy, but it is in this day and age, with all the tools that we have, it is far from easy. So I just want to show you an experience of like what this looks like, right? So let's say that you want to sell a product. So you first need to choose a category, and then you need to type the name of that category. And because the description has to be enticing, you have to not just type what the product looks like, but you have to type in something that will sell the product well. So this is live, right? We actually registered ourselves as sellers on a marketplace portal in order to be able to understand this, right? So we wanted to see what the process was firsthand rather than just rely on it through hearsay, right? So this is how the product, it looks like in real time, right? So I'm not going to show you the entire video, but the video will run for 6 minutes and it will run over 4 screens before this entire experience is complete, right? So now the question is, can we make this better, right? So here is our attempt at making it better, where instead of doing all of this, you simply upload a picture and then you have AI take care of it for you.
खूबसूरती से तैयार की गई सोने की टोन वाली हनुमान देवता की मूर्ति जटिल रूप से विस्तृत और अलंकृत पैटर्न से सजी हुई।
Right. So essentially, you have auto cataloging app driven by vision language LLM running at the backend, very Indic aware. And as part of this, of course, you can just let it run like a default app. It will auto generate an English description. It will fill all the fields for you. But imagine someone who has to sell this product and they really do not understand English. So you're doing something about the product and they have no clue about what is happening. And it is here that we can leverage existing Indic technologies to do the job for you. So we can take, in this case, we took the description generated by fundamentally an English language model and translated to Hindi and spoken by a TTS. Right? So without waiting for the advances in NLP, we can take whatever we have, put them together to already enable solutions. And this possibly provides a glimpse of what can be done, right? So this was demoed at the Indian Mobile Congress in October earlier this year. Now, where do we want to go to? So ideally, any input, any task, right? So most of the discourse today has been around solving tasks which are fundamentally autoregressive or discriminative in nature, but you can also have generative AI in the sense that most people tend to relate to text to image and so on. But it is important that we have these frameworks developed in a way which addresses not only contemporary needs, but they are also grounded. So yesterday, Professor Sangal was talking about letting the winds in, but staying grounded so that you are not swept away. So I think it's important to have both so that you are relevant to contemporary needs, but you are also not overwhelmed by them. Yeah, that's it. Thanks.
Thank you, Professor Ravi. If any of you have any questions?
Can we have Mitesh also on that?
I'm sorry. Speech input we have not come to yet, but that is on the pipe. Yeah, because we can have a scenario where it is translated and the person who is selling is not satisfied with the way it is described. It can very much happen. So I think speech repair is something that's on the horizon.
This question is for both Mitesh and Ravi. When we're looking at these initiatives, there are a number of them. Some are coming from the private players, semi-private players, and also the government initiatives and individual efforts that are going in various institutions and so on. So as it is, our community is very thin, and then making these multiple efforts, and somehow we also need to get to a point where we integrate all of these. Any thought process at the maybe at the very high level, policy level, thing that is going on? Any inputs from, because you're seeing it from very close?
Maybe I have already taken a question. Maybe Mitesh can go first.
Can you just repeat the last 20 seconds of the question?
No, I was asking if there are any initiatives to consolidate these efforts or cross-leverage. Should there be, first of all, and then if so, any thoughts in that direction?
Yeah. So to the best of my knowledge, currently there is no concrete initiative to sort of merge or even sort of cross leverage these multiple initiatives which are there. I think they are fairly independent because they started in parallel and went their own ways, right? So I don't think there's an effort right now. But whatever initiatives are there, at least I've seen that the paths do cross in several of these larger think tank kind of meetings and what should we do. So, but it's all inorganic right now. I think there is a need to make it more coherent, where all of us are aware of, all of the players are aware of what the goals for everyone else is. And if there are any redundancies in things like data collection or even model building for that matter, then maybe it can be all consolidated, right? So I think the clear answers are: one, I don't think there's a consistent consolidation right now, and second, I think there should be one so that effort is not duplicated.
Yeah, so I agree with what Mitesh is trying to do here. I think some of these things happen just because of the asynchronous nature of these initiatives. And also the way incentives are set up in some of these initiatives. So either there is a bottom-up effort from the community where people come together and they understand that there is perhaps there can be some complementarity. Like, somebody is working on X, working on Y makes sense because when you put X and Y together, then you can do multiple things. So for example, the whole arc of NLP and now vision, right? So I see that as complementarity, right? Vision by itself may not have an independent existence, but put together, there are a lot of domains where it makes sense, right? So documents make sense, scene text makes sense, right? So I think that is bound to happen. Now, there is only so much redundancy that one can minimize, and some of it is also due to credit anxiety. So until there is either a top-down push to eliminate that credit anxiety, but until then, I think we'll have to just make do with whatever exists.
One quick question from Professor Bhavi.
Yeah, a quick question to actually both Dr. Mitesh and Ravi. Do we have a choice of not building an Indic LLM, especially in specific cases like defense sector that would like to use the emerging technologies, including large language models, vision language models? So is that an option that we have of not building our own? So this is a question to Dr. Mitesh, then implication for BhashaChain riding on an LM. Right.
No, I mean, my clear answer on that would be that we don't have a choice. I think we should have a native or sovereign efforts on building Indic LLMs. And the choice is only about in the timeline, right? So that's what I was saying, that in short term, we can do something in the here and now. In midterm, we can do something. But in the long term, we have to move towards large scale efforts in India which build these models ground up, right? I don't think we have a choice in that. I mean, we should have those efforts.
So, Professor Bhavi, you were asking about a defense context. Right. So I think when it comes to critical infrastructure, there is definitely a need for something homegrown, right? So the whole UPI or Aadhaar stand as examples of that. And recently, even for the quantum mission, the government has taken this strategic stance that all critical technologies, we need to have a homegrown component so that we are not locked in, right? So I think in that context, having an Indic LLM makes absolute sense. We need to have our own.
Hello. With this, we can we can take the rest of the questions later, please. In the interest of time.
One question, please. Yeah, in India, most of the population depends on the agriculture. From the BhashaChain, are there any initiatives towards agriculture domain? Are we building any LLMs towards agriculture?
Right. So I'll just keep this brief. So there is an initiative where we are collaborating with the Directorate General of Agriculture and Crop Research towards building bots called Krishi Sati. You can find details about it online, right? Or you can come talk to me later.
Thank you.
Thank you, Ravi. Thank you, Mitesh, for these enlightening talks. Now I'll hand over to Anuga to move on to the next.
Thank you, Professor Ravi. I request Professor Vasu to hand over a memento to sir. So we move on to our next session. We have a talk by Dr. Anup Kunjuguttan on NLP at scale for Indian languages. I request Professor Anil to kindly introduce our speaker.
Yeah, good afternoon. As Manish mentioned, this is the extension talk to that AI for Bharat. Dr. Anup is a principal applied researcher in Microsoft machine translation team in Hyderabad, India, and co-lead of AI for Bharat at IIT Madras, advancing Indian language NLP. He's also an area chair of ACM rolling review in multilinguality and low resource NLP. His research focuses on multilingual learning, large language models, machine translation, and NLP for related languages. Dr. Anup has contributed to resources like Indic Trans, Indic LLM Suite, Airavati LLM, and the Indic NLP library, which support Indian language technologies. He completed his PhD at IIT Bombay in machine translation and transliteration. Yeah, over to you. Yeah, thank you.
Hello, everyone, and thanks for the kind introduction.
I'm really happy to be here. I think since I started with my association with NLP at IIT Bombay, IIIT Hyderabad has also been a part of the journey. So really glad to be here, and congratulations to everyone involved in building this institution. And today I think I'll talk about something that IIIT Hyderabad has been involved in, along with a lot of institutions in India. So, and alluding to how do we build NLP technologies at scale for Indian languages. So what do we mean by scalability? It means the ability to handle a growing amount of work within constrained or set resource limits, right? And what do we mean by that in this context? What we mean is the ability to address maybe a wide variety of languages, a wide variety of tasks, handle a range of requests, volume of requests, etc. So in this context, I'll focus on the number of languages and tasks for today. And I think it bears no saying that the challenge in India is the diversity of languages in terms of the number of languages, the number of language families, the scripts, and the fact that even though it's a language country with a large number of languages, it still is a country with amongst the highest, I mean, it's fragmented, yet each of those languages have such a huge speaker base that they warrant a high volume of usage, right? So and within languages, dialects, registers, and many other phenomena to be handled. Coming to, say, use cases, we want to support, say, applications for social good, government services, for education, for, say, information dissemination, etc. Maybe just to enable people-to-people contacts among people speaking a wide variety of languages, be it culture, be it movies, etc. And surely business, economic goods, how do we enable good business, right? And to do all this, we need to build technologies that can be easily scaled and can be brought, can be easily enabled for a wide variety of languages. So how do we do that? So first of all, what are the challenges there, right? The challenge, as we have already alluded to, Mitesh spoke about it, that one of the primary challenges is data, right? So we lack data, and data of different kinds, be it raw data, be it domain-specific data, data for training specific tasks and models. In terms of the size of the data that we have, how do we scale? And when it comes to that, then it also means labeling the data. So do we have at scale people the skill to do those annotations with a certain level of quality, right? So that's one part of the story. The other part of the story is running cost, deployment. So again, in a price-sensitive economy like India, if you want to run models, the model sizes should be constrained. Inference time and latency are, of course, always important for applications. We want to keep maintenance low and to have the right developer tooling so that building these NLP applications is easy, right? So that's another aspect of scalability. And finally, evaluation is a very important aspect. Now we are moving towards an era where we have more and more complex NLP applications, more subjective applications. And in that case, how do we evaluate these tasks? How do we solicit quality judgments? And not just quality solicit judgments, but also how do we get feedback for improvement, right? Many times you're just working on languages you just don't understand, right? So what is the right mechanism for doing that? So these are the kind of challenges that exist. I'll touch upon a few of these today, primarily from the data point of view. And this is the picture a few years back when we sort of started looking into scaling data. And this is sort of an illustrative example of the gap between English and, say, Hindi, which would be amongst our most resourced languages by far. So if you look at Wikipedia, English has around 6 million articles compared to Hindi, which is just about 150K articles. The same is the story with parallel corpora for machine translation, or if you want to look at NER corpora for doing name entity recognition, or if you want to do question answering, squad data set is by far larger than anything that exists for Indian languages, right? So that's the challenge. And how do we approach this challenge of scalability. And my thesis here is this. That's been the attempt of NLP over the last 30, 40 years, and each generational change that has come about has tried to address this scalability challenge by making it, by kind of lowering the effort required and thereby enabling more work to be done. And if you look and more, and let me talk from the perspective of just number of languages, right? So we started with rule-based systems, and moving from rule-based systems to classical ML, the requirement for linguistic expertise, which is always at a premium, reduces. Moving from classical ML to deep learning, we can do away with feature engineering and associated tools for feature engineering. So every language would have to do its own post taggers and parsers and things like that. That is one sort of evolution that's happened. Semantic representation helps. What deep learning really enabled, and for multilingualism, is the fact that you can represent data from multiple languages into the same vector space, and then enable multilingual and zero-shot kind of applications, right? Going ahead, pre-training LLMs have all added to that, reducing the data requirements. In very concrete terms, what do we do today, and what is the kind of approach that looks appropriate and what seems to be working, right? So today we are all in this era of deep learning based NLP, and representation learning, as I said, has a lot of interesting things to contribute, which helps bring down the cost and the effort in terms of the reduction of feature engineering, etc., that I just mentioned. Multilinguality is a critical component. It sort of helps to build language agnostic models, especially if you can have one language help the another. And so data requirements across languages amortized over these languages can reduce. Pre-trained language models have enabled us to sort of infuse a lot of world knowledge, linguistic knowledge upfront into the model, so that when developing certain task-specific models, the need for data kind of goes down. Then there is the whole notion of being able to gather and mine data from public sources, from the web, and etc., which is a good opportunity to sort of leverage and get data at scale for various kinds of problems. So we'll kind of walk through some of these things. So as an initial activity, what we found useful was just curating data. And this is an example from when we started working on machine translation. So all we did first was look at a lot of efforts the community has put in from various groups, gathering little amount of parallel data, putting it all together. And just doing that, I think, gave us around 12 million sentence pairs across 10 to 12 Indian languages that we were looking at that point. And that itself was able to help us build an MT model that was better than anything that was available in the public domain. So cataloging, organizing is a very useful activity. There are many examples of that across the globe. Opus, for those familiar with machine translation, is a very classic example. We have tried to put together an Indian NLP catalog where you can collaboratively submit and edit resources available. And there are similar efforts on the Indonesian side. I recently came across GLOT 500 corpus, which I thought I should mention, because it's an effort to collate language resources for 500,000 plus languages, and that looks pretty interesting. So that's of course the challenge in these curation efforts is that the effort to sort of make it easy to search, navigate, and maintain the catalog over time. But it's, I think, worth the effort and should be an ongoing effort. Now, the first activity to do is sort of to collect monolingual data at scale, which we invested in while building text corpora for Indian languages. And it's the story sort of evolved. We started with just building, gathering, crawling web sources, collecting sentence level data, to increasing our language coverage, increasing our coverage for more sources, which sort of resulted in INDICOP V2. But eventually, I think with LLMs coming in, people have realized the need for one document level, large context, so as to be able to reason and understand a lot of knowledge. Plus the fact that you have to filter, curate data. And so building a pipeline to do this, to get data from various modalities, be it text, be it PDFs, be it audio, and then to be able to filter it is a very important infrastructure to be able to scale our NLP technologies. Because this corpus is kind of the basis for a lot of things, not just for training LLMs, but it's a treasure trove for mining a lot of data sets. So be it translation corpora, transliteration corpora, named entity recognition corpora, everything. Many language generation data sets have just been mined based on monolingual data. So that's important, and this should over time evolve as more corpora comes in. This activity needs to be sort of continued, iterated, and move towards collecting more corpora. It still probably doesn't go anywhere near the 10 trillion target that Mitesh mentioned, but whatever exists for Indian languages, that's an ongoing activity. Right. So that's about unlabeled data. And as I said, this is an example of a very rich resource. And I'll talk about how we could mine labeled data from it. And I'll take the example of machine translation. So for machine translation, what we need is parallel corpora. And so we could mine at different levels of granularity, sentence level, document level. So we started with working on sentence level because that was what MT models were doing previously. And you could do some simple heuristic-based mining. You could, some parallel websites, and you use URL patterns to identify websites and sentence and mine sentences from them. That's not sufficient, right? There's much more parallel content on the web. Can you be more ambitious and say, okay, I just give you millions of sentences in English and millions of sentences in Hindi, and can you figure out what are the parallel sentences? With multilingual embeddings and nearest neighborhood search at scale, we can do that. And with that, we were able to kind of mine up to 200 million sentence pairs across about 14 to 15 Indian languages. And this kind of exceeds any human curated data that exists. And it's been a significant contributor to improving translation quality overall across all Indian languages. Of course, it's important to filter this data. There is noise. These mining systems are not perfect, but that's the better the metrics get at identifying bad translations, the more cleaner our corpus gets and the better we can do. And these are a few more examples of what you can do with monolingual corpora. So we have mined, say, for example, headline generation datasets, summarization datasets, biography generation from Wikipedia. So if you have the Wikipedia info box, and then the first few lines of a Wikipedia article, it is a kind of table to text kind of dataset that you could extract from such a model. So the possibilities are kind of immense. It's just creativity that limits what you could mine. Of course, after all the automated mining, there is a very important role for expert annotation as well, because that helps boost model quality, very high quality data, which I think is understood these days. If you build translation models built on mined data and then fine tune it with human generated data, that gives a good boost in translation quality. And this applies not just to translation, but also many other applications powered by LLMs where high quality fine tuning data is very valued. So the role for experts and annotators lies there. And for some languages, for very low resource languages, this is probably the only way to collect data. There is no way of mining data for many of these languages. Now, when we want annotators to build, to create these data sets, again, we need a scalable way of doing it because this is a very subjective task. So we must put together very clear processes in place. And that's what we tried to do in terms of giving clear guidelines for translations to the extent possible, refining it over time and as we gathered experience, but also selecting the kind of sentences to translate so as to ensure it's diverse. Make sure you have quality checks on the source side before translation, quality checks on the translation itself to ensure the output quality. Along with that, it's also important to give productivity tools to translators so that their work is speeded up and we can make the maximum use of their efforts. So this could be in terms of, say, transliteration tools for Romanized input, or draft translations being made available, glossary support being available through a very easy to use translation interface that you can see here. Right. Okay, so so far we talked about human data, either mined of the web or curated in controlled environments, but increasingly there is the trend towards using synthetic data for training. And I'll just use machine translation as an example. And machine translation has been doing this for quite a long time. For neural MT, it's standard practice to sort of use monolingual data on the target side, translate it so as to create pseudo parallel corpus and get better language modeling, right? So, but increasingly, this is also being used for many other purposes, and question answering data sets are being LLMs essentially use LLMs to create different kinds of task-specific instruction tuning data, which you could use to distill and create smaller LLMs, right? So the important thing there is that you need to filter this kind of data so as to ensure that the quality is used good enough to make sure that the model can do the task it has to do without doing any hallucinations. Finally, a very important part of being able to scale to many languages is multilingual modeling. And I think now we take multilingual models for granted. It's a no-brainer for Indian languages. Whenever we're building any sort of models, these are typically multilingual models. The benefits are obvious. I mean, with much lesser data, we are able to generalize better, do well on low resource languages. In some cases, get good zero-shot performance with or very little training data for low resource languages, which is an important use case. But at the same time, multilingual models also from the deployment perspective improve scalability, because you can have smaller models with the deployment footprint being smaller. You don't have to have a model for every language, say, but just one single model. And one single model means easier maintenance. So from that perspective, also multilingual modeling is interesting. So this is one of the biggest factors that has sort of helped to scale our current NLP models to multiple languages across tasks. Finally, of course, language model pre-training is a big advancement. Now, how does it help? So it helps essentially by encoding a lot of knowledge and thus providing base features on top of which you can fine tune for certain tasks. Now, okay, what are the challenges if you want to use massive pre-trained models that already exist, say, for example, XLMR or MBART or something, can't you just repurpose them, or even the modern LLMs like Llama 3? So as Mitesh also sort of alluded to, there might be limited coverage for Indian languages. Tokenizer representation is an issue. Limited language coverage. They might not support all the languages, and therefore there is sort of a need to have certain, say, India-specific language models which can cater to these demands. But of course, the challenge, as we already talked about, is compute. How do we have the compute to train models at that scale of data that we're talking about today? And also the fact that the models that are trained today are trained with a lot of English data, 10 trillion to 15 trillion for Llama 3. And the data there is valuable, the information there is valuable. Training from scratch, we will be losing all of that. Or we need to kind of account for being able to train with the same amount of data, right? So is there a middle path worth exploring? Can we take some of these well-trained English models, adapt them for the languages, adapt their vocabularies for the languages we are interested in, while avoiding any catastrophic forgetting? So that's sort of the one possible option for LLMs in Indian languages to look at. And finally, like machine translation is itself a big enabler for scalability. And I think we already talked about it, both Mitesh and Ravi mentioned the use of translation as a vehicle for creating data. And it sort of, in many contexts, is just the scale at which English datasets exist. It would take a long time to translate, to create native datasets for it. Probably not possible. But if we can translate at scale, we can create large instruction tuning datasets for Indian languages, enabling instruction tuning. And this is particularly important for today's autoregressive decoder LLMs. Previously, when we were doing classification models, there used to be a fair amount of cross-lingual transfer. So you could still do cross-lingual transfer without having to translate, but that's not necessarily the case with decoder LLM. So that's important. I'll leave it with a final thought. We talked about translating training data, but what about evaluations? That's a very open question. Are machine translated benchmarks good? There is an increasing usage of these benchmarks, but there are studies that point out that quality issues do result from these kind of translated benchmarks. And they are probably only applicable even then as some sort of an indicative guide when the translation quality is reasonably good. On the flip side, there are also studies which sort of show that even human translated benchmarks for low resource languages are low quality. In fact, in some cases, the machine translated ones tend to be better. So there is judgment and caution to be exercised in both cases. So to summarize, what is the recipe for scalability that the community has discovered over the last few years? So it's train these large pre-trained models on huge amount of corpora in a multilingual way, mine data sets, and I would say today even synthesize data sets using LLMs, fine-tune using these data sets, and then create benchmarks for evaluations. Now, what are interesting directions going forward? So English LLMs is a reality, trained on humongous amounts of data. So how do we make sure that we can do good cross-lingual transfer from English, other than basically having to translate everything from English into other languages? Are there good ways of doing it? Synthetic data generation, both for fine-tuning as well as preference data generation, are other rich areas sort of to look at for scalability. And finally, evaluation. I mean, that's a very central challenge. How do we evaluate the ever-increasing complex NLP tasks? And here, I think machine translation has some lessons to give, because I think machine translation sort of has a lead and has taken the lead in doing learned metrics, which correlate with human judgments and are increasingly showing to be doing well. LLM-based evaluations are starting to pop up, and how do they pop up for the multilingual scenario? We need to see, but those look like interesting directions to look at. So with that, I'll close my talk. Thanks.
Thank you, Dr. Anup, for the nice talk. Yeah. We'll take only one question due to interest of time.
Okay, Anup, as usual, very contentful. Just wanted to tell you that the translation seems to be promising. This EMNLP, we have a paper on translation. It's me, Toshi.
Yeah, exactly.
And we show that the performance decreases only marginally, 0.84, 2.84, that kind of points. So I just wanted to make this comment.
Yeah, that's a valid point. I think increasingly, even for pre-training, like the use of empty data is promising. Yeah, it's probably only the scale of translation that needs to be done to do the training, and the resultant increase in training data for the LLM is a concern.
Yeah, thank you, Dr. Anup. I request Professor Vasu to. Thank you, Dr. Anup. I think I took permission from Anchor that I want to introduce this session. Actually, I think it may take a couple of minutes for setting up this one. So the current session is the linguistics in the era of LLMs. It just come to my mind that, LTRC also playing a lot of role in reply IT, not only in the linguistic education, also in the value education, right? So these LLMs issues, you see that hallucination and something, right? So, and also I think LLMs or the neural networks are mainly motivated by the human brain, right? So you see, currently the issue is that, we feel that we are developed, or, we are something, and at the other hand, we are missing the values. Maybe whether values are required or not is a debatable question. So I think similarly, LLMs also maybe the values like linguists are something maybe missing. Maybe we'll see what is the role of it. Okay, I think who will be the better moderator than Professor Sangal, right? He's also a accomplished linguist and also human activist. Over to him. Thank you.
Yeah. I want to invite Professor Pushpak Bhattacharya, Professor Deepti Mishra Sharma, and Dr. Manojit. And we have two other panelists online. And I'll be Professor Joseph Janabit at DFKI and Soumya at the Canadian National Research Center. So since we have a large panel and the time is short, I'll quickly give a brief introduction and then we can jump into the panel. So first, so the order, I'll introduce them in the order in which they will be presenting. So first, Professor Joseph van Genebith is one of the scientific directors of the German Research Center for AI, DFKI, the well-known DFKI. He heads the Multilingual Language Technologies Lab in DFKI. He's also professor of translation-oriented language technologies at Saarland University, Germany. He was the founding director of the Center for Next Generation Localization, now called ADAPT. His degrees, I'm not mentioning everything, just briefly. His first degree is in electronic engineering and in English from Aachen, Germany. So it combines both, I suppose, language degree, language training, as well as computer science and electronics. The second speaker would be Professor Manojit Chaudhary, Professor of Natural Language Processing at Mohammed bin Zayed University of Artificial Intelligence at Abu Dhabi. Prior to this, he was principal scientist at Microsoft Research India and Microsoft Turing. He is currently also professor of practice at Plaksha University and adjunct professor at IIIT Hyderabad. So he visits. His research interests lie in the intersection of NLP with social, cultural aspects of technology use and ethics in particular. Been working on multilingual and multicultural aspects of large language models and their use in low resource languages. He also chairs the Indian National Linguistics Olympiad and holds his education is in BTech and PhD degree in computer science from IIT Kharagpur. We have then Dr. Soumya. She's the NLP researcher at Digital Technologies Research Center at National Research Council, Canada. She's joining us online. And she has experience in building data science teams at Canadian industry setup and was also a faculty member in an American public university. She did her PhD from Germany, University of Tübingen, and is a proud alumnus of IIIT Hyderabad. Current research interests are information extraction, multilingual models, reproducibility, and evaluation. Then we have Professor Pushpak Bhattacharya, already introduced earlier also, Professor of Computer Science and Engineering at IIT Bombay, and he served as Director of IIT Patna, and he also served as the President of the ACL, as a Fellow of the National Academy of Engineering, Abdul Kalam National Fellow, serves as editor for Journal of Natural Language Engineering and AAI's AI magazine. Published over 350 papers, supervised more than 300 students at all levels. And I'll skip the rest. I'll go to Professor Deepti Sharma, Professor Emeritus and LTRC, IIIT Hyderabad, active member. She has made significant contributions to linguistics, language technologies, computational translation systems, etc. Earlier, before IIIT, she was at University of Hyderabad, and she's contributed to major projects, IL, Indian language to Indian language machine translation, dependency tree bank, development of dependency tree bank in Hindi and Urdu. She holds PhD in linguistics. So I think we'll jump straight with the panelists, and I request Professor Joseph to, so what we have done is we have 4 minutes each for the panelists. And after that, 10 minutes for any cross questions or issues that have arisen. And then we have last 10 minutes for the audience. This is what we have planned, but let's see. It's a little tight. So Professor Joseph. Yeah, kindly go ahead. Can't hear you, Joseph. Yeah, still not able to hear anything.
Yeah, can you hear me?
Yeah, now.
Okay, very excellent. At the moment I can't hear you, but I guess we'll just make the best. So first of all, I would like to say heartfelt congratulations to this momentous event, the 25th anniversary of your institution. It's an amazing achievement. The impact you had in India, but also on a truly international stage. It's amazingly impressive. Congratulations to that. And I'm very much looking forward to the next 25 years. I'm not sure I'll be at the next celebration, but it'll be amazing to see what our younger colleagues will have done by then, I'm quite sure. So let me say a few things about linguistics and large language models. Natural language processing, it's probably fair to say, is a young science. It's sort of like, I don't know, maybe 60 years old, 70 years old. And it's very typical of young scientists to rapidly undergo paradigm shifts. And we had a couple of those paradigm shifts in natural language processing and computational linguistics. Those sort of like rule-based approaches that were inspired closely by linguistics. Then we had approaches that were based on statistical estimation. Then we had classical machine learning. And now we are, of course, in the age with amazing successes of deep learning and large neural networks and large language models, etc. Actually, at the very, very beginning, taking a slightly historical perspective, at the very, very beginning, and here I mean the 1950s and early 1960s, there was not that much linguistics in natural language processing. And the results were not always very impressive. And there's a famous report, mostly focusing on machine translation, but not just on machine translation. It's called the ALPAC report. And I think it was issued in 1966, where a committee, I think they're called Automatic Language Processing Advisory Committee in the US, looked at the advances in machine translation in the mid-1960s, and they were not very impressed. And what they came up with is a diagnosis, and they said, like, actually, the way you're trying to do machine translation is a little bit naive, and it doesn't contain enough linguistics, and actually, we don't even know enough about languages yet. So they recommended to do computational linguistics, so like, study languages and linguistics, but also doing computational approaches. And in some sense, that is maybe the birthplace, or one of the birthplaces of this close intertwining between linguistics and natural language processing and computational linguistics. And I think that gave rise to an amazing flurry of new results and systems, and it still continues today to some extent, and I think for good reason, for very good reason actually. But it also hit a wall. And the wall is very often to do with the fact that natural languages are just so amazingly complex. One word, many meanings. One meaning, many words. Metaphorical languages, context dependence, etc. And that's just really, really hard to capture with rules. And if you try to do this, and you try to do this at scale, you end up with so many rules that you kind of like, it's very hard not to create a Frankenstein, because it's so complex that it's almost impossible to sort of like rule in some sense. And of course, at around the same time, there were alternative approaches such as like, the statistical estimation, like at IBM for acoustic speech recognition, but also machine translation then a bit later, then classical machine learning, now deep learning. And actually, some of the ideas, like looking at words and text as vectors, are actually quite old, because they're really old hat in information extraction, information retrieval. Like, of course, like to people working in information extraction, information retrieval, words were vectors, or words are vectors, and documents are vectors, like TF, IDF, for example. So, I think, in terms of scaling, in terms of amazing systems at industry scale, I think the direction is clear. I think neural networks, deep learning are just really, really amazing. They have lots of problems, but there's lots of research on that as well, on trying to address these problems. But at the end of the day, I think my take would be that whatever's going to happen in the future, linguistics is important, and it's super, super important as a language and a conceptual system, as Rajiv always emphasizes. Linguistics as a language for talking about language. And that's really, really important also for our engineers that are very, very well versed in the latest methods in deep learning and machine learning, etc. It's really important to have a language to talk about the object of your science. And I think I think that's sort of like where linguistics will remain, like even in this age of deep learning. But it goes beyond that, because of course there's still very many open research questions in languages. There's no single language that is sort of like completely covered by linguistics, and there are interesting research fields where you have a pairing between deep learning and linguistics. So, for example, there's evidence that activations in large language models actually correlate to brain activations, and I think that's really interesting research. And I think with that, I think I've well covered my 3 minutes or 4 minutes, and I'm looking forward to my fellow speakers. Thank you.
Thank you, Joseph. So we now go to Monojit.
Okay, so I will pick where Joseph left at that linguistics provides a language to talk about language, and why this is so important. No matter what you do with languages, be it deep learning, be it amazing systems, you always need that language. This comes at two places, I think, prominently. One is when we define our tasks. What task to solve. And you might think, okay, some of the tasks linguists had defined earlier, like post tagging, morphological analysis, parsing, are no longer relevant. And whether we agree or not is a different question. But even if I agree that they are no longer relevant, imagine the tasks that we are defining today. You know, NLI, glue. If you take the glue, super glue benchmark on which, or MMLU, these are all linguistic tasks. And not considering linguistics in these tasks actually create a confusion. And I will give you one example. So once you define the task, you also need to evaluate the models. And that evaluation process also, I think, requires linguistics, because unless you have the language to describe the qualities of the sentences that you are processing, you miss a lot of things. I'll give you one example. So we were working on natural language inferencing. And those who have worked with NLI and used NLI datasets know or would have observed that it's a mixed bag. You know, I mean, you have a hypothesis, you have a premise, and the relationship between the hypothesis and premise, whether it entails or not, could be because of various reasons. It could be a logical entailment. It could be a temporal entailment. It could be a spatial entailment. And linguistics provides very neat framework to, it could be an implicature, it could be a presupposition, and there are great frameworks, but nobody has used them. It's a mixed bag. So we started classifying NLI examples by their linguistic categories. We call it taxi NLI, a taxonomy for NLI. The data set is out there. But the interesting observation was, we saw that Swahili had very low scores overall. And the point was, why Swahili, out of all 7-8 languages we looked at, including Hindi, which is low resource, did not have that low score on the task, while Swahili had. And once we looked at different classes, it was not that Swahili was low consistently across all the classes. It was one particular class, which was when negation was important to understand, do the logical processing. So further logical would be negation and or, right? These are the three logical things. So negation. And then when we looked at the data, what happens in Swahili in negation is you add there is no single word like not for negation. Right, in Hindi, we have nahi, mat. In all these other languages, we had particles for negation. Swahili didn't. What Swahili had was a morpheme which connected to the verb, and that morpheme changed with the subject and tense. Now, what happens is when your tokenizer gets it wrong, you can never get negation. Now, that whole story I told you, just think of how many linguistic terms I used. And I would not be able to tell you that story and give you that insight and analysis if I did not consider linguistics. So I think that's the crucial role when it comes to, let's say, evaluating and getting deeper insights on where a model is working and where it isn't. And while structural linguistics is important, but I think the models today are so smart that we can go much more beyond, and we can look into pragmatics. We can look into sociolinguistics and those kind of explanations, which opens up whole new areas of research, I think. And the reverse is also true. We can now use generative AI to study, let's say, model sociolinguistics at scale and so on. So it's both ways. Not only linguistics help generative AI can also help linguistics. And I think it's very, very needed. Let me stop here.
Thank you. So we'll now go to Soumya. And perhaps Soumya will tell us what is important, linguistics and or not.
Can everyone hear me?
Yeah.
Okay, good.
Yes.
Okay, first of all, congratulations, LTRC. Congratulations to all of us for the celebration. I'm very happy to be a part of this panel. And thank you for Professor Joseph and Professor Monojit for their insights on the role of linguistics in the era of LLMs today. So I'm going to take a slightly different perspective because a good discussion needs all perspectives and say maybe we don't need as much linguistics today. I have mainly two things to say. So the first thing is domain expertise. So we are seeing large language models in many places beyond NLP, beyond traditional NLP tasks. So just yesterday there was a panel discussion on multimodal models in this event. So it's not just about language anymore. And even in terms of end user applications where large language models are being used or where NLP is going, it's going into many different disciplines, and there are many different applications coming up, real world applications. So at that point, then the next question is, what do we really need beyond the technology? Is it domain expertise or is it linguistics expertise? Linguistics itself can be the domain in some cases. Like say, for example, I'm building a grammar checker or something like that, and knowledge of grammar of a language, that itself is the domain expertise in that particular case. But let us say I'm developing some NLP application for some finance or something like that. Traditionally, when we think of where do linguists come into picture when we are developing NLP systems, we think of data annotation, labeling, and coming up with evaluation sets, evaluation strategies, doing qualitative analysis, and these kind of things. So all these things, when you're looking at a specific domain, needs, in my view, needs more of a domain expertise than specific linguistic expertise. So, and if you look at the problems with LLMs, like say with bias in models or hallucinations or things like that, these problems are not just technical or linguistic in nature. So there is potential socio-technical, socio-cultural angle to it. So like Professor Joseph and Professor Manoj said, linguistics probably helps us in describing what the problem is, because it's a language about talk about language, but maybe it does not offer clear solutions for these kind of problems. So what I want to say essentially is maybe we need a different form of linguistics, probably not the kind of linguistics that we've been using in NLP, like say, for example, things like say part of speech tagging, constituency parsing, dependency parsing. Maybe that's not the kind of linguistics we need for LLMs. Maybe it is some other form. And finally, like Monojit also said, linguistics also may need some large language models today. Like in even EMNLP last month, there were some papers on using LLMs for glossing endangered languages. When you talk about glossing endangered languages, you think about field linguists, talking to people, documenting the languages, and so on. But here now we are talking about using large language models to gloss endangered languages, even though we don't know, whether the large language model already saw this language or something like that. Because at a higher level, you can think of large language models as being able to learn some kind of relationship between symbols, if not specifically language. So yeah, so that's essentially what my stance is. Maybe we need domain expertise more than linguistics, and maybe we need some other new parts of linguistics than what we've been traditionally using for NLP. Thank you.
Yeah, thank you, Soumya. I look forward to discussions on each of these points as we go along. I request now Professor Pushpak Bhattacharya.
Okay, I'm going to make a few remarks which are actually borrowed from the NLP course that I teach. So some of the things I say there, and I think they're relevant here, is that linguists are also actually data scientists. They discover patterns, regularities from language data. Now, I have seen the history of Paninian morphology, and have come to know that Panini used to move, over villages, towns, and so on, listening to what people are saying. And then Rama, okay, where the lexeme is Ram, and the Subant, okay, the Pratipadik coming and attaching with Ram. So these generalization of Subant, Tingant, etc. for verbal forms, they came from observation of lots of linguistic data. Okay, so I would like to call linguists also as data scientists, and linguistics is a kind of data science. Now, if we look at natural language processing, this also I tell my students that there are two pillars on which NLP rests. One is linguistics, the other is probability. One is language science, the other is data science. Now, linguistics, as has been said before by my co-panelists, linguistics comes at the stage of preparing data for training in models. So part of speech tagging, for example, is a task where annotated data is required. Now, designing part of speech tags is a very intricate exercise where both linguistic insight and computational insight are needed. If the part of speech tag set is very coarse, it is not useful in the downstream NLP application. If it is too fine, too fine grain, then the classification accuracy is very low. Again, not being useful in the downstream applications. And where is probability used? Probability also, yeah, linguistics is used in interpretation of results. I have an experience similar to Manojit's. When we started building statistical machine translation systems in 2010, 11, 12, that period, we found that Dravidian languages, it was Anup's work actually, Dravidian languages show very low accuracy in the N by N blue score matrix. Dravidian languages show low accuracy. And we understood that this is because Dravidian words are extremely agglutinated. And unless you segment and pick out, bring the morphemes and establish alignment mappings for them, the accuracy is bound to be low. So this comes from the linguistic insight of how the Dravidian morphology behaves. Now, coming to probability, one of the key foundations of a deep learning system is the softmax function, which shows that a neural network can compute probability. And that probability distribution is compared with through the cross entropy loss function with the target distribution. And that is our bread and butter. So the other very important point is that whatever with the underlying distribution, if you have a sufficient amount of data, then central limit theorem says that we can make use of normal distribution approximation, whatever with the underlying distribution. So these are extremely powerful conceptual instruments which give us theoretical tools to move forward. And finally, we see what is our bread and butter as a researcher. We understand language phenomena and then use mathematical tools to create a model out of it. We are empowered by the fact that neural networks can be universal function approximators. So this the mathematical model is now cast into the neural network, which is a universal function approximator. We bring the results, we do analysis, compare with baseline, and write the paper that is an advancement on the field. So this is our bread and butter. This actually happens. Okay, the blind feeding of data into a machine learning model, obtaining the results, is not really common, as even if we would like to think about it. Yesterday, there was a beautiful talk by Dr. Sriram, Journey of NLP from Glass Box to Black Box. Okay, he touched upon many of these very insightful points. So my point is that we need a balance of language science and data science, in particular linguistics and probability, giving lots of importance to both. And the final point is that linguistics is needed not for the machines. Linguistics is needed for NLP researchers. We get our insight, inspiration, energy from linguistic insight. This gives us a kick. And therefore, we take up interesting problems and do NLP. If large language models want to do NLP research, they may not need linguistics, but we human beings need.
I'll request now Professor Deepti Sharma to.
So I'll start with an example. Very recently, one of my students gave me his thesis draft to review. When I started reading the first para, I found it, I was very impressed and I said, wow, this guy knows his English. Second para, some doubt set in. And I thought, is it his English? And third para, I was quite confident that this is ChatGPT. I called him and he said, yes, ma'am, only for introduction. Because I tell my students not to use ChatGPT for a reason. I don't want to get into it, but a very well-found reason. So I obviously I sent him back. I said, write it yourself. What it left me with was I mean, how come I was able to identify that this was not written by a human being? English was beautiful, very fluent, ideas were presented well, but there was some element in the entire thing which made me identify that this is not written by a human being. So this needs closer study before one can come to some conclusions, and linguistics is needed to actually identify what is happening there. Now I'll bring in another aspect. When Chomsky appeared on linguistic scene, he came up with new proposals and ideas which were really quite, one would say, even revolutionary when people were studying the way people were studying linguistics. Amongst his many ideas, there were some two or three very core ideas. One was competence, performance. I just want to talk about these. Now, competence, according to Chomsky, was the knowledge that a speaker of a language has. The knowledge using which the speaker of a language can then form sentences. And Chomsky, by the way, was only looking at the structural aspect of language. And performance is the other aspect. And performance is use of language. And Chomsky was not interested in performance. Why? Because performance had noise. He didn't say noise, but noise in the sense that they were unstructured sentences. They were not, there may be disfluencies, and there was variability. Variations were there. So all that was distracting from looking at language from the point of view when you're looking at its mental process. So Chomsky put performance aside and focused on competence. Chomskyan research gave a certain direction to research in linguistics at that point, and which has remained. But there was, and was well accepted, but there was a section of linguists, anthropologists, in fact, who were looking at the language of certain communities very closely. And these anthropologists, linguists, were not disagreed with Chomsky. And they said, well, you cannot put performance aside, because performance is an important component. So Chomsky was not looking at language as an instrument of communication. Chomsky was looking at language, and it's a very interesting aspect of language, the way it is working in our mind, the psychological aspect. Whereas the people who are working with the language of the people in a society are looking at language as a means of communication. And for them, performance was an important part. But they didn't say performance, they said, you cannot stick to the competence of the type that Chomsky was talking about. And Delheims, one of these scholars, came up with the idea of communicative competence. Now, communicative competence talks about, or rather, when you start looking at language in use, there are aspects of language, and at this point, I'll say there are intra-language aspects and there are extra-language aspects. Intra-language are that we are talking about structural aspect of it. So you can talk of pure stacking and the way sentences are framed, or whatever information is there within the language itself. But when language is being used and a human being is using it, there are aspects of language. And for this group, the social linguists, variation was very important. They said variation is integral to language. And therefore, you cannot put variation aside. You have to look at it. Now, what does variation do? This gives choices. And a human being uses these choices consciously. And then what becomes important is what is being spoken, where, to whom, and when. Now, this is the extra part, and this is equally important. And I'll just, we can take it up later, because all the points that others made are important. So what Soumya said, and I think Manojit also said, that structural part may not be important anymore when we are doing the kind of NLP we are doing today, but there are aspects which are still unexplored and which need to be incorporated when we are talking of conversational. And I'll just take use an example from my life. I was 14, 15 years old, and a cousin who was much older than me was visiting us. And I have to apologize to Joseph because I'm going to use a Hindi example, but I hope my tone will tell you something. So he was much older to me, was visiting, and my brother was just 1 year old, and another brother who was 4 years older to me, and this cousin were sitting in a room and chatting. It was dinner time. My mother sent me to call them for dinner. So I entered the room and I said, Kukku Dadda, and Dadda is the term we use for addressing the elder brother. So I said, Kukku Dadda, khana khane chaliye. Arun Dadda, khana khane chalo. Pappu Dadda, chalo khana khane. Same vocabulary, more or less. Same syntax. Now it had a lot of other information in it. The relationship, my relationship with each one of them, and lots more. So these are the aspects of language which are still unexplored and have to be incorporated in language if we want to do NLP for use as human beings use it. I'll stop here.
Thank you. I think lots of interesting questions have come. But let me start from, what Joseph said. And he talked about the, how historically, how things happened in NLP. And initially, the LPAC report, which actually killed all funding for machine translation, that was its impact in America and then followed in Europe and Russia. It said, no, you should study language. And in a way, he said computational linguistics developed because of that. But as these grammars were being written for use by computers, they were clearly inadequate. The existing theoretical grammars which existed could not be used directly, and so on. So, at some point, statistical NLP came in. But statistical NLP maintained, there was scope for maintaining the linguistic divisions, if you will, in linguistics knowledge, if you will, in morphology, in phrasing or chunking, followed by dependency, analysis, and so on. In artificial neural networks, all that is gone. So what do you say about that? That this change that occurred, so statistics and linguistics actually married each other, contributed to each other, and gave birth to many interesting systems. And then came ANN, they said, no, we don't need any marriage, we'll do alone. So what would you say? Yeah, to you, Joseph.
Can you hear me?
Yeah.
Yeah, excellent.
Again,
I think the
low.
I think the sort of like I don't know whether you can call it a divorce, because you used the marriage metaphor, which I think is really nice, But I think the sort of like the divorce between statistical and methods and linguistics happened already to some extent in ASR and in statistical machine translation, because the notion of a phrase, for example, in statistical machine translation is not the same as the linguistic notion of a phrase. It's just a contiguous sequence of symbols that is matched to another contiguous sequence of symbols in the target language using alignment probabilities, kind of like, And I think in early statistical machine translation, there was quite a bit of discussion and also criticism, because from a more traditional linguistic background, people were asking why don't you use phrases or chunks, sort of like linguistically motivated chunks, like, I don't know, prepositional phrases and noun phrases and verb clusters or or something like that. And some of the early papers in statistical machine translation tried to answer that question. So there's one by I can't remember the Philip Kuhn, I think is one of the co-authors, where they actually chunked the training data, the bytext training data using linguistic information. I think that they used the chunking method where they in the languages that they looked at, they looked at the function words. So every time you had a preposition or a determiner, you have some indication that maybe sort of like a noun chunk is starting. When there's a preposition, maybe you have some information that a prepositional chunk is starting or something like this. And then they restricted the phrase extraction for that statistical machine translation system to the linguistically motivated phrases, and they found that the results go down because you don't capture this sort of like really crazy variability. So I think already in that work, there's sort of like some divergence between linguistic ideas and more purely statistically motivated ideas.
Okay. So I want to jump to this other aspect of domain expertise, domain knowledge versus linguistics based knowledge. Now, linguistics gives you a structure that would be very general, and indeed that generality can be useful. And Professor Pushpak mentioned about, what is the structure of, for example, he gave the example of part of speech set, tag set. It should not be too fine and it should not be too coarse. So the domain knowledge should not be too fine and not too coarse. What would you say if linguistics is already giving you a level which is not too fine, and hopefully it is not too coarse? But when you go to structure, dependency, relations, it's already giving you a structure which is not too fine. So what would you say about that? Soumya.
Yes. I probably want to give a more real world example that I encountered recently, where I was in this project where we were doing text classification, which probably is like considered the most straightforward way of doing it. And with LLMs, there is no linguistics involved, tons of domain knowledge involved, because coming up with the label definitions and categories and then refining them, like do we need 5 labels or 50 labels? If it is 50, we tried to do something and then we realized and reached like 20 or something like that. So a lot of back and forth happened, and all this was done with domain experts in that field. There was, as far as I know, nobody has a linguistics background, but all of them have a lot of knowledge about their own domain and about how this kind of fine-grained versus coarse-grained categorization comes for that particular problem. So that is what I mean when I say maybe it is domain expertise, because traditionally when we think about the marriage between NLP and linguistics, we think more from a from academic tasks, right? But today we are no longer limited to academics or research, and we are using all these things in a wide range of application scenarios, which is why I think maybe domain knowledge can also be fine or coarse-grained and can be adapted to the problem.
So this is on this issue, because it was said by more than one of our panelists, that perhaps structures are not needed. Dependency or whatever other structures are not needed in linguistics. And you said, no, now we need domain knowledge. So what I'm trying to posit is that if you have used linguistic structures, the right structures like dependency, they are your first level of domain knowledge. So Monojit, you would like to say something on this?
Yeah, you are definitely right. I think that when you are trying to study or model any domain, you need some sort of categories. And the moment you start talking about categories and their relationships, you are back to linguistics in some sense. And again, to give an example, very similar to Soumya's, so we talk a lot about reasoning these days. You know, LLMs can't do reasoning, etc., etc. But the question is, what is reasoning, for instance? So we are trying to build, let's say we are trying to build an LLM that can do financial reasoning. It's a real story. We had this debate. We have been having this debate, actually. So the question is, what does you expect the LLM to do? That is fine. We know that we want this LLM to compute my tax, for instance. We want this LLM to advise me on which stocks to purchase. So the applications are clear, and that comes from my practical sense of the world, business value, etc. But the point is, tax, if you think of, it depends on the tax laws, which vary by country, vary by year. I don't want the LLM weights to have that information. That should be provided separately. Then what do you want the LLM to know? And it's a very hard question, because then if I think of a chartered accountancy paper, is it that you want an LLM to pass that exam? But does that actually mean that your LLM knows the thing? So then we are back to, okay, LLM should know compound interest, simple interest, maybe what is a stock, what is a, what is tax, what is income tax, different kinds of tax.
What is a loan?
What is a loan? So maybe it should know those relationship between those, and everything else can be provided as a separate outside information. So this is exactly what sort of is a dependency structure that you are talking about.
Yeah.
And I think since we don't have these structures at the moment, people have ontologies, but I agree with Soumya there that the way to look at things with LLMs and without LLMs might be different. And once you start building those structures, I think we will have a lot of handle over how to build agents, for instance, because we are struggling with it now and people are doing, just common sense.
So the argument that was made about structures, so phrase structure for the entire sentence may be less useful compared to dependency structure. And Panini actually worked with dependency. He gave the Visheshan Bhav, modified, exactly the dependency structures. So linguistics provides you the first layer of domain knowledge, if I use that word, but it's not domain specific, it is general. But let's shift topic now. So structural linguistics gives you that domain knowledge. That's what the point I was trying to make. But the other important points which have come, that language is not only about individual sentences and their structures. Language is about, beautiful example of honorificity. Khana khale, aap khana khaiye. So and two different ways of saying, and when you talk about connected discourse, across sentences, then there is an element of reasoning also comes. So would you think, this question to Professor Pushpak, do you think that by doing so, by introducing sociolinguistics, honorificity, etc., would that be very important if we want our even generative, I'm not talking of translation anymore, just generative models, to generate text which is coherent, which is meaningful, which makes easy to understand, the reasoning is clear. Coherence means that the reader can follow what the line of reasoning is in a way. So what role do you see of these theories of sociolinguistics, honorificity, discourse, grammars, and so on?
Right. So I'll come to this point very quickly. But before that, I want to draw your attention to one important point. So this layer of lexicon, syntax, semantics, pragmatics. Okay. This Montego semantics was a very powerful, though limited framework where it said that you can compositionally build semantics out of syntactic trees. Compose the meanings of subtrees, and then the composition of and then the whole meaning of the structure will emerge from that. But then it was found that, as Deeptiji pointed out, there are things beyond these syntactic structure, compositional semantics, and there come these phenomena of implicature, deixis, then presupposition, okay, information order. Why is it that you can say the flower vase is on the table, but you can't say the table is under the flower vase? Okay, so this is the information structure. All these are pragmatic phenomena, and they are beyond syntax semantics. Now, one of the most practical applications of pragmatics in action is chatbot, really. So, which is where theory and practice are very, beautifully blended. Now, we have a paper in this year's ACL where we wanted to investigate the pragmatic capabilities of large language models. And we studied this phenomena of deixis, preposition, implicature, etc. And we found how powerful these LLMs are and where do they stand with respect to human performance. Now, the point I want to make here is that when we ask this top level question, what are the pragmatic capabilities of large language models? Then we recognize the presence of pragmatic phenomena. Then we are helped by the linguistic work of what are the different kinds of pragmatic phenomena, and how are these pragmatic phenomena handled by large language models. So my favorite slogan is linguistics is the eye and computation is the body. Without this question being asked and then understanding the categories of pragmatics, we could not have embarked on this task of investigating the pragmatic capabilities of large language models. So I would like to say that, to answer this question, all these phenomena are very important to be understood and modeled and then implemented and investigated for their results.
So, pragmatics relates to the intention of the speaker, what the speaker wants to do through language utterance, language as an action, the famous thing. Now, intentions, if you also bring in intentions now, so structures, social linguistics, and intention, that is language. So it's very much a part of language and linguistics. So therefore, if you are going up to intentions, it's all the more important that you should bring in linguistics. You want to comment on this, Deepti?
Yeah, so one comment is, it looks like the entire panel, except Soumya, to a certain extent, not fully, disagree. But the entire panel seems to be fighting for linguistics. So that is important. I would say, see, pragmatics is important, and that's if we look at language in the way where we say there are these layers, and then pragmatics is naturally the next layer. It is important, I would say. But I was talking about this when I brought in social linguistics example. I was talking of another aspect of language where there are choices before the speaker, and the speaker is making one choice in any given context, and those choices are expressions of not just what the linguistic content of the utterance is, but expression of her social identity, her assertion as a social entity, her assertion of relationship with the person she is speaking, her own maybe certain kind of political opinions. All that comes through language, where you are not explicitly mentioning it, you are not lexicalizing it, but it is there. So that aspect, I feel, it's very challenging, but that is one aspect of language which you cannot leave behind or aside and talk of modeling language.
So I know this field is very big. So should we take up some questions now from the audience? Yes. Professor Uma Maheshwar Rao.
Okay, this need not be in the form of a question, right? It's a kind of comment. What I have heard about the speakers now proposed before this audience. Actually, in my opinion, NLP is linguistics. It is not actually technology. Technology is built behind it, and then that is used to process language. Processing language is part of linguistics. And then developing language technology tools is again actually a process of developing tools. So in between, whatever you are using, you are actually simulating language. Simulation of language is actually part of linguistics. And like Chomsky, etc., they are actually trying to build models of language in the mind. Whereas in the performance model in the society, people are building actually how this can be modeled out when the communication is actually going on. Now, between these two, actually, I can give you a kind of metaphor. All life forms move by locomotion. All life forms move by locomotion. Now, for that, they use different kinds of locomotive organs. Let us say human beings, they use legs. And now, they can walk, they can run. And also at times, if they need and there is a demand, they take different types of vehicles. And the building these vehicles to perform the same thing, like a simulation of locomotion of life forms, achieving the end result is actually moving from place to place. And this movement is again a locomotion of life forms. So activity and language is an activity, as you have said.
Speech
right?
acts.
And now that is actually done through the technology is being built. But what is done here is actually simulating the activity. So this is linguistics. NLP is actually essentially linguistics. There's no difference between the two. Yeah, that's my.
Okay. Yeah. Parmeshwari. Dr. Parmeshwari. Yeah. And after that, Bapi Raju.
Thank you. So both the fields, especially linguistics and NLP, have grown with data. Data is the centric for both either language analysis or generation here. And both the fields have evolved over a period of time. But at one point, linguistics have been stagnant because the theories and models that are being built are limited. Let's say a post-Chomskyan era, the kind of linguistics theories that are come up are handful, not many. But on the other hand, in the field of NLP, it has grown into different stages. Now, what do you think? What are the limitations and biases with the current linguistic theories? Like whether LLM can leverage the linguistic research in the future? If so, in what are the other ways?
So, any of the panelists?
I'm not sure that I will give you a very correct answer, but linguistic theory, in fact, post-Chomsky continued to grow quite a bit, okay? There is neurolinguistics, there is cognitive linguistics, there is psycholinguistics came post-Chomsky, and sociolinguistics as a field actually developed post-Chomsky. So post-Chomsky, a lot of linguistic theories have come, and I'm not covering them all. And cognitive linguistics is one that actually happened as a reaction to some of Chomsky's claims. And that's a field of research that one needs to probably look in, and people are already, I'm sure, looking. All those who are doing NLP and cognitive linguists are coming together to look at it. Yeah. That's what
Joseph,
I feel.
I just wanted to make another quick point about the data part that you mentioned. That's very true. Both the fields depend on data. And one of the limitations of linguistics is because humans look at the data. You cannot, I mean, if you don't go to quantitative or computational linguistics, then you cannot really study large-scale data.
I know.
So if you look at sociolinguistics literature, like when we were looking at code mixing, for instance, there are very limited studies, maybe with 10 participants here and 5 participants there. But with computational power, you can do these studies at a much, much larger scale and come up with very interesting generalized theory. And very quickly, one example about honorifics. So recently we did a study of how in Wikipedia, in Hindi and Bengali, personalities are referred to. When is up used and when is up not used. And interestingly, in Hindi, there is a strong sentiment-based division. Like you use up when there is a positive or neutral sentiment, but not up when there is a negative sentiment. Like terrorists, right? Articles on them will not use up. Bengali doesn't show that pattern. You use up for everybody except for children. So those linguists have never documented, and now we can do that.
Yeah, that's a good point, that we can use these tools to do further linguistics. Now, Professor Joseph wanted to say something.
Yeah, maybe I think maybe linguistics and data-driven approaches need each other, because if you just look at language data, there's a phenomenon that is referred to as reporting bias. So the way the way we use language is for communication, and of course we do not communicate what everybody knows. Okay, so if you try to learn, for example, event descriptions from large data sets, like, in the old days of AI, these were called scripts or something like this. Somebody goes into the restaurant, they sit down, they order a meal, they enjoy the meal, they pay, they give a tip, they go out or something like this. If you actually look at large data sets describing this, a lot of the stuff is just not mentioned, because we don't use language. I mean, this is like, if we use language to just communicate what everybody knows, somebody would call the ambulance and they would come with and say, "Sir, please come with us. You need to relax a little bit." Or we sometimes violate that sort of like communicative function of language, which is really focusing on the new and a little bit of what is known. We violate that consciously for jokes or for stories or something like this. And so I think in that sense, I think there is a point where, of course, like, in data science and in large language models, you train on massive amounts of data. But that data itself is also not neutral. It doesn't always tell you the full story. So I guess even there you have a fruitful, I don't know, a fruitful basis for some kind of a marriage.
Yeah, we lost the sound. We lost the sound, Joseph. Yeah. Acha, he stopped. Okay. Professor Bapi Raju.
Yeah, actually, I think panel has addressed just now. I was going to say, if we have enough amount of experiential data that's collected, do we see this pragmatics, all these problems that have been traditionally posed by linguists and various other pragmatics is hard, all of this would vanish? I was going to ask Professor Pushpak.
Going to vanish. No, these are phenomena. Phenomena will not vanish. So, so I would like to say that linguistics is required for benchmarking the LLMs. That is the point. So there are linguistic phenomena, and they have been documented over millennia. Now test the LLMs against those benchmarks.
So I have a question. So you think linguistics is not needed for building NLP systems, only for evaluation?
When the resource is in short supply, then we'll need linguistic signals on the data so that the models can still be trained.
But otherwise they are not needed.
Maybe not, yeah.
Yeah, please.
What about social linguistic aspect? Your data, currently the data and models trained on that, and the way you are training the models, will they be able to do this kind of things? I mean, make choices, conscious choices in certain contexts of certain options.
So let's take one particular phenomenon. Shall we say politeness is a phenomenon? Very simple, yes. Politeness, but seems like a very difficult proposition to implement on large language models and so on. So there are different manifestations of politeness, lots of ramifications of politeness. Do we capture all of them? Who is asking this question? Somebody who is, isn't it? Who is asking this question? And when will such an entity be capable of asking these questions? Okay, we seem to be in this whole discussion, we seem to be keeping the human being out of discussion. I would like to come back again and again that linguistics is needed not for NLP, for NLP researcher. Okay.
So I want to throw in another idea, but then Vasu is telling me better close. Yeah. If you look at sciences, particularly physics, chemistry, how they developed, what is the scientific method? And what does doing science mean? And based on that, you build technology, of course. It was very clear that science is not just about observation. These are philosophers of science told us that no, science is not just about observation, that you are observing and you see something. No. That you need a hypothesis before you can see anything. Right. And that hypothesis tells you what you are looking for. And then you do experiments or you observe keeping that hypothesis in mind. And after that, you decide whether the hypothesis is to be accepted or rejected. What do you think is the role, or maybe this question I can leave this audience with, that there is this role of theorizing and hypothesizing for doing any scientific work, which is now well accepted. And now when you do this, an hypothesis which pass, which go through, they become theories, and then we use those theories. Now, sometimes those theories are opposed to every single known data point. I think back about Newton. Newton gave something counterintuitive when he talked of laws of motion. So he said, all moving bodies will move forever. I'm paraphrasing him, for moving bodies. For static bodies, they will stay stationary forever. Right? Idea of inertia I'm bringing in. Right? But if you think the implication of that idea, all moving bodies will move forever, and it violates every single experience of every single human being on earth. Now he came up with a theory which violated every single data point. So if you had data science, you never have this laws of motion saying that law of inertia holds. Impossible. So people asked Newton, what do you mean? You're talking nonsense. He said, they stop because there is a counter force. So what is that counter force? He said, usually it is friction, but there could be other methods. So before we can make sense of data, and more importantly, if we have systems that are learning automatically from data, we have to be aware of what the hypotheses or known theories are. And then we can use them and go beyond. And we come up with new theories where we will use these tools. So this marriage between theory and data, this I believe is very important. And it comes up in structures, it comes up in domain knowledge, it comes up in discourse, semantics, pragmatics, and so on. And ultimately, multimodality. So I thought I'll make that statement and then maybe leave, because Vasu will not leave me otherwise. But if anyone has a very compelling point in 30 seconds, kindly do make it. Joseph wants to say something. I can
No,
see.
I mean, it's a joke, and the joke is, in theory, there's no difference between theory and practice. In practice, there often is. So.
Okay. So we will close at this. Thank you. Thank you, all the panelists.
Thank you very much.
Thank you very much.
So, in addition to performing my duty of, one additional thing I wanted to say, this panel discussion is so deep, so intriguing, and so interesting. I would like a paper out of it, or rather a blog that is as a combined authors of all of it. So I think that is something that's my personal request. I hope the panel actually extends their work beyond the panel discussion.
I want to add to that, sir. I also was thinking of a blog post about this panel. So yeah, maybe it will happen. We don't know.
Oh, thank you, Soumya.
Thank you so much. And one, my personal emotion.
So we'll break for the lunch now, and we'll come back in half an hour. Thank you. Welcome to the second session of the second day.
Good to see you, Pushpa.
I'm really delighted to introduce Dr. Sriram Rajamani, again, one of the most dearest friends of IIIT. Thank you so much, Sriram, for being here. Sriram is a corporate vice president at Microsoft Research, and he is also an ACM fellow, INAE fellow, and winner of the Computer Aided Verification Award. His work has impacted both academic and industrial practice in programming languages, systems, security, and formal verification. He is currently working on reimagining the future of programming and software engineering in the era of large AI models. Sriram did his PhD in computer science at UC Berkeley, but then we always add a last line whenever Sriram comes here. He's also a parent of IIIT Hyderabad student. So
Yeah,
Sriram,
thank you.
welcome.
Yeah, the student as well. Yeah, thank you. But my son didn't want to attend my talk. He's gone home. Yeah. So, yeah, thank you. Thank you for inviting me. Such a pleasure to come here. See, my background has always been in programming languages. So I never expected that I'll get invited to give a talk in an NLP audience. I think the only legitimacy I have is that I am using NLP as tools to solve, programming problems. So that's actually my excuse, I guess, for being here. But for the past year and a half or so, this is the topic that I've been increasingly getting obsessed about. I think that's the best way to describe it. And it started by, when first ChatGPT came and the GitHub Copilot came. I'm a proud programmer. My initial reaction was that, oh, it will just generate some code. Maybe it'll sometimes work, but I wouldn't take it seriously. Right? But some of my colleagues from Redmond convinced me, man, it's good, you should try it. Then I installed GitHub Copilot. And I just found that there are a few times when it gave me completions, which really was jaw-dropping for me. I couldn't really believe the quality of the code completions it was giving. So that's how I got sort of sucked into it. And then I realized actually that even though it gave me good completions, it had many issues as well. But the promise that I saw compelled me to work in this area to fix the deficiencies rather than be a non-believer in that. So that's how I got sucked into this area. So what I'll talk about right now is sort of my own journey thinking about, and I've been building productivity tools for a long time. My entire career, I've been building verification tools, testing tools, and so on. More using compiler techniques, runtime techniques, and so on. And I've just been exploring how those can be combined with LLMs, right? So that's actually what I'll talk about today, right? But before I start, right, maybe, I don't know how this clicker will work. What should I do? Should I point to something? It seems to be on. It works now? Okay, sounds good. So I have a couple of introductory slides, on, my own way of how I just got sucked into this field. These large language models and foundation models, you can sort of see the parameter sizes, growing over the years. And what was surprising to me was that these three things, right, the transformer architecture, the self-supervised nature of the learning, and scale. It was just really surprising to me how these three things can together create magic, right? That too, as an outsider to the NLP field, I just found this absolutely amazing that this thing actually happens. I have a colleague by name Sebastian Bubeck. He's in Redmond. He sent me this slide, which I also found absolutely amazing. That he tracked this was a NLP to image model, and he gave this caption, a portrait. He gave the picture, and I think maybe the other way around. He gave the prompt and actually asked the system to generate a picture, and you can sort of see how as the number of parameters increases, the fidelity of the image generation increased. And Sebastian wrote a paper called Sparks of AGI. It's a very interesting paper. And one of the things that in that paper is he tracks actually as to how, as the number of parameters increased, even though these models were trained just for next token prediction, how this emergence actually happened. And as the models got bigger and bigger, at 62 billion parameters, they could summarize text. And most importantly for me, at 540 billion parameters, it could complete code. And that's how I entered into the picture. Right? Once it entered 540 billion parameters, I think it somehow affected my life. Right? Yeah. So this led to many interesting tools. And in particular, the tool that got sucked me into this field is called GitHub Copilot. And the way it works is that it sort of integrates with your coding editor. And as you write code, you can sort of see that it generates completions, right? And I use it every day. And I'm just stunned by how much it sort of understands what I'm trying to do. And it gives me contextually relevant completions to what I want to do. The other thing it does actually is that if I write a comment about, here is the code I want to write in English, it understands the comment and then it actually fills the code that I'm trying to write. It actually is able to generate test cases. I can actually select a piece of code that I'm trying to understand, and then it goes from code to natural language. It sort of explains what this code is doing. It's really, really amazing as to what these things do. And this is not a toy. I think it has over 1 million users. Last year, GitHub Copilot revenue crossed 1 billion. Right? So this is the scale of actually what's actually happening. Every serious software engineering organization now uses Copilot. All programmers use it. Right? That is it has now reached a stage where it cannot be ignored. Right? Which is why I don't ignore it now. That said, actually, even though it is really fascinating, there is still a gap between technology and the problems we want to solve. Right? So, software engineering is very different from programming. That's actually one of the things I learned when I was a student. When you're a student, you actually do various programming courses. You become smart in algorithms, and somebody can ask you a complicated question of reversing an array in n log n, or all kinds of things people can ask, and you can do them, right? But then when you go to a large engineer, and by the way, before my PhD, I worked as a programmer for 5 years in the US in various companies. And one of the things that was a real learning experience for me was how hard it is to work in a team with, say, 100 people. And a code base of size, say, 1 million lines of code. It is so hard. Right? The reason why it is so hard is that typically your manager will ask you to own some piece of the code and ask you to make some changes to it. And you have to do that while building a mental model of this around 900,000 lines of code, which you don't know, right? And it is just a very, very difficult exercise on how to be a part of a large team. And actually, over time, as I grew in career, I used to manage a small team. And it's extremely hard to actually manage a team with 10, 15 programmers just writing code. It's incredibly hard, right? So if you now think about those kinds of problems, right? Suppose I am managing a team with 1 million lines of code. Then can these LLMs now help me do my engineering tasks better? Still, there is a huge gap between the capabilities of LLMs as a nice shiny object and the demands of software engineering as a large engineering profession. And this gap is actually what has interested me to now work in this area, right? But let me say actually that if the LLMs didn't exist, I wouldn't even dare automate, even embark on some of the problems I'm solving, right? So in the sense that LLMs are absolutely indispensable for the kinds of things that I want to do, but they are insufficient today, right? Which is why the opportunity in this research exists. So let me just tell you what these questions are, right? That are beyond the reach of LLMs today. Right? So if you are a typical, this one actually, the first question I actually got from a Microsoft product group. Microsoft people write large C# code bases. And actually the same problem exists in Java as well. And these C# code bases rely on a library called .NET, right? And what happens is actually .NET, they will move from one version of .NET to another version of .NET. And then all of the C# code that depends on the .NET have to now rewrite to move to that new version. Same thing with Java. Java has actually these things called JDK, Java Development Kit, and they produce newer and newer versions, right? And now there are so many hundreds of millions of code that use the Java development, the library. And you have to now rewrite your code in order, because actually for various reasons, they are not API compatible. Even if they are API compatible, they may not be behaviorally compatible. So you have to go change code in order to deal with this version. It's a very difficult problem, right, to solve. So, you can ask, if I have 1 million lines of code, can I now use an LLM to And today, how do people do this migration? They will employ 20 engineers and spend 1 year. That's what they will do. Right? Somebody will go through line by line of code and figure out how to actually move that. The second one is actually, I'll show you examples. Many large engineering teams have code quality checkers. They have various kinds of security issues. These are things you have to deal with if you run an engineering team. And the way people will deal with security issues is they build checkers or scanners that go through your code base and just point out, oh, here is a security error. And these things might, in a large code base, right, they can show 20,000 errors. If you have 10 million lines of code, right, they can give you 600,000 errors they can show you. Now somebody has to go triage each one of them and go deal with them. Again, the only way we need to do that is to actually just put people on it, right? And typically the amount of people you have to put on it depends on the size of the code base, and this is how it works. It actually doesn't scale at all in terms of what you want to do. The third one is, there are new programming languages like Rust. And so I don't know how many of you heard about Rust. Rust is by definition, by construction, it actually eliminates security errors in unmanaged code. There's a lot of code that people have in C, like Linux and Windows, and they are all written in C, right? And there's a Biden directive in the US to write all new code in Rust, right? Because hackers cannot do memory attacks if you write in Rust. But what do you do with all the other code that exists, right? Now, can an LLM can translate between English and Telugu. Can the LLM translate between C and Rust? I mean, it can actually. You can give it one method, you can do it. But you can give 1 million line of code, can it translate? But still, the first question is possible. Second question is not possible today. Right? So this is the problem I'm interested in working on, right? And as I said, right, if LLMs didn't exist, I won't even attempt them, right? But even if LLMs exist, it's very hard to solve this problem. And one of my theses of my talk is actually, in order to do this, you have to combine LLMs with classic program analysis techniques to solve this problem. And I'll give you evidence of this, right? But I haven't solved this problem. It will take many years to solve this problem, right? But I'll give you glimpses of what is possible, right? So the first glimpse I'll give you is propagating changes across what I call dependencies in code. Let me just explain what this means. Let me explain what this problem is and a solution that we have come up with that actually kind of works, right? So I'm sorry for the font, it is green, but let me just try and point that to you here. So so typically this is the kind of thing that people want to do, which is what I'm seeing here is actually a class called complex number. I mean, we just created this academic example where a complex number class has a real field, imaginary field, and so on. And throughout my code, I have complex numbers, but I've represented complex numbers as a pair of floats previously, right? So basically these things, right? Return a complex number is a pair of floating point numbers. That's what this code is returning. Now I'm going to rewrite that code to use a complex number as a class, right, in an object-oriented fashion. This is the kind of thing that people always want to do, right? Now, what I have to do in order to deal with this change is that I have to go to all the places where create complex is called. See, here it returns this variable. I guess it's implicitly typed. This is a pair of floating point numbers that is being returned here. I want to rewrite this to this code that you cannot see because it's not, because of the color, to return a complex number. So now actually, the same functionality, but it returns a different class, a different type, right? The reason why this is a very difficult thing to do in software is that in software is actually you change one line, the whole thing falls like a pack of cards, right? There are so many places where this method, right, which is now returning two floating point numbers, this is called func. Now this func is called within this process. See, this process method calls this func function. And this func function expects now a pair. Now it returns, like it was expecting an apple, now it is getting an orange. It is now getting a different type. Now I have to go to all those places and change that code. Now that code will return something else. So this change can percolate through your million-line code base, right? And today the only way we know how to do that is actually to employ somebody to go do that. And you can ask an LLM. What an LLM can probably do is that you can give it a localized method and then say, how should I change the method, assuming something has changed. But the LLM currently doesn't have the intelligence to do all of this dependency analysis and figure out how to do this in like 5 million lines of code at a time. It just simply doesn't have the intelligence to do that. Actually, one way to put it is that if the entire program can fit into the prompt window of the LLM, I can actually ask that question. But the code is just too large to fit into the prompt window of the LLM. So some people might say, oh, that's fine. I can now build large prompt LLMs. Maybe I'll build 1 million token. So what I find is actually, if you do that, the quality of the output just degrades, right? But no matter how big an LLM we build, I have software that is much bigger than that also. This is, this is life. There's nothing you can do about it, right? So how do you solve this problem? The way you solve this problem, as a programming languages person, these kinds of dependencies, I don't need an LLM to track. I'm a compiler guy. I know how to build dependency graphs. I know what depends on what. I know how to track them. So what we did was actually, this process that I just told you, I can actually implement. This is like, in some sense, actually, together with an LLM planner, I can actually implement a static analysis-based planner that uses all these dependencies, because I know how to build these dependency graphs. And then I can actually have an algorithm where I go through every change, figure out, if this method now returns an apple instead of an orange, who are all the methods that actually call this method that I can figure out statically. I can go to each one of them and I can give an appropriate prompt saying, hey, this method that you're calling used to return an apple before. Now it is returning an orange. Well, how will you now convert yourself? And what thing different will you return? I'll just ask the question to the LLM. The LLM might say, oh, I know how to do this, and now I'm going to return a mango. Now I have to go to call the callers of that method and say, previously you got an apple, now you got a mango. So this kind of analysis, right, that I'm doing manually, I can do that using a combination of a static analyzer that builds all the dependencies, and in some sense, break the big problem of rewriting this into many, many small LLM calls, each with different prompts, right? Because that actually depends on the type information of what comes in. And the static analysis has information to figure out what to call the LLM also. It's a very fine-grained interleaving of static analysis of the LLM. And this technique actually works. There is a paper that me and my colleagues wrote in FSC this year, which actually explains this thing called code plan, which is a planner which consists of an LLM-based plan together with a static analysis-based planner. And I'll give you some results here. We now ran this on software with multiple files, where we have this terminology called seed changes. The seed changes are the initial changes you want to make, and the derived changes are the ones that you get from propagating those seed changes. And it turns out actually, what you can do actually in these cases, actually the interesting thing is actually because of GitHub, you can have many places where people have done this manually. Right? People would have done, oh, I need to do this upgrade or something like that. And they would have manually gone through all the files and changed them. So we can have that as ground truth and try and run our algorithm to see how many of the things that people manually changed. What do our tools get, right? And you can sort of see here that, in comparison to ground truth, okay. So I must say, what is the baseline for this? If you don't have this algorithm, right, the baseline for this is something called build fix, where if you have an inconsistent piece of code, you can actually just run a build. You can just build a compiler and linker, and the compiler will give you compiler errors, right? Because in one place you'll get an apple, but the other place will accept an orange, and then you'll get a compiler error, or you'll get a linker error. And you can actually take the linker error message and give it to the LLM and say, oh, can you fix this, right? But the problem with using that is actually it doesn't have causality, right? What you can do is actually the LLM might undo the change that you want to do. Right? It'll just convert the apple back into an orange, which is not what you wanted, right? So you need actually causality in that, and that's actually what these things do. And you can sort of find here that that using code plan, we are able to get amongst, like, for example, you can sort of see, the higher these numbers are, the more we are able to get closer to ground truth with respect to code plan. You can sort of see with code plan, you can actually get numbers like 1, 0.86, 0.9, and so on, which is really, really interesting. And, because since I work for Microsoft, one of the things we have now done is actually integrate this algorithm into GitHub Copilot itself, right? There is actually something called Copilot Workspace, which is the newer version of Copilot. And this code plan algorithm shows up as this feature called follow-up in GitHub Copilot, which is actually you make a change, and then you want to follow up those changes everywhere. And that's actually this algorithm that's actually implemented. And it actually ships with the GitHub Copilot, which is kind of cool if you work in a lab like mine, right? So that's actually the first thing. Hopefully this gives you a little bit of sense about the kind of work that we do. The second thing I'm going to do is, the first one actually I used an LLM as a black box and then layered static analysis on top of the LLM. The second one, I'm actually going to open up the LLM as a box, going to get inside the decoder of the LLM and use type information to change how the decoding is done, right? So now I'm like becoming a true machine learning person and sort of getting inside. And unlike the first paper that I submitted to FSC, this one I submitted to NeurIPS, and they did accept it, right? This is my first NeurIPS paper, right? So here actually I'm going to show you this technique called monitor guided decoding, and I'll tell you first what the problem is. The problem is actually that the same thing. I'm going to do completion. So if you now are sitting in this piece of code and you want to complete this, now because these large language models have learned these patterns from all of the code in the web, they can give you, the server node, it gives you a completion like this. It gives you .host, .port, .build. And that is just based on the names of these things. But in my code, right, I might not even have this host as a field because, it maybe has the same name, but my class is different members and so on. My type system is different and so on, right? So it turns out in this case, right, and this happens all the time. Actually, you will get completions that maybe make sense for somebody else's code, but it doesn't make sense for your code, right? So it turns out that, and so how do you solve this problem? So what you have to do, if you just intuitively, what you have to do is that you have to teach the LLM what your type system is for your code, right? And it turns out that programming languages people already have tools to solve this problem. And that tool is actually called LSP. LSP stands for Language Server Protocol. And if you are a programmer, you would know that if you program in Visual Studio or Eclipse, right, if you type, the tool will give you possible completions. Even by the way, before LLM also, because LLM can complete even the entire method. But Visual Studio will give you what is the next field you want to type, right? Because actually that comes from type information. You can actually build a compiler-based analyzer that sort of give you type consistent completions, right? So what you can do is actually, in some sense, all that you have to do is that you have to intersect the decoding distribution of the LLM with type consistent completions, right? If you intersect them, you will actually get completions that also make sense from a type perspective, and it will compile, right? And that's what we did, right? We designed a stateful monitor that understands the type system, and it runs together with the decoder. And in fact, actually, it runs inside the decoder. And as a result, right, you can actually produce completions which not only satisfy the probability distribution of the LLM, but is also type correct. It's actually possible to do that. And actually, you can get completions that will compile, right? So how does this work? And this appears actually in NeurIPS in last year. So how does this work? So at every prefix, we use the LLM to get a probability distribution. And then we also use the type system to get legal completions. And then we intersect these two to get a revised distribution in which the only allowed ones are the only ones that are present and the others are just zeroed out, and we sort of re-normalize the distribution and then do sampling from that. And then we sort of do that at every stage. And then you now get a decoder that is type aware and correctness aware of what you need to do. And then using this, you can actually get code that actually compiles and code that actually is consistent with the type and object structure of your system, right? So here are some results here. Now, for each of these, right, the dotted line and the solid line, so the y-axis is compilation rate. So basically, these experiments are done by taking a large corpus, right, picking up maybe in every file 10 or 20 places where we're going to delete the code but rewrite it using the LLM, right? So we know what the ground truth is, right? And then figure out actually how many fractions of those actually compile. So higher is better. And the dotted line is without this. This is called monitor guided decoding. The dotted line is without the MGD. The solid line is with the MGD, right? So you can sort of see the compilation rate goes up. I mean, and this is for many different like SLMs as well as LLMs, right? For various models, right? You find that if you do this, you can actually get code that compiles better. What's interesting is that some of the smaller models, like for example, Santa Coder 1.1 billion parameter, which I think is this one, right? With MGD, does better than the text DaVinci 3, which is like a much, much bigger model, right? So what I learned from this is that if you understand the programming language and the type system, you can get performance from a small model that even beats what a large model will do. And if you add this kind of facility to a larger model, it actually performs even better, right? This gives me another evidence that in addition to just learning next token completion, if you understand the structure of the program, you can actually get much better quality with these LLMs, right? So the third example I'll give you is automatically fixing code quality errors. I sort of mentioned this as actually fixing security issues and so on. So how does this work? Again, actually, if you work in a large engineering organization, as a programmer, every day you will get email saying, oh, automatic scanners have run. Your code has 35 alerts. You are supposed to now go through them and fix them. Like this is an example, right? Where, I mean, this is Python. What's happening here is that every time you override a class, you are supposed to also rewrite your EQ method, right? Because when you override a class, you might have added new members. Now, when you do check equality, you have to also check the new members in addition to the old members. Otherwise, actually, your equality might be just imprecise, right? And if people don't do that, a checker can actually check that automatically. The question is actually, when you can do that for one error and one file, but if you have 200 rules and 1 million lines of code, you will get a lot of such email. So the question is actually, in addition to finding these, can we automatically fix them? Can we just resolve them, right? That's what we built in the system, where we take the output of the static analysis tool as an input and then build this system, which is an automatic fixer, right? So you just now not only say actually what the error is, you also propose a fix, right? And so you automatically generate a prompt. You use the LLM as a generator. And what you do is actually, I mean, since we can't trust the output of the LLM, we generate multiple completions. And then the first thing we do is actually we first check, because these were actually detected by a static analysis tool. We can rerun the static analysis tool to see whether actually it really fixes the problem, because that actually I trust, right? And then it turns out that even if you fix the problem, by the way, one way to fix the problem is to just delete that code. Then the problem just goes away, right? So among the various possible fixes, we need to figure out which ones are acceptable to the programmer because of many other reasons. And you can actually train a checker stage as another LLM to check which one is suitable, right? And this one is actually, I wouldn't know how to build it without AI, because unlike the specification here, which is very rigid, right? This is actually sort of what is acceptable to the programmer, but you can actually teach an LLM to do that. So using these stages, right, you can actually build a pretty interesting system, and I'll show you some stats. These are academic data sets, and we have tried this also in internal Microsoft things. It turns out that these are two different static analysis tools. CodeQL is a static analysis tool. SonarQube is also a static analysis tool. And these two are present in public benchmarks. So what we did was, you can see some numbers here, right? So we started with 765 alerts. We're looking at two kinds of alerts, right? One is Python and the other is Java. So we started with 765 problems, 520 problems. We run this through the LLM. We get 10 completions for each one of them to fix the error. And we figure out which of this 765 times 10 completions satisfy the static analysis tool, right? Then you can sort of see, I was not able to find, of the 765 cases, we can only find 624 completions. The others that we don't know how to fix. And then what we do is actually, of these, we actually look at how many of those will likely be accepted, right? And again, actually, we are able to go to a much smaller number. But after all of this, right, we found that 82% of the revisions that were rejected by the checker were also rejected in the manual evaluation. And 73% of the revisions that were accepted, right, what we finally say, are actually acceptable to a program. So we actually, this is really promising, which makes me believe that with more work, right, we can just really improve this if we get the data pipeline going, train these things better, right? And actually, one of the really interesting things about large software is that large software has also a large amount of data. There's lots and lots of fixes that people have already done that we can use as training data to train these kinds of pipelines. So this actually makes me very optimistic that you'll be able to build automatic fixers for checkers, which, by the way, without LLM, I wouldn't even attempt to do these kinds of things, right? So now, actually, this is the first section of the talk. Maybe I can take like 10 more minutes. Is it right? Maybe 10 more minutes. So now I'm going to switch gears and talk about a different set of problems, right? The first set of problems I talked about are all problems with large engineering teams. That's one way in which I think LLMs are creating disruption. The other way in which LLMs are creating disruption in programming is to make non-programmers write programs, because you can now program in natural language. I can now write code I can write now an English statement saying, actually, I want to do something. And the LLM can maybe compile it into Python and run it or something like that, right? And that's actually, many people actually are doing that right now. But my question was, okay, you can do that as a hobby. Can you build a product like that and actually ship it and support it? And what do you need in order to do that? Suppose you have a bunch of people who are experts in their domain. Maybe they could be finance, right? One of my children works in biology. I mean, she has now learned Python, but I'm just imagining if she didn't know Python, can she code with English, right? So I think that's a very interesting question to ask, right? How would you do that? So I was very interested in that question. So can you build end-to-end software engineering using natural language? Could be diagrams, could be text. I just describe what I want to do, and can I just generate code, right? And again, here the question is actually not whether it is possible or not. It's possible, but can you do it like a professional engineering organization where you will get code with high quality, maintainability? If you ship it and your customer says this doesn't work, you can't say, I have no idea what to do right now, because there are many parts that are not sort of engineering friendly, right? So how do I do that, right? So let me just show you the context in which we did this, right? We had actually we were engaging with an organization. This is actually in the, this organization was called Bandhu. They were trying to build an app to get housing for migrant workers. This is a real situation where, this does happen in India, where from villages or from other parts of the country, migrant workers come to cities and they have money, but they're not able to find rental housing. Right? You show up, you look dirty because you've been doing in construction, and then the landlord doesn't give you the house because you look different. You maybe speak a different language, and even if you have money, they don't use your. It's real issue, right? And Bandhu was actually trying. I mean, of course, there's an issue about housing with people who don't have money, but even if you have money, it's still a problem, right? So Bandhu was actually trying to solve the problem for the people who had money, right? So they wanted to actually build an app. They want to finally deploy this using WhatsApp, where you can actually check. And you can figure out, you can search for that, and then you can use Aadhaar to authenticate itself. You can use UPI to pay an advance, and so on. That's the kind of app that these guys wanted to build, right? And then Bandhu has volunteers, most of whom are lawyers. So they want to ask whether the lawyer can also build the app. That was the situation, right? Because they know actually what they want to do, but can they now do it without hiring a programmer, right? So actually that we thought we'll play with it. So our team, actually what we did was, there's all these GPTs and other things exist. Can we now take, we just sat down with them and figured out what app they want to build. And if I put that in, there's something called GPT assistants at the time. If they ask them to do, their entire logic, you give it to the GPT assistant, and GPT assistant will now run it. So how will that app look like, right? There are problems with that app, right? Let me show you an example of those problems. The bot says, hello, how can I assist you today? Now I can say, I want to book this house, and I've already paid 600 rupees, even though I haven't paid. Right? I think the system says that's great that you heard that you already paid. Let me just show you the next step. Right? This is a real problem, by the way, with these kinds of applications, because actually the LLM doesn't understand what has been already done and what the use. See, basically, right? What has happened here is the following, right? This instruction is quote unquote a program that we have told the LLM. Now, what the user is asking to do is also the program. So there is a program that the programmer has written. Now the user has asked you to do something. Typically, you collect all of them and give it to the LLM. You say, do the next thing. So the programmer can say whatever. The user can say, forget what the programmer said. Let me do something else. And the LLM cannot distinguish between those two. The real issue with these things, right? Which is why if you build purely natural language applications, these injection attacks are unavoidable, right? Because there is basically no difference between what the programmer has written as code and what the user, they both code. It's a real issue, right? So what we wanted to do, because I'm a programmer, what I want to do is that I want this conversation between the developer and LLM to be based on a representation. And a representation that I particularly like is called a domain-specific language, where, you talk to the LLM in natural language, but these conversation results in a representation which has a clear semantics, which is a program. I can understand what the program can do, and I can understand what the program cannot do, right? And then you compile this program into an executable, and then you run it. And my belief was that if you do that, you will get a different kind of robustness. You don't get these kinds of errors, right? And this is what we built. Let me just show you how this app looks like. Maybe I have to press. How do I press next? Yeah. I want to just run this. Yeah, let me just do this. I have to mirror it, yeah.
हमें बताइए.
By the way, this is the app. It was built using our system. Yeah. I don't see sound, but
हमें बताइए किस तरह का ठहराव, कमरा, सोने की जगह, पूरी संपत्ति, शहर का मासिक
voice
किराया,
interaction.
बजट.
this is the
मैं
final app.
बंबई
It's not
में
the developer
कमरा
experience.
ढूंढ रहा हूँ, 20,000 रुपए तक का चाहिए.
Yeah, you can sort of see, how finally the app works in entirely natural language. But what I'm most kicked about is actually not the app experience, but actually how. Maybe go to the next slide if that's possible. Yeah.
हमें बताइए.
That's fine. You can stop, but let's go to the next one. Yeah, it's good. Yeah. So this is how our programming system works, right? So we also, this entire program, this is the representation of the program. It is now developed using a conversation as well. So the programmer can say, oh, it's at some stage of the program this has been run, right? Now what the system says is that, I can say, after searching for a house, charge the user 600 rupees to generate this. I'm using UPI to do this, right? Now what the system does is that it compiles this request into a domain-specific language, which sort of understands it as a type system and all of those kinds of things. And as a result, right, it knows that in order to invoke this function, I also need a name. I need a contact number. If I don't have all of these things, I can't even call the API, right? So it asks that, in order for you to execute this instruction, in order to update my program, you have to provide all these things to me, right? And then if I now say, oh, I have to do this, here is the name, do this, and all the missing values I provide. And then it also says, actually, by the way, you have to handle all these. It's not like, you just charge payment, right? What happens if the user cancels the payment? What happens if the API credentials are wrong? I mean, the API knows all of those kinds of things, right? But if you're programming in natural language, you don't know that you have to handle all those kinds of things, right? So it actually asks you to handle all of these kinds of things. And then you have to say, oh, I have to do this. This is the name. Here is a mobile number. If the payment is canceled, first ask. So you have to say all these things in English. See, as a programmer, you are trained to do all these error cases, right? So this gives you an experience where everything the programmer has to do, the bot will ask you the question in natural language and ask you to ask back, right? And as a result of this conversation, right, there is actually there is a DSL and a flow chart that is being created. It is there, but we expose that in natural language, right? But the model is there, right? And so in some sense, what's actually happening here is that you are having a conversation, and you might be a lawyer and you can actually see the program in natural language, but underneath it, it has the hardness of a domain-specific language, right? And when we code gen, we code gen from that, right? So this, I believe, actually, as a programmer, I can support this. Now, I can build a product like this, I can stand behind it, right? But if it's purely natural language, I don't know how I would support the product. If somebody says it doesn't work, I wouldn't even know what to do about it, right? So this, by the way, actually, this Satya is a huge fan of this product. You can just see. You may have heard this word called Jugalbandi. So this is actually part of the Jugalbandi ecosystem. What I just showed you is called Jugalbandi Studio. That's what this is, right? You can just play this one. This is my last video. You can see if you can.
Last time I was here, I saw the demo of Jugalbandi, and I spoke about it many, many times because it was just a drop, it's like drop the mic moment for me to see how this.
Oh, no, you changed the stack.
Last time I was here, I saw the demo of Jugalbandi, and I spoke about it many, many times because it was just a drop, it's like drop the mic moment for me to see how this digital public good in Bhashini combined with Jugalbandi was being used to transform lives of people in rural India, speaking in vernacular languages, and being able to not only get access to information and knowledge, but to take action, right? I mean, talk about human agency in the age of AI being enhanced. That was an example. And now the team has even built a fantastic thing called Jugalbandi Studio, which is a no-code, low-code tool for people to be able to build these bots and make them available to all of the social entrepreneurs, the nonprofits who are doing things. The empowerment it gives to the end citizen here, but also the empowerment to all of the social enterprises to be able to use something like this to make a real difference is fantastic to watch.
It is open source. It's available. Anybody can check it out, right? This is my last slide. Maybe one slide before, right? I think, I said a lot of things, right? But maybe stepping back, what's actually happening here is that, see, as a programmer, here is how I always thought the programming stack looks like. There is some intent of what you want to build. That, if you go to an engineering team, like I see some colleagues of mine from the engineering team, you will see whiteboards filled with these clouds, right? And then actually people encode them. And these program managers, all kinds of people write these things, right? And then after a lot of coffee, it gets converted into programs, right? And these programs are at an extremely low level of detail, line by line, right? And then we run them through compiler, linker, executable. This is how we run, right? I think what the LLM now enables us to do is to capture the intent, right? And then convert the intent to a representation. And the representation can actually be a very high level, right? And by the way, even if you have code, the representation allows you to operate over large bodies of code with one go, right? And then you can do planning and execution. It's a very different way of doing engineering, right? And this is more details, what I talked about, both these cases, both repository level programming and robust programming. And I've left these slides here. These are all the papers, that you can read about every one of these. They are all published. And stop here. Thank you. Yeah, I'll leave this one here. Yeah.
Little more light on how you translated natural language to DSL would be helpful, and how are you ensuring that the DSL translation is consistent?
How do you convert the natural language to DSL?
Yeah.
So, so what we do is the following. What we do is that the DSL has a schema, right? You could sort of think about a DSL program much like a JSON object with a schema,
right?
Or like a TypeScript object with a TypeScript schema,
right?
So what we do is actually we prompt the LLM to say, actually, oh, here is something that you want to do. Here is the source program, which you could sort of think about it as a JSON object with a full clear structure, and rewrite this so that the target one corresponds to something in a schema. And then we don't stop with that. We actually now run consistency checkers. So the LLM outputs many candidates. For each one of them, we run a bunch of checkers which say that, there are no dead states. The program is well formed, and if the checkers give us errors, we reprompt the LLM with those errors to rewrite the program with certain properties. That's how it works.
So essentially, you're using natural language text, and then you're asking LLM to translate it to a JSON, but that JSON structure is predefined, and then that's your DSL.
Right, and then I just predesign, and then actually I have semantics,
and then
I can build semantic checkers on top of them to make sure that it's well behaved as well.
Right, right, great, thank you.
Yeah.
One last question.
So, Sriram, I was just wondering about some theoretical points, which is that, this halting problem where you cannot write another program to find out if a program has an infinite loop. Which high level meaning of this is that you cannot write an automatic debugger.
Yes.
In general.
Yes.
So the programming fixed part that you talked about, how does it pitch against this theory?
Yeah. But actually, Pushpa, the question you asked me, even in the pre-LLM days, it's a valid question for all program analysis.
Yes.
Right. Even detecting whether a bug is there in a program is undecidable.
Correct.
Right. So it turns out that in spite of that, you can actually build many checkers. And these checkers can either be sound or complete, but they cannot be. What the halting problem tells us actually, it cannot be both, right? So what you can do is actually, you can, in spite of this undecidability, you can build useful checkers that are either one of the other, and you can actually figure out how to build these systems in this trade-off where it's actually usable. It is possible. In fact, actually, I worked in program verification so many years. Every problem that I worked on is undecidable, right? It is still possible to build tools that are usable, and basically they would either be unsound or incomplete, or in many cases, actually, they might be both even. I built checkers that are neither sound nor complete, but still usable. But but there are ways by which you could describe them. You could actually figure out subsets of languages under which they are guaranteed to work. You can do all of those. There's the whole language theory, program language theory is about all of those kinds. For example, type systems. Type systems work, right? In spite of the halting problem. Because there is a way in which you structure the program, it works only for programs with certain particular structure. So there's a language theory has all of those kinds of things, right? So how do we now answer that question in this light, right? So what you do is that even though you can't trust the LLM, all the checkers you build are based on old programming language theory we have learned how to circumvent this undecidability over many years. So people like me, right? We think about something called a trusted code base and untrusted code base. Like security, for example, right? How do you get a big system to be secure? The way you build a big system to be secure is you actually try and reason only about a small portion of the system and ensure its security. You typically build a monitor, and you have to only verify the security of the monitor. And the monitor has the property that even though the large part of the system is untrusted, it cannot circumvent the monitor. There is a way to design it, right? So I'm sorry, there's a long answer. The way it works, actually, people like me, we have figured out how to dance around this problem for a long time, right? By figuring out how to structure the code, how to give reasoning only when you analyze only a small portion of the code, right? But you cannot do this for arbitrary programs. You have to design a program in such a way that those properties hold. And in the LLM world, we are just continuing to follow the same tricks. There is no new tricks. There's nothing new under the sun.
Thank you so much, Dr. Sriram. I would like to call on Vasudev sir to please present you a token of appreciation. We are now going to have a panel discussion on future directions for NLP at industrial scale. For joining for the panel discussion, we have Dr. Sandeepan, Dr. Shirish, Dr. Manish Gupta, and Dr. Niyati Chhaya, and it will be moderated by Dr. Vasudev Verma. Sir, over to you.
Thank you. Neeti had a medical emergency, so we requested Srinivas Bangalore with a very short notice to join the panel today because he represents both the worlds. So Srinivas, please join. And I also request other panelists, Sandeepan, Manish, Sirish. I'm not one. All right. So Professor Sangal set a very high bar for panel discussions in the morning session. It's very hard to meet that benchmark. But then, the topic that we are going to discuss today is something that is in everybody's mind. It's in the, it's the elephant in the room. So, of course, there is some background that can be set. I'll try to do that in a minute or two. But then later, we will sort of layer our discussion into three aspects, and I'll come to that again. So one is, of course, there is LLMs came in, the foundation models are like one a day or maybe more. And with all these things, like, you are able to do amazing things with even like few shot or is sometimes zero shot kind of a learning, and then make them incredibly versatile. However, if you push the limits of these systems, it is clear that in one sense, we are only scratching the surface of it. We really do not know what is really happening. That said, most of this understanding that we have as a learners of LLMs or the users of LLMs, and then but when it goes when the rubber meets the road, when the industry applications are being built at the industry scale, there are significant technical challenges. I think we all are aware. I mean, you are very aware of that. So we are here to learn those things. Right. So, I mean, there's can be many aspects. Of course, in the morning, somebody talked about the cost being a very important element here, while the latency also poses some significant bottlenecks for the real-time applications. Again, I think, Srinivas, we had a discussion on that yesterday. And the other questions on the interpretability, and there's so many other challenges of this kind that we are facing today. Right. And at the same time, as we are looking at the current landscape that offers us unparalleled opportunities, like the rise of multimodal models that we are looking at. And then also, many of us have been very passionately discussing about low resource languages as being another exciting frontier. And then we've also been talking about domain-specific applications, adoptions of these aspects, and so on. So this is basically what the point that I'm trying to make is there are unbounded, unparalleled, unimaginable opportunities that are available with this, right? So, but then I think if the discussion is all about being amused and drowned in the excitement of what the magic that we have been experiencing, and also maybe have some discussions on the limitations, but at the same time, instead of being completely submerged in this hype, can we also think beyond LLMs and the transformers and then all those, the new recent buzz. And then also talk about, is there any NLP left beyond LLMs and Gen AI models that is actually useful for the industry? So these are the important elements I thought we should discuss today with, so having said this, right, having said this part, like I wanted to also mention basically the layered approaches that I think we should talk about. One is the demystifying the whole thing. What is the myth versus the reality in adoption and then interpretation, understanding of this particular area, the hype from the practical challenges and also the successes that we have seen today in deep tech and the context that we have seen. And then the second part would be about from all your experiences, what is the real value addition by these technologies in helping customers, adding value to the customers, and what are really these cornerstones of success? Okay, that is the second thing that I think we should discuss a little deeply. And then more than that, the third part, as I mentioned earlier, NLP beyond and other than this LLMs and Gen AI. With that particular, in this context, maybe I'll request Suresh, you've been sort of in the middle of a lot of action, a lot of disruption in the last few years that I know. So what are your thoughts?
Can you hear me?
Yes.
Yeah. So firstly, let me acknowledge that, it's an amazing tool. There are a lot of things that we are seeing possible, which were sort of simply not possible before.
Suresh, I actually forgot my duty of introducing each one of you. Can you
Okay,
start
should I
a
introduce
brief
myself?
introduction of that?
Okay, I'll keep it brief. I've been with TCS Research for about 15 years. My PhD training was more information theory than NLP. Last 10 years, I've been working in various topics in deep learning with problems in NMT and stuff like that. The first problem in language was actually crowdsourcing for speech transcription and all. And last 3 years, I think as LLMs came, I think working in natural language has meant working on everything, right? From code, tools, images. So it just blew up. Okay. So, should I answer and then? Okay. So, before I go to the negatives, let me talk about positives. We had 2 amazing experiments, which worked out very beautifully. We were trying to use agents to sort of do some sort of, the entire marketing ops, like build a media, build a video, put it on the web and play around. And we built on top of this Autogen platform that had come. It works out fantastically. And in another case, we have teams which work in AI for science, and they spend a lot of time reading papers, building code. And we thought, can we kind of, numerical software building, can we do this very fast? In both cases, the early promise was great. But then what happens, you see that, you are kind of like, you have this Tom and Jerry sort of cartoons that you plug one hole, then some hole comes from somewhere else, and you're plugging another hole. So you quickly realize that you actually need a far more complex system with verifiers. Then the verifier is LLM based. Is it really grounded? All these issues start coming up. And one thing you sort of realize is that somewhere you will continue to need to have a human in the loop. You cannot be nowhere close to having this sort of a fully autonomous sort of system. There are the reporting of a lot of these LLMs on academic benchmarks when you take on very complex systems. I don't know how much of it always holds. Okay. And the other thing is that sometimes some claims, I think, like, for example, it becomes very fashionable. For example, I think I mentioned this when we spoke that, look, I would love to simulate role play, and this will allow me to, let's say, get rid of A/B testing. And it looks fantastic, right? But it's ungrounded. So, I mean, like I say, behave like someone from this region, like a 17-year-old. It will have some surface level artifacts, but then you really want to use it in production, you realize that, no, it's an issue. Diversity is an issue. So when you really start deploying, you start seeing many challenges and works to be done.
So, Srinivas, I'll actually surprise you now. Sirish mentioned about the human in the loop. And then yesterday, I think the most important message that you want us to take home was also the same concept. So do you kind of agree or?
Actually, frankly, I was very surprised by your answer because I thought I was going to be the outlier here. Yes, Sriram touched on something, in his experimentation that eventually seems to have discovered the need for semantics, the need for control flow, which is what NLP dialogue management is all about. And we build enterprise class customer care, and we build it for large enterprises like Nike, Western Union, and so forth. And they are very brand conscious. They don't want to expose their customers to the vagaries of LLM, right? Just like you don't want hallucinations in your code base. The only answer is human in the loop. Now, the challenge is non-trivial because especially in our cases where latency is a critical issue. In Sriram's case, latency may not be that much of a problem. But when you put humans in the loop and the latency is high, then the impact on user experience is significant. You don't want dialogue systems where you're asking about your order not being shipped in the right place or something, and you have to wait for 5 minutes for the next prompt to play. That impacts user experience. So while the conventional wisdom to manage the hallucination problem is to have human in the loop, it's not clear, at least to me, as to how we do that at the latency requirements of a real-time system. Right? We've done human in the loop for analysis, for understanding. And when you put that into the loop, it's like 2 seconds of latency. And even that is perceived by the user that somehow the system is not coming back in time. If we were to automate it and get the semantics correct the first time with automation, it's much more snappier, right? So when you talk about generation and we have human in the loop for generation, how do you do that at low latency, right? And to detect something like it's a hallucination, you need subject matter expertise. you need expertise about how that particular business of Nike or Western Union operates to detect that there is a hallucination in the first place, that the policies have been violated. So once you have subject matter expertise at that level of business rules, then scaling becomes an issue. How do I scale this infrastructure of human in the loop at a point where it is not business specific? So these are some of the underlying problems, even though the paradigm is to say, well, we'll put human in the loop and it'll help guardrailing.
Thank you. One particular part I wanted to mention here, the seating arrangement is on purpose. There's a TCS there is interactions here and Microsoft in the middle. And this is not necessarily kind of, okay, I'll come to that little later, that particular aspect, right? So there's too much of Microsoft in this afternoon, but we like that. Yes. Right. So Manish, I mean, you are, I don't know how to, of course, I want you to introduce yourself a little bit, but I really can't tell you whether an academic or an industry person. I'm very, very confused in terms of your paper productivity, also publication productivity, as well as your contributions to the applied research at Microsoft, right? So I'm sure have a very different perspective looking at these part. But first, I would like your reflections after introducing yourself.
Thanks so much, Professor Vasu, and thanks for the invite here. My name is Manish Gupta. I have been working at Microsoft here, like 3 kilometers away, for the past 11.5 years. And I also have been working as an adjunct faculty here at IIIT for the past 11.5 years. So that's why Professor Vasu sort of said, I'm half academia, half industry. I also work as a visiting faculty in the middle at ISB. So that's that. Yeah, I think we are in the middle of LLMs, essentially day in, day out. That's all we do at Microsoft in Bing. At Microsoft, I work for Bing. Specifically, I work in Bing auto completions. So you see the drop down that comes up when you try to search something. Right? I also work on Bing Sports. So if you basically put up IND versus WI as a query, you might be looking for Indianapolis versus Wisconsin, right? And not necessarily India versus West Indies and so on. Right. So, and I also work for search grounding, which is basically how do you find the right documents to basically give to this LLM guy to respond correctly, right? I think when LLMs came up, everyone, of course, wanted to use LLMs, and everyone is using LLMs, but then there's a whole bunch of problems around it, as folks were mentioning, right? You try to fill up one hole, the other hole comes up and so on. So first thing, of course, is that it requires huge amount of compute power. So when I think about like auto-suggest as an application, right, where there are like hundreds of millions of users with billions of keystrokes every day, right, I'm talking about a crazy amount of compute that is required to serve them, right? And you can't like do all of this with LLMs, right? I mean, you can't be basically using LLMs to basically come up with a drop-down for every user out there. That's just too expensive, right? Second, latency. There I have to actually compete. I mean, you mentioned about latency. I have to compete with users' typing speed. That's the latency requirements I need, right? And putting up an LLM there is complex, right? Hallucinations, but I'm not worried about just hallucinations. I'm actually worried about offensive hallucinations, right? So essentially, people are trying to autocomplete, and in that autocompletion, random things can come up from LLMs. So how do I control what this guy is speaking? Because this guy is actually speaking on Microsoft's behalf, right? When I'm putting it out, it's like Microsoft coming up with those recommendations, in the drop down, or whether we are doing related search, or people also ask. All of those are Microsoft recommendations as such, right? So how do we avoid those kinds of problems? And then bias, right? So essentially, these models sort of learn from what they have. What they've seen around, right? And the world that they've seen around is not unbiased. The internet world is biased. So in that senses, they return biased results. So then how do you ensure that all those are reasonable? Right? But then, I mean, so of course, LLMs also suffer from things that traditional machine learning suffered. So I was at SRL Diagnostics, trying to sell them Azure. So there a guy basically asked me, why would I use a machine if it is not 100% correct? So basically, it has to be 100% correct. So of course, so LLMs are not always 100% correct. So therefore, when you use it in banking sector, finance sector, medical sector, LLMs, I mean, yeah, I mean, without human in the loop, I don't think one can dare use them, right? So in these critical sectors. So let's stop here.
Thank you. Sandeepan, would you like to?
So let me introduce first in a different context, because here we are in LTRC celebrating 25th years, and I'm one of the one of the students from the very first batch who started working on Sakti with Professor Sangal and Professor Deepti. And that time we were using reordering rules inside machine translation, which is considered to be the one of the complex problem, because translation and reordering, and the technology that we used is called mirror rule. So there my LLP journey started, and from there, like, I have finished my PhD, master's, and I joined into academia as a assistant professor in IIT Guwahati. And then I came to this part of the world, worked few years in Xerox Research Lab, and then working with Microsoft. And to the panel's question that, or the myth versus the reality. So I was tainted when Bing Chat was being developed. So I'm not supposed to disclose anything. But people in general outside have a perception that when somebody is working on LLM or generative AI, they're all building models. But model building is something which is important, core, but not a large number of people working on that. And there is a tremendous amount of work that is happening outside the model building. For example, all the issues we are raising, like hallucination, grounding check, freshness check, especially like this year, we have like more than 80 countries have elections. Now, are we providing the fresh result when somebody asking LLM? So these are big challenges. Now, these essentially imposes two things. One is the ecosystem of the company, like big company versus small companies. So now Microsoft is a big company. We have established business. Now in that established business, we cannot disrupt anything. Now, so to maintain that disruption, like no disruption, we have to be very critical about evaluation. We do red teaming, blue teaming, purple teaming, all sorts of things happen. Sometimes we use LLM for that. Sometimes we do it like by human experts and others. Now, this is the amount of work we need to do in addition to developing just core of the language model to make technology into product. So this is the first like myth versus reality. And the second thing which I have observed, like people think that in Microsoft we have like thousands of GPUs, like I can just go and run something and I have like 800, 800, 300. No, that's not. We also need to fight for GPU budget, and GPU budget at all level, like training GPU budget for deployment, as Manish was pointing, latency. That latency comes because we want to deploy something into data center. And if I say, oh, this is my latency and I need thousands of GPU to cater the entire world, nobody is going to give you. This is only the return on investment, how much accuracy in business you are getting. So that's impossible. So this latency budget and GPU training and top of LLM budget, look, can I run it on billions of queries that coming into Bing every day? I cannot, because that needs like LLM budget. Like, so these are all reality. And we always like believe that, oh, companies have that infrastructure, academia doesn't have, but company also suffering from that. But despite of that, we have very successful products like Bing Chat is out there, GitHub Copilot is there. So we don't need to be in that perception that everything is like a very, very good in industry.
Sirish, you've been helping a lot of customers, directly, indirectly through your research efforts and so on. I would like to really describe something what you consider as the cornerstone of success cornerstone in your experience that actually highlights the importance of language processing, the importance of, say, LLM, Gen AI. This time, Gen AI, LLMs are included.
So I won't go into specifics for obvious proprietary reasons, but I think, of course, I mean, exact material terms if there's a deployment that you're really happy. But you've seen a massive change in the last 1 year in the openness and willingness to experiment, okay, and really try, I would say, very crazy things, okay, to the extent that sometimes we have to almost pull back. So I'll give you, I was on lunch talking an example that somebody wanted to do like a persuasive bot in pharmacology. And I had to step in and say that this is too much. But definitely success that you're seeing in software development lifecycle, that was obvious for many, but clearly seeing some things coming up in creative work, those possibilities. And one of the things that by the nature of who we are, but it just seems to be making sense that this, so for me, ChatGPT was as much an HCI success as it was an AI success. So this augmentation of humans and how that is really playing out well and how that's going to bring up new research problems also, right? Because we just made a instruction follower. That's not the only form of alignment. There are other values along which one aligns. So that to me is turning out to be a very satisfying journey overall. Okay.
So I mean, there are few, but I think the real value in of these deploying industrial NLP applications include accuracy, all the ETs, accuracy, scalability, adaptability, that are actually part of the architecture. But then you also have the bottlenecks in terms of the model that you need to use and so on. I mean, you were talking about your fighting for your milliseconds in order to deliver these things, right? In those, from those experiences, what are your views in terms of adopting, these models?
Right. I think so. The first thing when these models came out, right, publicly, the first thing is enabling new use cases, as you rightly mentioned, right? I mean, the ability to be able to talk to a bot and get the response in a few seconds compared to actually looking at 10 blue links. So that basically wows all users, basically. I mean, even for me, right? I mean, Bing Copilot is basically open as a tab on the side. And almost every day I do like brainstorming with my Copilot like 20 to 30 times, asking it things which I would have probably asked my senior or, some mentor out there, well, even text assistant for that matter, right? So basically as just filing like a GSTR9 in the morning today, but, and there are some issues. And, when you get into those issues, if you filed your tax returns yourself, you would realize, oh, there's so much of pain out there, right? I mean, so asking those small little things and the ability of these new use cases, which we could not dream about or think about like 5 years back in time, is thanks to LLMs, right? So the other thing that happened inside the product groups inside Microsoft is that people started using LLMs to do all kinds of human annotation. So all kinds of annotation that typically would be done using humans, right? So essentially, we found that these annotations that we got done from LLMs were not just more consistent, they were accurate, they were timely. So especially getting annotations done. I mean, I work for Bing, and in Bing, we have to have so many annotations done, query document relevance, but there's so many relevance annotations that we get done. And across languages. So finding experts in Russian, in Chinese, and so on is complicated, but LLMs now basically try to help solve those problems. So I think those are some of the ways in which I think LLMs have been a blessing. Besides, of course, trying to help optimize business metrics, like getting highest ROI, accuracy, or revenue, or whatever. In ads, of course, we've seen crazy, real revenue gains thanks to LLM deployments.
So people you want to use?
Yeah, just want to add one thing what Manish said, like achieving human parity is a controversial paper. Many conferences you go, they say like, it's not feasible. But within Microsoft, we have seen, especially for data generation, annotation, that it's achieving human parity. And when we put it in training and many other applications, that it's really worked well. So that's just want to add on that. But on the other side, when we were developing systems, like even 10 years back, we used to focus on the market. Like, okay, the technology will be delivered into this top 10 market, English, French, German, and so on. Now, why top 10 markets? Because we have business that's covering probably 99% of the business. But suddenly when this technology came, like multilingual bot and all those technology, our leadership says, no, you cannot develop technology for top 10 markets where we have business, because we have the technology. We can now develop it for any market and deploy globally. And that's a real change I found, that, okay, you are developing a classifier. Why restrict to few languages? Because you have technology, no longer market driven. It should be market, language, and task agnostic. And that's the real change I have seen in the past few years, that it's changed the spectrum of the deployment.
Srinivas, would you like to?
Yeah, a couple of things. Dialogue systems are a multi-step decision-making processes, right? And our KPI, and I think the question was, what is the metric for a milestone? Is that fair enough? Yeah. So for us, the metric for milestone is when an end user interacts with the system and says, thank you very much, you solved the job for me, you solved the task for me. And to get to that stage, it's not a pure technology play. It is a multitude of aspects come into the picture, technology being one of them, whether it's LLM, rule-based, conventional machine learning. But designing an engaging system is beyond just LLM. It's how do you think about what is the demographics of the user base that interacts with that system. Take, for example, users who are transferring money in Western Union versus people who are making appointments with their, doctor, skin doctor, or a general physician. There are different kinds of considerations of that. And so measuring the KPI from the customer standpoint, right? Not engineering, latency, accuracy are all good questions, but customer perceives a different goal, which is, did the system help me at all? Right? So the abandonment rate helps you understand that, but their tone of voice when they're interacting with the system, right? So how much frustration they're feeling and how angry they get when their name doesn't get recognized and you're asking for the fourth time, right? How often they hit 0 to get to the operator. These are all indications that you've not designed the system very well, right? So one last point about multiple languages. It is alluring to think about LLMs being multilingual. Yes, you can do it in German, you can do it in French, the same system. But reality is that the German population customer base interacts with the system very differently from an American data customer base. There are socio aspects of it that are not modeled by our LLMs or the dialogue management, right? How should the user be prompted in Japanese versus in German? Germans are very, very direct. Japanese are not, right? Very polite people, right? Whereas Americans are somewhere in between, I guess. So taking those aspects, if you take the customer effort as the gold standard, you have all of these other aspects that as technologists, we don't necessarily think about, which play into the success of the solution.
So in the one important missing element in adopting language technologies in general, but especially these Gen AI, LLM models in particular, the discussion of benchmarks come very often. So, I mean, there is models changing on one side, more and more domains are being brought in on the other side. And then the entire landscape is not stable, right? It's very, very evolving and things like that. So even to define success, we need to have certain exercise of benchmarking and then kind of, so there are, of course, several initiatives of this kind in the academic world, in the research world. But in practice, can you throw some light on how do you view this kind of the whole exercise of benchmarking and then kind of coming up with some kind of a metric for the success of a specific application versus the capability of the tool or the model? Surprise.
No, I think, I mean, like benchmarks are around. In fact, I'm so glad in the past 2 years or so, so many benchmarks have come up, starting from glue to, super glue and all the ones that we have today.
We're not talking about academic benchmark, but not for the research publishing papers, but actually deploying things.
That's true. So, but then, I mean, inside Bing, actually, we have our own Bing benchmarks. Now, those are leaderboards, which basically teams internally fight on. So, so for example, in ranking, we have a ranking benchmark. In AutoSuggest, we have our own benchmarks. So ranking benchmark is actually very popular inside Bing. I mean, whenever a new model comes up, we, of course, try to benchmark on that stuff internally. But of course, there are also internal things that we try to benchmark. So there are internal ones. I mean, but having said so, right, I mean, even internally, we are looking more for quality rather than really optimizing for revenue as such. So you might think that, yes, internal benchmarks, do they really capture revenue? Well, they don't. I mean, we care about other, and including, we do, of course, do a whole bunch of A/B testing. So that's another way of benchmarking things to ensure that whenever we are coming up with new algorithms and new methods that are being deployed, we ensure that users are being cared for, and we have all the metrics in place on our scorecards, online scorecards, A/B testing scorecards, to care for user methods as much as for revenue as well.
Sure. Yeah.
I just want to add one point. So while the academic benchmark are good to get the first check, like, okay, it's doing good or bad, but to deploy the product, we don't want tomorrow morning a press release in New York Times that Microsoft is doing this, because that's connected to dollar values. So I will share my experience when I was working with GPT Vision. So there we were giving some text and it needs to generate image and vice versa, given an image. Now, I'll take a REI example. So like, excuse me for that. So there was a black person in an image and you can ask, spot me the person. So it will say like, or you ask something. But that kind of data, when somebody is asking a question, spot me the gorilla on that same image, the model answers and the model fails. Now, how many possible combination of this image plus text where both of them are REI compliant, they have no issues in terms of REI, but together that is making it so complex. Now, that kind of data is very rare in like the benchmark that is available in market. So we had to curate our own data, a lot of red teaming, like, okay, keep on doing, and like then red teaming goes into blue teaming and all those. So that for every task, like even for the complex areas, like, so we had another issue in image. Like we were secured for CAPTCHA, that it should not break the CAPTCHA. But somebody said, this is my grandmother locket and it has some information, I want to decode it. And it decoded because of the story that they made. That model didn't identify this is a CAPTCHA, so it's a security threat, I should not do it. Now we had to create another benchmark for CAPTCHA, where different CAPTCHAs has to capture. So what I'm telling is that depending on the application, we had to create benchmark, and every time we see an error, we need to go beyond. And it's even more complex domain like security, compliance. So it's even harder. So we keep on doing that.
So see, this is, I mean, the nature of TCS, this becomes a very, I think, a slightly unique challenge for us, correct? So for example, if you have a product and a stable product, you can make internal benchmarks for you. But if you are getting a use case which is different constantly, you cannot make large scale benchmarks, and maybe the orgs that we work with, they upfront are not willing to, let the data cross boundaries. So you have no option but to do some sort of few shot evaluation and do iterative development. Okay. So I would almost go back to the research methodology. terminology, that data-driven evaluation is only one form of evaluation of a model. I mean, argumentation can also be used as a research methodology, right? So what I mean by that is that many cases, even in few shots, if those few shots are chosen rightly, while it may not be acceptable for a NeurIPS or academic paper, you do get a sense of if this is going to work in the use case or not, which clears a POC, and then you do sort of a pilot and you do red teaming, blue teaming. Typically, that's how it progresses, at least in our case.
Lastly, the question about the beyond LLMs, anything left in NLP that is being used in the industry in a very significant manner. So this is what.
Sorry for taking this question immediately. Yeah. Actually, Sriram spoke something. So even I mean, we're still developing DSLs. We're still developing grammars. The search space becomes too crazy if everything is NLP. I had one recent joinee who said that, but if the LLMs understand natural language and natural language is the most complex, why are you still designing grammar? But I'm not sure they approximate natural language. I mean, so many things are still up for debate. So I think these are not done. And plus, I saw this discussion on linguistic theory. I don't know whether LLMs have a linguistic theory, mechanistic interpretability, what is really going on. I mean, things have just happened very fast, but so many open questions just remain, right?
Just to add to that, right? I mean, I was going to say the same thing. Sriram talked about how they have been trying to use still older software engineering kind of theory in combination with LLMs, right? So, I mean, I think tool usage is something that is very popular with LLMs, and for a reason, because LLMs are not good tools by themselves. So essentially, in fact, Monica is here. So we basically just recently did this tutorial in knowledge reasoning conference, where we basically, I mean, more or less passed the message that LLMs are great, but they may not be great reasoners. So they can actually come up with really good outputs, and correct outputs don't necessarily mean correct chain of thought or correct reasoning in that sense, right? So I think, and therefore, a lot of people are actually banking on external logic-based systems or software engineering systems, so as to have LLMs define inputs for them and parse the outputs from those systems, but then, hey, depend on them for correctness purpose, right? So that's that. The second thing, of course, is that LLMs can't be like retrained every day. So essentially, I mean, therefore, therefore, we have to supplement them with fresh information. So essentially, when we brought up the Bing Copilot, it was not like just taking OpenAI ChatGPT and productionizing it. We basically make use of the huge amount of fresh and recent information that we have at Bing, so as to be able to pass it as extra context. Everyone knows that as retrieval augmented generation now, right? So LLMs by themselves, are limited. Therefore, you have to basically pass on that information from some external store to enable them to do that. And there is a lot of NLP left to do that, do there, right? So essentially, how to build those stores correctly. How do you take the latest that is happening in sport matches and somehow gather all that information so as to surface it nicely as extra context to LLMs. There's a lot of NLP which is still involved there.
Yeah, for me, I'll answer this from a different angle. So far I'm seeing LLM as a cost reduction tool rather than revenue generation tool, because it's not finding any business where it can generate revenue. So the addressable market versus it's actually operate on the addressed market. It's not creating an addressable market. Now, so we need to find NLP applications in that space, like where LLM can solve something that can bring revenue. And of course, like technically, as Manish was saying, RAG, and then following that, like knowledge graph, memory, and all these things people are trying to incorporate into LLM. Because if I want to deploy something in IIIT versus another institute, the terminology, the information, that varies significantly. Now, if we know that attention is a very successful technique, but what it is attending, if it is a general LLM, it's attending to every knowledge that is there. But if I specify that, okay, there is a knowledge which is specific to LTRC, triple IT, then that attention will be much more useful. Now, how this knowledge graph can be built, how that can be embedded into LLM, these are some space, even memorizing, like all those. So this is all, but in a nutshell, like we haven't found any problem in language processing which LLM cannot solve reasonably in its current state. And we haven't found any problem which can generate revenue because it's mostly operating on the space. Like I can summarize things if somebody pay me some, say that, okay, to use LLM you have to pay. I'll say I'll do my summarization on my own.
Yeah. When you were asking about benchmarks, I don't know if the academic community deliberately called it super glue, but we are certainly stuck in that. But yeah, so going back to your question about evaluation and the next steps, so to speak. Of course, we all are beating up on LLMs, right? And many of us in the audience may feel like, okay, LLM is the villain there, right? So we have to beat them up. But there's some power to these tools, and we need to figure out how to leverage that power, right? The classical AI systems had their brittleness. They had interpretability in the mind of the designer. So if an expert system were to fail, you would go and ask the designer of the expert system, what did it do, or why did you suggest it as malaria? Right? And there is a reasoning step behind it, and you can go and ask them. Today, we are trying to figure out if LLMs can do that kind of reasoning. And if it is, what is the error tolerance around it? So I think the future would be mostly around trying to figure out whether there is a way to quantify the error, there is a way to assure the user base. And simultaneously, I think the user base is going to become more tolerant. In the early days of speech recognition, people would quibble about, oh, you got that word wrong, you got that other word wrong. Not that ASR has completely solved the speech recognition problem today, but the user base is a bit more tolerant about errors. Now, the question becomes, will the user base in 5-10 years be tolerant about hallucinations, or figure out ways in which we can mitigate hallucination on one end, but also the user base saying, okay, I can understand, I won't trust this 100%. So maybe we'll figure out a middle ground where we can have a happy marriage to go about.
Great. Fantastic. At this point in time, I'm aware that we don't have the luxury of too much of time, but I would like to open up the floor for questions from the audience. So. You can take the mic from here.
Yeah, when it comes to benchmarking, what we do is, with respect to each business use case, we prepare the ground truth data set. Like suppose say, what is the prompt and what is the expected answer? We manually prepare it, and we will evaluate across the different large language models. Suppose say if we take 20 prompts, 20 answers, and we verify with all the LLMs and see which LLM is doing better. So it is very specific to the business use case, basically, not on the standard data sets, what we do usually. When it comes to the accuracy and latency, right? So what we are trying to do is we will collect the feedback and we will collect the prompt and the correct answers. Going forward, I come across Frugal GPT research paper where we see that some of the prompts are repetitive in nature. So what we do, as we have the prompt and the correct answers, so we do the sentence similarity, it almost matches the high, like 0.98 or 99, then we need not send the prompt to the LLM. So directly we'll answer it because we have the answer already. And sometimes what we do is we collect the prompt and the answers. We'll try to do the fine tuning. Then we'll see the sentence similarity is not matches. We'll go for the fine tuning. Still the fine tuning is also not works. Then we'll send to the LLM. So that's how we plan for our roadmap basically. Yeah, that's what I wanted.
So it's more of a comment rather than a question. So thank you. So if there are no more questions, then maybe we will close the session. And thank you so much for this enriching discussions, and really, really thankful for you making time for this event.
Thank you so much for the engaging session. I would like to call Dr. Swaran Lata to present the panelists with a token of appreciation. We'll now break for a short tea break. The tea is arranged outside, and we will assemble here in next 15 minutes. Also, the poster presentations are going on in the Alumni Lounge. So anyone interested can please proceed there in KCIS.
Someone which is
Yeah, but yeah, and my postdoc also is the same. So we chat almost every day.
Yeah.
Better. కొంచెం ఇలా రౌండ్ గా చేసావా కనిపిస్తుంది కదా Yeah. లైట్ లేదేమో లాస్ట్ ఇంకా చదువుకోవాలి
I would like to welcome you all after the tea break. So now we are going to have a panel discussion with our LTRC alumni on past perfect, future tense. So I would like to call upon Dr. Radhika ma'am, who is the moderator for the panel discussion. The alumni joining us are Dr. Prasad, Dr. Monica, Dr. Sai Ganesh, Dr. Divya, Miss Divya, and Mr. Bhavijit Singh.
So I request the students, can you call people outside to come in? Okay. Okay, this is the last event of this wonderful celebration of LTRC Silver Jubilee. As we always say, students are the pillar. Whatever the institute achieves or what the research center achieves, it's because of students and collaborators and everybody else. But students, to me, are the prime reason why we are here. And with that, the alumni panel, I think initially Dipti ma'am also had shared my 2 phases at LTRC. In that sense, I think I have a right to moderate this panel. So I would see it as some of you are from phase 1, like Prasad, and some of you are from phase 2. Within phase 2, I will also see there are 2 sub-phases. One is before COVID and one is after COVID. So we have pre-COVID people. So there is Divya, okay, and then we have post-COVID graduates. 3 of them are recent graduates. So we also have PhD students and dual degree students. So we would like to compare also how things were before and things are now. And I will also request if you have any questions later, you may ask them. So to start with, we had come up with this title, Past Perfect, Future Tense, for this panel discussion, because unlike other panel discussions, this will be more like a nostalgia, run down the memory lane of LTRC and your IIIT days. So normally when we think of past, we think of our good old days. So in that sense, past is perfect. Similarly, there is uncertainty in the future in every, so we say future tense. So past perfect, future tense, that's the title. And present, because today is a gift to all of us. So present is present. So with that introduction to the theme of this panel, I request each one of you to introduce yourself to our audience. You can tell your batch, your program, and what are you doing currently, and then something that you share as you entered this campus today. What made you nostalgic? You can share 1 minute each.
I'll start with myself. Hello, everyone. My name is Monica. I joined LTRC in 2018 as a PhD student. Currently, I just finished my postdoctoral research from University of Bonn, Germany. So every time I come to Hyderabad, I make sure that I'll visit my lab to rejuvenate myself. And I'm super happy to be here in person for the LTRC Silver Jubilee.
Hello. Yeah, so I'm Prasad Pingali, and I was the first PhD student in LTRC. I joined in 2003, and I passed out in 2009. And since then, also for a few years, I taught as adjunct faculty while I was doing my startup. But after a few years, I was not able to manage both the things, and I had to drop off after that, and then I continued totally working. So right now, these days, I'm more consulting in technology leadership roles, on and off. So that's basically.
Yeah, good evening, everyone. So I am Sai Ganesh Mirishkar. Currently, I am a co-founder and CTO of Voxverse. Previously, I was a senior research scientist at Sony Research Tokyo. And coming to Triple IT is always like a home. Like now, like it's like complete circle is full for me. So yeah, there are so many moments which I miss from Triple IT. Like we used to have a brainstorming session in the lab. Like it's not for just solving a problem. It's like how to think any problem being given by a professor. It is like peer-to-peer connection and mentors. Like there were senior people who used to guide us based on their experiences. All such things like we miss, but I think yeah, it's a full circle for me as of now. And it's and thank you for inviting me as a LTRC 25-year celebration.
Hello, everyone. My name is Divya Sai, and I joined Triple IT in the year 2012 as a computational linguistics dual degree student. Currently, I am working as an NLP data scientist in Shell Technology Center. And mostly what we do is I work in the knowledge management portfolio for Shell and their technical documentations where we could retrieve knowledge easily in an intelligent manner. Apart from that, the moment I entered today into this auditorium, again, the first person I saw was Vijay sir. And like I always say, I went back to my graphics class, that classroom that day. And just all those memories came back. And I should say that Triple IT kind of gave me that atmosphere where I discovered a part of myself. When I joined Triple IT, I don't think I was a person that I am today, definitely. And I should definitely say that Triple IT has played a very significant role in that, where I could openly discuss all my thoughts. Like Sai Ganesh has said, brainstorm, no matter what. So maybe today I'm not able to do that, right? In corporate where, every time if I want to brainstorm something about something, I think at least twice if this is a stupid question to ask. But I don't know why, but at Triple IT, we kind of never had those inhibitions. We were very open, and maybe I would have been a more shy person today if it was not for Triple IT. Thanks, thanks Triple IT, and also ma'am, thank you for inviting for this panel discussion today.
Hey, I'm Vijay. I graduated in 2023 as a dual degree student from LTRC and Triple IT. I'm currently working as a pre-doctoral research fellow with Microsoft Research in Bangalore. And yeah, so Triple IT, that is one thing that we were just discussing right now, all like me with my lab mates, that this place just feels like home. We can always walk in. I was so happy to see that my fingerprint still works somehow at the main gate. So yeah, so the place in general just feels like home. As people have already mentioned, we could discuss ideas, and we still have the same spirit. Like I just met my lab mates, and we were still discussing ideas and research problems in the exact same manner, like we were when I was there as a student. And the current lab students, the enthusiasm, the energy, everything is the same, and that's just great. And yeah, Triple IT is the place which has probably which has definitely rather got me interested into research. When I joined as an undergraduate student, I had no clue what research is right after 12th. But over time, somehow I've now realized that this is something that I would really, really want to do for like probably the rest of my career as well, or like the rest of my life. And that is amazing. Like that is something that I don't think I would have ever realized had it not been for LTRC and the professors that I've worked with and Triple IT. So, yeah. And it always feels great to be back. So thank you so much for inviting.
Okay, so all of you are in research now. Prasad, you too. Are you also in research?
No, I'm more into
Divya also.
startups. And
Okay. Yes. So I'll start our first question with you. What was that at Triple IT that made you think, this is what I have to do the rest of my life? Okay. Something that triggered you, each one of you. There must be some moments, right, which has helped you guide your future path as a undergraduate, as a beginner at Triple IT. There must be some movement, some inspiration, or something that helped you decide on your future goal. In your case, it must be.
no, so in my case, when I joined Triple IT was like another startup. Okay, to be honest, it just started. It was just a few years since it started, and when I came to meet Vasu, and he was leading the search lab, there were only 3 people. And out of that, Ponrangam was one of them. He was leaving just at that time to CMU, I think. So myself and Jagdish, we were the only 2 people. And we were allocated a corner in LTRC. So from there, we grew it as a whole independent lab with its own space and all that stuff. So it was, so everything that it takes to build a organization. So we were part of that. We saw that whole thing. So it takes people it takes resources, everything to be able to build a complete lab. So for me, it was like very naturally like a second home kind of a thing, because that is what I always love to do, pick new challenges and then grow it so that it becomes self-sustaining after that. Yeah.
Okay. Anyone else wants to share the aha moment while you were at Triple IT?
So one thing, what changed my life and what currently I'm doing is directly like it's related. So first of all, I should thank my prof, like Anil, like who helped me and gave an opportunity to me to do a project, which was a I think PSA project, pilot project, which was speech to speech machine translation for broadcast speeches. I think the intention was to transcreate Modi's Man Ki Baat from one language to other language. So like we had many challenges initially, and then the LTRC, like LTRC faculty, like I should name Professor Sangal, Professor Deepthi, and we used to have a regular meetings to solve the problem. Like there I realized, okay, to attack a problem, it is not just a solution. You need to understand the input nuances first. So like slowly again we were introduced to folks in Microsoft IDC Hyderabad, like how they are trying to solve with respect to speech to text and text to text and text to speech engines. Like that was the end goal, like what was being drafted in the proposal then. And then I met Vandan, right? So like the rockstar of current NMT, right? So like we have done crazy things. And like the current path what I am following in my venture current, it's also the same thing, like with respect to a real-time angle. Then I realized, okay, this is what will change the future, and it's a what I feel as on date is next 30 years LTR, I mean, language technology will definitely rule, because each and every modality, whatever, or the device, whatever we have or whatever we feel, speech will be the modality. First of all, you need to understand the speech, right? And coming with a geography, like as in India, most of them are convenient in their native language. Native language influence should be there. That's what Professor Deepthi has taught me in one of the SSMT lecture. So yeah, all such things. Yeah, then I realized, oh yeah, language should not be the barrier for communication. So it should be used even by the masses. So then I slowly formulated, then I have a clear path. Okay, this I have to achieve by whenever I hit 36 or so, 40. So I have some goals probably I might achieve. So yeah, that's one of the thing what I just wanted to share. And probably that's the moment.
You want to share?
Yeah. Yes, ma'am. So I think my moment is also kind of very related to what Ganesh has just said. So initially, when we started with the basic courses that we had, like C programming and data structures, I knew that they were foundation courses, but the moment we were introduced to courses like natural language processing, artificial intelligence, etc., that is when, while doing assignments, I have found something like there is no one straight solution to solve a problem. You can approach it from multiple angles. And that is where like I found my joy. Like, for example, I still remember we did an assignment for author classification when given a piece of text, right? So if you just follow some kind of pre-processing techniques, you remove all stop words, all kind of more frequently occurring words, right? And if you remove those, you will lose the style of the text, right? In which the author has a style. So I kind of understood that no, there is this pre-processing step, but you shouldn't take that as a golden rule and apply for everything. So at each and every step, there is a reasoning why you take a certain decision. So that is something I really appreciated. I wanted to be in that kind of a field for, I wouldn't say the rest of my life. Maybe for now, I'm at least enjoying it. But now what I also do is when we take R&D solutions like this, when we create innovative solutions, how to take it to productionizations and how that can sustain there. That is also something that I'm really interested.
I can go next. So during like my first 2 years, since I wasn't like a CLD student, I had no language processing courses specifically. So when I was looking to join a lab in my second year and get interested into research, I was reading across various papers. And one of the things from our institute, and one of the things which excited me were like some of the works around Project Angel, which had recently come out at that time. And I remember realizing that these are the things, like this is one area which had like fair real world, like direct real world implications, and at the same time required a good amount of like technical engineering skills or like research skills and modeling skills. And that is something which really fascinated me. For those who are not aware, Project Angel was about hate speech detection on online social media platforms and making them safer for particularly younger women. So I wasn't a part of the project, but that is what kind of inspired me to like go for LTRC as a research option. Then talking about moments in my particular research experience, which made me feel like this is something I would want to continue and do even after I graduate, were okay. So there's this time where like I was working on solving text generation for Wikipedia, automating Wikipedia articles. And one random day, ChatGPT got released. And we used to have these weekly meetings with Professor Vasu and Professor Manish and about our work. And I remember the next week, I had slides, and the title of that presentation was Existential Crisis. That what are we doing? What do we need to do beyond this? And like, is there any scope for anything to do for us anymore? And after those discussions, that week-long discussion of, okay, what's happening, that quick experimentation of like rerunning all the benchmarks and testing it out with those systems, I realized that while most of people around are busy in enjoying something new, there are like bunch of like 5 students in a lab sitting and trying to figure out where it fails and extensively figure out where it failed. And eventually we were able to find not one, like multiple options, like multiple scenarios where it failed. I won't go into those details, but that is when I realized that, okay, research is actually fun even when it hits you with a lot of problems, because the process to go through them is very collaborative, very intense, and very rewarding. And that was, I think, one moment where I felt like, okay, yeah, it'll be fun to continue doing that.
Monica?
So one of the assignment in NLP class was to implement word to vec from the scratch. So when I was doing that, I realized and I understand how the probabilistic model, traditional models, and how these word embeddings are important to get the representations. And I also played whether the representations of words changes with respect to the context, with respect to the surrounding words and all. So this made me realize and read a lot of papers like LSTM with attention and all. And also this exposure also helped me to fix my PhD research as well. So to implement all these representations from scratch for the Telugu language. And the aha moment is once the models are ready for the Telugu language, we did some automatic operations and we just projected how the results are. And for Telugu language, it performed very well. We are able to get all the semantically similar words. So we were so happy at that point of time. And for me, I did not feel anything that this is the rest of my life, but everything happened on the go. Like when I interacted with Radhika ma'am or Deepthi ma'am, I was able to get more and more information, which I realized that I should work on this field. Yeah.
Okay, so this is for Prasad, because you belong to that early generation. So at that time, we used to do all rule-based, basically paper, pen analysis of language, right? And today, students are very fast, right? Everything the machine is doing the analysis for them, right? So the output is the same, but I feel the understanding is where there is a, kind of a gap. People earlier really understood the problem and came up with a solution. Now you just have to write a prompt or something and you get a solution, right? So how do you see yourself from say the journey from rule based to statistical to neural network based, these approaches to analyze language?
Yeah, so I think if I remember it right, I was able to see that first phase from rule based to moving towards statistical slowly, right? And then the whole LLM kind of thing happened like at a very fast pace, right? But yeah, you are right. I mean, so basically what it demonstrates in some way is, and what you are also saying in a different way, is initially the humans were knowledgeable about the problem, which means the humans were more intelligent than the machines, and the humans were giving that intelligence. Now the machines are becoming more intelligent than humans. So basically, it is like the same problem we face with the calculator, right? So initially, people were memorizing the multiplication tables and all that stuff. These days, no kid goes through that process, right? So it's all, so you have the calculator. So you will, I think, in the future probably you will see a generation where they may not need a lot of these underlying insights. So the way knowledge is going to be driven is going to be just in time, meaning this whole, I think it will fundamentally disrupt a lot of fields, including education. Because education, this whole formal education that we go through, right? So learning things from basics, foundations, and all that stuff, because the knowledge pool becomes so vast, now everything becomes just in time. Like, you cannot afford to spend 4 years studying something. It'll be, okay, I'll spend another 1 week, 2 weeks. I want to quickly know everything that will help me to do this NLP project. Okay, so the whole paradigm is going to be shifted, that way. And this is going to be true for not just language processing, but any other field due to AI, right? Whether it is programming, whether it is investing, or any type of skill set that you want to pick up. I think it's all going to be just in time. You can gain expertise. So I think it's a very brave new world the next few years. I think a lot of things that we are used to, the traditional way of doing things, are going to be completely reinvented. It's going to change behaviors, a lot of things. Yeah.
So I would also see it, so earlier, the traditional ways, they would keep away from all the modern things. Just like, in our houses, traditional conservative people would like to have their dosa and vada batter to be done by hand, right? Today we are going for all the blenders, electric appliances. So those people still say, but handmade ones are much tastier. Okay, so this is how it is, so students, if I even ask my children, multiply 13 into 13, they're like, why should I do a mental calculation when there's a tool that will tell me, right? And so there is always this resistance for something, and that is where you see the generation gap, right? Now, I have one question. So your supervisors belong to the earlier era, right? And you belong to at least Monica and Sai Ganesh. This question is for you. So, were there any times you felt you knew more than your professors? Your professors are here, but it's okay. They all are broad-minded. Were there any moments you thought, I know more than my teachers?
No, like frankly speaking, I didn't feel so because no, no, being frank, I didn't feel so because like to just answer in a one line, uh, Professor Anil was my younger, elder brother who used to give me suggestions. No, if you do this way, you are going to fall in this trap. So you should not. I mean, see, it depends on how we converse. How we converse. If you converse in a wrong way, that will lead to a wrong direction.
You already
But
got your degree. Don't worry.
no, no, no. It's not. No, no. It's not about being very frank. Most of the discussions went through a conversation. At one point of time, I felt like no, no, probably I might be right. The next day morning, sir used to come up and show, no, see, this paper is already published. So no, try some other method. So what I feel is um, they are just showing us a path which will lead in a shorter way, right? Which will lead in a shorter way where you will learn too many things. If we choose this way, you'll go to the result, but there won't be any byproduct of it. So yeah, that's my answer.
Yeah, Monica.
I'll try to answer this in a lighter note. Let's say I'll go to Radhika ma'am or Deepthi ma'am and say, I know this ID batter or some other branded batter and all. Then they will say to me, yeah, these batters are all fine, but I know how to make homemade batter. I mean, we may know the names of the technologies and all, but definitely they will give us the way how to implement these technologies, whether we are going in a correct direction or not, like what linguistic information we need to have and all those things. So, yeah.
Okay. Okay, at least we groomed our students to be politically correct. We are proud of all of you. So, one question I would like to say. So, my own experience was that I did my PhD in 90s, and libraries were only the source of information. So, University of Hyderabad, then maximum you go to FLU or Osmania University and that's like 1 day journey kind, go and come back. But today you have access to information, and but the downside is there's lots of information, right? Too much of information is also overwhelming. So again, this comes back to you. Do you see the PhD these two people have done recently compared to the PhD you have done earlier with lesser internet access, and we did not have smartphones. Now everything, like even to take a printout, I'll share this. When I was a PhD student, we would give a printout to the line printer and go and have tea. When we come back, the print would be ready. Okay. Today, of course, we don't even need a printout. Everything is in a handheld devices. So do you see the current generation have an edge over your time where access to everything is so easily available?
Yeah, absolutely. I mean, Definitely, there is a lot more tooling available, lot more support available for the current generation of students. And that is true not only for my generation, maybe you go back further, right? So that is true as a continuous trend, if you look at it. And probably that is also needed because the nature of the problems are also going to become more and more challenging. And hence the time that is available for you needs to be more efficiently used. And hence you need all that tooling. Otherwise, you will not be able to compete and actually deliver value uh, at the end of the day to push the state of the art. So this is how I think about it. So there is no doubt that that trend is still continuing, and probably it will also continue further, right? Maybe it will even go to an extent where the machines will start generating the research hypothesis. Maybe all the initial work is already done. So maybe the human's role gets more and more diminished. So, but ultimately, the nature of challenges also are going up. The nature of problems that you're dealing with, which previously were thought to be impossible, are being made possible these days. So hence, that kind of tooling and assistance in research is going to be needed.
So I'll take a different shift to this. When we are working and you meet other research groups, right? So there is a certain kind of cultural shock or certain kind of inspiration this other group gives, right? We had that at University of Hyderabad when Akshar Bharti group came to us. We were like, we do little bit of research, little bit of fun, but Akshar Bharti group, Sangal sir is here, Vinny Chaitanya ji, they are like, they just work without breathing, they work. So that was my first exposure to a different kind of work culture that I was exposed to. So similarly, I will ask, this question is for Divya and Monica. You had your own internship, postdoc experience abroad. So can you throw some light on this experience you had with research groups, how they are different or how similar they are to our work culture? Can you share your experience?
Yeah, so I think it was in the year of 2016. I had just finished my 4th year and I had this opportunity to go for a summer internship at Language Technologies Institute, Carnegie Mellon University. First of all, I was very excited. Then when I went there, one good thing there was that they very well recognized the work that LTRC has been doing, and they are very much aware of what is the culture of LTRC, and then it was a very warm welcome for me. But something that's different is that when I went there, we were working on this project where there were people from multiple disciplines. So here, when I was working in the lab, I had like mainly 2 sections of people. One is from the linguistics department, like my guide, Professor Deepti ma'am. And then there were others from the statistical and other lecturers. But then when I went there, I saw that there were people from psychology department, there were people like behavioral sciences, right? And then there were people coming from mechanical engineering background and so many different backgrounds. And they were all coming together to work on a project which was called Socially Aware Robot Assistant, where at that point of time, it was trying to do some kind of, based on how you speak, analyze the rapport between the machine and the human being. And how all these things, so first of all, when you work in a team like that, because I was not used to that difference of backgrounds, for me, it was I should say it was a learning curve where I had to convey my technical ideas in a very non-technical way as well, and the other way around also to some other people. So here everybody understood, right? When I was working, I didn't have to put so much effort. So that's one thing there. And then also, I think with these different kinds of people, you, like I already mentioned earlier, one problem, so you think of only one side of things. I either, because I have that linguistics exposure and statistical exposure, I look at only from that angle, but somebody else will come in and put in the psychology aspect, and look at from that side also. So I would say there's a lot of learning, skill development. Definitely when you're working with a lot of people, we had to learn a lot of new things. So at that point of time, we were not very well versed with GitHub or anything like that. But since we were developing a product, though I was an intern, I had to pick up things very fast. That's one thing. And as a byproduct, ma'am, I would say that that increased a lot of confidence in me as an individual. And when I came back, I've been thinking how to, when I get some things and incorporate it in our own lab. Yeah, that has been my experience.
Monica?
I'll 100% agree with Divya. So coming to my postdoctoral journey, I did my postdoc in University of Bonn, Germany. So the goal of the project, which was assigned to me, was to develop a data set for stance and dogmatism tasks. So generally, we know that we used to do stance for a post, that to which limit to 300 to 400 characters. But here I need to do for the entire Reddit conversation, which is a year long or maybe goes to 2 year, 3 year long, which is having like more than, each user is having like more than 590, 600 comments, and very, very lengthy, like one paragraph, one page comments. So with my knowledge, initially I started the human annotation. I almost spent 5 months of time doing human annotation. I only have 1 year, 2 months time to finish that project, but it is not working. So then I quickly realized, why can't I use LLMs as human-like annotators to do this task? Because it's very complex task and humans are unable to do it. It's like reading the entire user history, identifying stance for each post, and dogmatism for the entire conversation. Then I wrote the prompt, and using the Mistral Large as well as GPT-4 models, I was able to achieve the on-par performance with the human annotation. In the last panel discussion also, Manish and the people from the Microsoft also told that they're using LLMs as annotators for the tasks which are inside the Microsoft. So I think I also have done the same thing. And we got some reviews at NeurIPS, some raised ethical concerns as well. We addressed them. So it's like a good learning curve for me, and the things that will work for Indian languages may not work for other languages. Sometimes we need to do things very quickly. At that time, definitely we can use LLMs. But one thing I can say is we need humans in the loop to do the evolution. So I also used humans to do annotation for the 200 smaller conversations, and we evaluated it using the LLM annotations. Yeah, this is what I have done there.
Good. So each one of you have, it's more like, Triple IT is a home and then you go out, right? Same worries we also have for our students. So Bhavyajit, this question is for you. So you moved immediately to industry, right? So how is NLP or anything that you learned here, how is it helping in your current role? And what challenges do you face in real world applications?
Okay, so yeah, my current role is again that of a research fellow. So apart from the technical concepts, even the general know-how and that entire journey of a research project that I had already done here for my like master's thesis is something that has been like very, very helpful in my day-to-day job there. More than that, coming on to the second part of the question, which also includes like the technical things from here, which are helping me around, and challenges in real world NLP. So for that, to give a brief background, I'm working on improving retrieval and recommendations for low latency constraint settings, right? Now, something that has been different from what we were doing at Triple IT is that it's not just the results that matter, it's also a huge trade-off of results versus the cost at which those results come, which is what matters. So, for example, because it's like somewhat product-oriented research, if we are giving a 5-point gain on a particular metric, but with say 50 more GPU hours or 50 times the GPU hours, then that doesn't matter. However, if the same then that's not a good research solution basically as per those standards. But if I could get the same gains with like say the same compute requirements or at least 5 times the gains then even the compute goes out of the window. So that is something very different, where the constraints move with respect to what you come up with, and how, like, you have to analyze that trade-off for every solution that you think of. Whereas in triple IT, we used to just thrive for like the best possible solution in most cases. Like how do we get the best possible numbers, basically, if it's a number task, or like the most reliable solution, and so on and so forth. Secondly, in terms of the technical things that I learned here, I feel the concepts are very similar, even with all the new things that keep coming up, and we have been having these discussions. The backbone of a lot of things, at least in a window of like, in my window of like last 3-4 years, hasn't changed too much. Even when I was at Triple IT, we were working with transformer-based, attention-based standard models. Over there also, I'm using the same models, just under different settings, different constraints, and so on.
So, Prasad and Sai Ganesh, so with all this latest LLM and all that, how do you think it will affect your role in industry, or vice versa?
I think one of the panels, previous panels, they also talked about that LLMs are not yet revenue generating, so it's like, but they are more into cost cutting right now. I agree, but one thing that is definitely that we are going to see is there are going to be a lot of productivity gains. Okay, so productivity gains directly or indirectly translates into reduction in human resources, for sure, right? So this again, like, would happen at varied percentages in different industries. Like you already mentioned, like the machine is able to annotate better than human beings on my research task. So that is going to be true for so many other types of tasks, whether it is programming, whether it is content creation, or even strategy making, so many types of things. So this is going to be disrupting in a way of reducing human labor. So what does that mean to people, youngsters who are now going to come into the labor market? It means that, I mean, it should be viewed as an opportunity, in my view, because now probably is a better time to think about value creation as an innovator or as an entrepreneur than as a job seeker. I think the next generation, probably we are going to be seeing this more often, that a lot more people will be ending up doing their own startups, because the cost of doing the startup is going to come down because of these type of technologies. So the amount of people that needs to create $1 billion company, if you look at it historically, has been coming down. Okay, so initially it used to take hundreds of people, then 100 people, then WhatsApp was sold for $16 billion with 15 people or something like that, right? So the number of people needed to build a high impactful application is going to come down because of these type of technologies. Because if somebody has a very innovative idea in future, they don't need to build a large team around them. They probably need 2-3 people, and they will be able to very quickly go to market and disrupt some industry and generate valuation. So I think in future, a lot of people need to learn the skill of being on their own instead of depending on somebody to give a job to them.
Sai Ganesh, you want to add to that?
I have a slightly different opinion. So what I feel is AI is another technology, first of all. Like, so I would just quote from yesterday's Dr. Sriram's things. Like, he has quoted a very beautiful example of a customer service, what they have deployed, right? So the point here is like, like if you're talking to any customer agent, say it could be an IVR or something, if you deploy an LLM, right? So there's a chance of hallucination or something. Like for enterprise, it is a different ball game. You need to fine tune it for for such use cases. Number one. Number two, it should be real time. No customer will wait for a longer time, right? It has. So what I feel is, like no customer will wait for a longer duration, right? So everything has to be real time. For that, such data is required first of all. See, what I feel, this is my opinion totally. The LLMs currently have mimicked language, but it couldn't mimic human thought. So it will take some time to mature. Number one, whatever the vertical you take, I mean to say the contact center or education domain. If assume there are a bunch of people who don't understand English properly, who are convenient in their native language. They want education in that particular thing. So can we give a personalized content to them in their native language, in their accent or something? Such things still require certain maturity. It will take time because of lack of availability of data, or there are a number of things. So yeah. So it's like something like a human is required. One liner is a human is required in between. Directly we can't expect an end-to-end just talking to a bot as of now, like probably
You want to add?
five to 10 years.
Just one example, ma'am. So I agree that from the time that LLMs have been around for some time now, but I think from the time that ChatGPT has been announced, because it's so beautifully packaged and everybody can use it, right? From that point of time, we have seen that the penetration of Gen AI and LLMs itself has increased, but I don't think it has reached a level where maximum, or at least if you take India, right, majority of the population is still not, they're not using it, right? We don't have that level of products. Like for example, in the morning, I think Professor Ravi was showing an example where there's a picture of Hanuman's idol, and then there's a description that is generated in English, and that English is then translated into Hindi, right? So that element is bringing that inclusivity where Gen AI and LLM technology can reach maybe somebody who doesn't know English or cannot understand English. So I think historically, I think we have been trying to see what are the technologies that exist, try to understand those technologies and see what we can solve with them. But now we should I think we should start to find problems. What are the problems that are there and how we can bring this inclusivity? If there is any technology, how can we bridge that gap? I think that is where maybe the current generation of the students can think more on.
Okay, with keeping the time in mind, we'll just do one round. Okay, very quickly, one advice to our current students. And along with that, first part of your response should be, how will you see LTRC in next 10 years? What is your expectation? And what advice would you give to the current students? So we'll do this quickly, okay, starting with Monica.
Yeah. So in earlier years, let's say if we are working on an NLP task such as sentiment analysis or hate speech, if we get better accuracy or if we do a better error analysis, we used to publish a paper. But now the things have changed and it changed very rapidly. With this, lot of researchers also thinking what has already been done and what needs to be done. We also need to work on solutions in an end-to-end manner. We need to work on things like interpreting the LLMs, like why, what, how, like behavioral, representational interpretability, and mechanistic interpretability. And also think like this. We have only one brain, but we used to understand sentences, images, videos, everything, sign language, and all. So we should think of developing models like this and also evaluating these models. I feel the end goal is to get a model which is like a human brain. So we have a lot of possibilities in neuro AI field where this linguistic information is needed, and also a field called human AI alignment. We can work on these things. And I strongly believe that these days people from other domains like speech as well as image vision people are also coming and working in NLP field, which makes everyone to have the breadth and depth knowledge of our field. And I strongly believe that LTRC will be able to capable with the advancements of this interdisciplinary research. in the next decade. Yeah.
Yeah, I think LTRC should start thinking more in terms of finding problems which are locally relevant, fundamental, and which are grand challenges. I think annotation projects were definitely of that nature, right? So multi-year, and it needed a lot of effort. So in the current scenario of things where we have a lot more tools, lot more automation in place, given that LTRC has such a large pool of human resources now, I think a large number of people now are more from technology background than linguistics and this type of background. So we should start thinking of making the problem size bigger, choose bigger problems which may be locally relevant, and then build systems around it, like a proper program or a product, right? So that it becomes a multi-year, it'll have a life of its own, and people will be able to push the state of the art, and they will also be able to easily be absorbed in the industry, because they are not focusing only on the language aspect of it, but they are looking at it as a grand challenge. Now, what those challenges are, I'm not sure. Probably some discovery work needs to happen. Maybe somebody needs to do some kind of work in the field with users. Some kind of background work needs to happen, or it could also be a continuous process. I think even in US, a lot of universities like this were the genesis for some of the fundamental work that finally led into these type of systems, right? Whether it is LLMs, or whether it is automatic cars, like self-driven cars, or a lot of groundbreaking disruptions that happen do not happen overnight, but they were part of a very long duration grand challenge. So I think if LTRC can come up with some challenges like that, which seem to be impossible on the face of it, but if you start working on it from now, maybe over the next decade or maybe few generations from now, will make some reasonable impact.
Good. Yeah.
I think most of the things they have answered. I would like to add, two things. One is real-time aspect in industry. Like if the model size is very big, right? They won't encourage for a deployment. It should be literally optimized. Like if it's 5 GB also, no. It has to be something which fits in their infra, and they try to see the operational cost should come down. So I think real time, then definitely it would be very fast, the inference will be very fast. That's one thing. And second one would be, anyway, like I think in LTRC every group or other group, like they are working on low resource constraint. These two I would just like to add.
Any advice to our current PhD and MS students?
Okay. I would like to borrow a quote which Professor Anil used to regularly say to me. So, research is a movie, right? It has to be planned, executed, and it has to be accessible even to the lower pyramid. Then the paper or like whatever you build or whatever you do, then it would be a fruitful. So I think this thing, I follow regularly this. So I think it is better to follow.
Yeah.
Yeah, most of the things they have covered, but what I would also say is, I think like multi-modality, multi-modal Gen AI models are the future. But then I think as the modalities increase and the types of features that we process increase, the explainability kind of decreases a lot, right? So I think it'd be very good if we, as LTRC as a lab, if we can focus on that explainability part as well. The goal should be towards fairness or transparency in the models or on ethical grounds. So if we can bring in that aspect also, I think along with excellence we will achieve the other value system part as well. And then my advice to the students is that because this is an advice that I give to myself, I get like really anxious when a new model comes in, a new Gen AI model comes in, right? So every time it's such a rapidly growing space that even if you run constantly, I don't think you can catch up with that pace, right? So I would say don't try to learn everything. And when you try to learn everything, you give like a limited amount of time to it, but make sure whatever you're interested in, make sure you have those fundamentals very strong. But tomorrow, something might come up, but like, if it is based on the transform architecture, you need to know what attention is. So that is something that I think you should get your fundamentals very right.
Yeah, so I'll start with the advice question first. So at least for like dual degree students and like young researchers, right? People who are trying things during their undergraduation, it becomes very easy to get distracted by the incentives or the outcomes of research rather than the research itself. So I would strongly recommend people to like pick harder problems, pick more foundational problems if you're truly interested in like what you're doing, because that will be way more fun and way more rewarding. Don't don't say sacrifice the quality of the solution or the quality of the problem itself based on external factors like timelines or anything else that you want to optimize for in general. And yeah, I know it's like easier said than done, but yeah, that is something that I would recommend. Secondly, for LTRC, I feel like as a lab, we have done a great job of keeping up with things that have been like changing rapidly, and all of us have been talking about all that. That would certainly be something that I would see. I would want LTRC to keep on doing, because I'm like all of us now, after everything that we have listened to today, are pretty sure that a lot is going to change, not just in a decade, but probably in the next 3-4 years itself. And while it's very hard to predict where those directions of change would be, it will be great to just be open to accepting those changes, whether they come in the form of multimodality, whether they come in the form of uh, mm, completely alternate architectures and so on. Lastly, I feel that it would, which is something that has been already said, even for LTRC, I would really love if we, like the lab and us, we could focus on like more foundational problems, uh, which have a regional impact, but at the same time have a much broader impact to the general like public as a whole beyond certain regional aspects as well. While like the regional work is great, but those would also be very like interesting tasks to focus on.
Yeah. So again, with interest of time, we can just open it for 1 or 2 questions only from if our current students have anything to ask the panel members. Anyone? Okay. Okay, I'm getting all. So thank you very much. Embracing change is and has been the motto of LTRC. We are expanding, and in the expansion, I also see the walls between, say, speech and NLP lab is also thinning. There will be Vasu has been talking about this. This is only one floor, no labs within LTRC. I also see. CVIT, which is on upper floor, that gap also is thickening. Only thing, we don't want that our ceiling to fall down. but vision, speech, text, this multimodality, I think, is the future for us. With that note, I thank all the panel members. We'll be continuously in touch. Thank you and all the best for your future endeavors. Thank you.
Thank you.
Thank you, Radhika ma'am, and thank you to all the alumni to share their views We really enjoyed it. I would like to invite Vasudev sir to please present them with a memento. Yeah, we also have gifts from the alumni cell for the alumni. So, yeah, that will be a token of appreciation from our side.
Yeah.
So I really thank, this was a very warm gesture from our alumni committee. Thank you very much.
As we proceed to the closing ceremony, I would like to call Professor Vasu for the felicitation and vote of thanks.
Okay, as the celebrations come to an end, what do we do? Precisely. So we start preparing our ground to start the next celebrations. That means you have to do enough work so that the next celebrations are. So I would like to mention just a few things because we are already pushing the day. So one important thing is we started this as when we're planning this event, we thought we'll have a half a day event where we ask everyone to come and then do a little bit of a story of LTRC and then give some mementos and then flowers and then leave. But then later it turned out that's not the real celebration. The real celebration is about creating more discussions, conversations about the field that we are passionate about. So from that spirit came this 2-day program, which we believe that it is of very good quality in terms of, and also utility wise, something that everybody should be benefiting from, not for just those who attended online these and in person these 2 days, but for many years to come. So the advantage of the era that we are living in is anything that we say, we create carefully, that will stay forever. Google never forgets anything, right? So this is something that we wanted to create, something that is worthy of not forgetting. So thank you so much for all the panelists, all the speakers who have been here having such wonderful conversations in the last 2 days. This is also the time to think about how the next decade or next 25 years should be. That conversation has started in a small way now, but then this should continue for a long time. And then for that purpose, we would like all the real stakeholders in this game, the alumni. I mean, if you see, even for the most technical content, the majority of the contributors are our alumni who actually went from this particular lab, made a lot of difference in the world to this field. So from that point of view, even to shape the future of an organization like IIIT Hyderabad or a research center like LTRC, your role is critical. So that is the main message that I have today for this closing ceremony. Please continue to engage with us and then continue to advise us and then make sure that the future generations will get better training and better learning environment than what you got. So that is the criteria for success for all of you. And I also would like to use the metaphor PJ and often uses, like universities are like water bodies. The water bodies need to be nurtured. The water bodies need to be fed continuously with fresh rainwater so that the groundwater levels keep increasing. In today's world, there's all the reasons why the depletion of the levels is happening. That's the same thing even for for educational institutions. So today morning, the discussion from PSA in terms of the need for establishing an environment where scholarship is celebrated. So such conversation should happen, such awareness should be enhanced. So that is where we would like to play a major role with everybody's help. So given all of this, so again, what should be the future of LTRC next 25 years? This discussion is something that we will start very soon in various forums, various shapes and flavors. Now to come to the formal closing of this, again, as Professor Deepti mentioned in her inaugural journey remarks, that there are people who have been with us since the beginning when Akshar Bharati group moved from HCU to here, and then they've been part of this wonderful journey for a long time. Not just those special people, but also people who have made immense contributions with lots of their hard work and then lots of dedication, and to for whom the work was worship. So that culture is something that is seen in LTRC from these people. So I would like to now invite Professor Rajiv Sangal to basically start kind of thanking from our bottom of our heart and also recognizing these contributions that have come in. So first, I would like to call somebody who has been here since this journey, and then all the knowledge that he gained through his experiences in LTRC in serving the institute, Mr. Rambabu. At some point in time, Indian languages work was synonymous with Rambabu. People may not know who are the faculty members or who are the the researchers who are working, but everybody knew Rambabu. So that was the So now with equal dedication and with always a lot of patience, Srinivasa Rao has been always around to solve all the problems that with the machines and everything else. So Srinivasa. So another very, very important person who has been there, not, even now, without him, many things will actually stop functioning. So that is Lakshmi Narayana.
Wanted to mention, and Professor Arvind Joshi was, he visited several times, and, he says, can I take them to University of Pennsylvania to run my office in the Department of Computer Science there? That was the dedication, that was the, the kind of work, their work style, their work methods, which sometimes, we don't realize because we see them every day, but that is the kind of dedication which is there. They actually joined us in 1996 when the Anusaraka project and the Akshar Bharati at University of Hyderabad, and when we moved, they moved with us. Thank you. Thank you to all three of you.
So we are very fortunate to work under the eminent leadership, eminent world-class faculty. And thank you for this felicitation as well. Thank you so much.
That I want to take a moment to thank everyone for honoring me. So happy to witness LTRC growth since day one. And I am truly grateful to be a part of LTRC family.
Thank you very much.
Faculty who they are also part of language.
LTRC.
But not just these three people. I would also like to acknowledge others. There are many people who have contributed during this journey. Kumar Swami, Namrata, Ashwini, Nanda, P. Kishore, and so on. But then there are two other people who are here today. Mahender, Mahender, please come. So Mahinder is very well known for his complete dedication to the work. And then anything that is given to him, consider that it is done. So that was the dedication. Thank you so much, Mahinder. And also Satish. Is Satish here? Okay. If not, we'll convey our gratitude to him later. So, but these are the people who are the real builders, who are actually the pillars of LTRC. And irrespective of non-cooperation and irrespective of mood swings of faculty members, these are the ones who have put everything together. Thank you so much with all our heart. Thank you so much. You're not thanked enough explicitly, but you'll always remain in our hearts as somebody who have made this center. Thank you. But then obviously the journey does not end here, right? There is people who carry all the burden on their shoulders. And today, this entire LTRC is being carried on the shoulders of Praveen. Again, this is the new Rambabu of LTRC. And Praveen, please come. Please come here. So, Praveen's desire is he should be felicitated during 50th year celebration of that. We will certainly do it. But then we cannot resist but to thank in a small way that all the work, all the great thing that you're doing, and thank you for your dedication. Thank you for your proactivity. Thank you. So in addition, there are several sponsors, several organizations that we worked very closely with. And then we don't have all of them here, but then at least I would like to acknowledge a few names. First of all, one major supporter for LTRC, not just with money, but also with the moral support and all the encouragement, is Ministry of Electronics and Information Technology. So I would like to really thank them, but most importantly, Dr. Swaranlata, who was here. Okay, so we'll specifically imagine the kind of attachment that we had after even retiring. When we told her that we are celebrating this Silver Jubilee, she came all the way and they spent almost all 2 days with us. Thank you so much, Swaranlata ji. Not just that, but also other governmental agencies that have helped us. But not just government, we also had a lot of interactions, very fruitful collaborations with the industry. So TCS has been continuously great supporter from the very beginning, not only in terms of money, but also in terms of ideas, in terms of adopting the technologies that are developed here, giving us feedback, co-organizing the programs and so on. So TCS is actually very well known to be a very benevolent organization, and and also providing us the Makan, the KRB that we are all part of this one. So Sirish is here. Please come. So Sirish will now be representing the entire TCS. So it is so Professor, I again request Professor Sangal to come and
the journey continues. Even today, we have many current employees getting trained here. So the gratitude is mutual. Oh, thank you. Thank you. Again, I would like to call upon Balaji,
who's representing Adobe. And Adobe also has been quite a great friend of IIIT Hyderabad and helped us in many ways. And we're all hoping that Sriram Rajamani will stay back and receive this token of appreciation from us, but unfortunately he left. We will give it to him separately. And yeah, so those are the things. But before we end this event, I request Professor Sangal to reflect on this event and also the path forward for next 25 years.
I think this event has brought many memories. And, sometimes we underplay the emotional aspect. There's the intellectual aspect and the emotional aspect. So the emotional aspect that gets nurtured through our memories, through our relationships, I think it's very, very important. And while there have been very good ideas and sort of an impressions about where technology stands today and what are the challenges and so on, I think it's both intellectual from a very impression point of view, which is sometimes leads the final conclusions by several years. So that has been there in terms of what we are feeling. But at the same time, the emotional part, and I think it has been a great journey. And it is everybody that makes it fun, that makes it enjoyable. And I think that part needs to be conveyed to our students. And there is joy in work. There is joy in working together. And I think thank you.
So this is time to thank everyone who have contributed to this wonderful event. First of all, I would like to thank Professor P.J. Narayanan. Not just for paying 60% of the bills, but also being such a wonderful supporter of not just LTRC, but every center here. But also for, very few leaders have the kind of emotion, the mindset to be in an event like this for 2 days. And then that is the encouragement that is unspoken. So this is what inspires people. So thank you so much for all your support and all your leadership. There are several divisions within IIIT that have made this event happen. From the outreach, Ramesh, Padma, they all helped in spreading the word. And Meenakshi and alumni team actually helped quite a bit in terms of spreading the word to all the alumni and then making these connections. But I would like to emphasize communications team's role here. So they've been such a great part of this whole planning, and Sunori took personal interest, and then she been there in planning the communication strategy and also executing it, and then such a great turnaround time in terms of getting the number of times that we change our minds and the number of times speakers change. And this is a very dynamic world, an event of this kind. So Babita, Sunori, and other members of the communication team has been so wonderfully helping us throughout this. So, and Sirisha and the entire GAD team, Srinivas, Ramana, Manohar, Shailaja, all of them have been providing lots of support in the logistics side, and the special thanks to all the housekeeping team and the security team. Thank you so much, all of you. And most important thing for such a event like this, where there are people participating technically, and then we have this the wish list, unending wish list of having AI companions to be part of the Zoom recording and then live streaming without any interruptions. When you have such demanding organizers, surviving in this environment for an IT team is very, very difficult. So thank you so much, Srikanth, Mahesh, Lakshman, for playing such a major role, and others who are part of this, this whole endeavor. You've been working very hard for last several days. Thank you so much for all your help. And one important thing is the role of volunteers. So, I mean, I really don't want to thank volunteers because they're volunteering, so they don't expect anything from this. But then there's a lot of things in store for you. One is, of course, this event itself. Hopefully, you gained a lot from all the speakers, the entire proceedings. But at the same time, the mindset of actually giving something without expecting anything return, hope that will remain in you, and then you will be able to kind of provide more and more support in the future. But that is for the formal thing. But actually, there is a great after party, after event party. We will be, we'll have fun. And the mess team for providing very good food throughout. And thank you so much, Saidalu, Srikanth, all others who are part of this. So all the speakers who have come, all the way, and then more importantly, all the organizing team members who have kind of coordinated with everybody, all the participants, all the speakers, and making sure that everything is done very well. It's a great team effort. And then we enjoyed the process of creating this event and then executing it. Thank you so much. And then we will keep the conversations on. And then we'll actually keep taking your advice to make LTRC even much better place and better environment. Thank you.
I think thanks to Vasu for conducting this so beautifully. Thank you.
So there's a high tea. Where is it arranged? Outside? It's just outside. Please fill your stomachs and then go home happy. Thank you.